Test, test. All right, I want to thank everyone for coming. We're starting off the OpenSUSE Summit today, and we'll be in here the entire day with various different talks. And I'd like to start off the summit with Harry Schoen, and he'll be talking about,
Oh, I don't know, this button.
network boot. And if you have any questions, please come and talk with me, and if you registered on events.opensuse.org, come please see me later, all right?
Okay, I can't control the this is not from my notebook, this is the site or whatever, or so this is my presentation. I did want to post up the abstract again. So my name is Harry Schoen, I'm from Intel Corporation, I'm part of what used to be the UEFI team, or the team that actually built and constructed UEFI back since the early days of Itanium. And this session talks about really network boot, how we do network boot in UEFI. So we'll talk about this in detail. Switch back to the presentation here. So this talk is sort of our push to talk to the open source community on using the network stack that we've put inside of the firmware. That should show up in most of the PCs, both server and consumer systems that you have these days. We've had the code out there for quite a while, so we would like to evangelize and get out into the public or the open source community to get off of the old PXE boot or network boot constructs that have been around since the early PC days and move over to our network stack that we've made available on Tiona Core and has been available there for a very long time. But trying to get the open source community to come out and actually use this. So there's a variety of reasons why you may want to use this particular network stack from the pre-boot space, and we'll cover that in the talk here. So as part of our agenda here, we want to go over the current state of how we network boot from pre-boot space or from firmware space today. What are the limitations with that legacy model? We'll talk about the more modernized UEFI network boot, how that works. The basic network stack that appears in the source code and then a spec. And then some use cases of why you may want to use this. There's some both security and functional aspects of why you might want to use this. And then a call to action. That's the reason why I'm here, is to try and get the open source community to come out and actually utilize this network stack in the deployment of your Linux distros and server software, whatever particular OS or backup software you're trying to write. So my role in this typically is to evangelize with the open source community and try and get people to both educate and use the UEFI API interfaces in actual products. So reaching out to the developer community to get them to pay attention to what we put in the UEFI specification on UEFI.org, and to also get you guys to actually working on real open source projects and code to actually utilize what we put up on TionaCore.org in the EDK2 project. So we'll first go over a list of the current state of the art, what's in shipping out there today, what you find in the typical server. There's server systems and your typical client consumer systems that are out there in the market today, and then move on to the stuff we put into UEFI. So this is sort of a history lesson. The current state of what the industry uses today is something that it was invented at Intel underneath the wired for management specification. So originally PXE boot was designed by IAL, part of our architecture group, to put another network connection into a system, a server or enterprise class system, that would give you a back-end connection into the system, so that if you booted to that connection in the system in a private network, that you'd be able to deploy the OS, bring a bare metal system up from nothing, nothing on the storage, nothing in the system, to having an OS or whatever firmware or software you wanted to deploy that system with. So in the early days, there was typically a NIC card. Intel makes NICs, right? You would plug that into the system or lay it down on the LOM, and be able to boot to your private network connection in your enterprise or your data center, or in a private network to deploy the system. So the wired for management spec was released out in the early 90s to the manufacturers, OEMs in the PC industry, and people have been making these 16-bit UNDI option ROM NIC cards for years. You still see that today on a lot of the NIC cards that are out there for x86 and PowerPC and other architectures. So that's been around for a very long time. And all the infrastructure that you see today uses this to boot. A lot of the cloud computing still has deployment software that uses this legacy PXE, what we call legacy PXE, 16-bit option ROM code that your PC runs. On your typical PC may have a special key in your BIOS, F8 or F10 or something like that. So if the physical user presses that key while you're booting and through the BIOS, then you come up and launch that option ROM that was dispatched during post, and then start that network stack and boot to that. So your local BBS or your BIOS setup will say there'll be a network boot option which boots PXE in the system. Now that requires some infrastructure put in place. And this is a typical setup you'd have on your little private network. There'd be a DHCP server that you have to configure specifically for PXE boot. It has to advertise where the PXE server is on the network, and also advertise the architecture type of the network boot image that you're going to post, whether it's i32, x64, Itanium, or ARM64, whatever it is, that needs to be in the DHCP packets to notify the target boot device when it asks for IP address what is available out there if you're going to PXE boot. There's also the PXE boot server, which you need to deploy. That's typically what a lot of Linux systems do, have a deployment server up on your network. And then in a very simple topology, there's just one switch and then a bunch of client target systems, servers or client notebook systems or whatever you have on your network that are booting to your PXE targets. So up in the right-hand corner, this is taken out of the Wired for Management spec. These are the exact steps between the DHCP server. As a client, when it says go run on the option ROM and go do a PXE boot from your BIOS post, what is it you actually do when you go off and do a PXE boot? So step one is you go out to the DHCP server and say, go get me an IP address. And then there's an ACK that comes back and says, okay, here's your IP address. And then when I say, oh, I want to boot, send a bunch of packets, ARP packets saying, hey, I'd like to be able, do you have PXE services? If you do, please give me, acknowledge that and then tell me where that server is on the network, the IP address, and then also advertise what available architecture option ROMs are available on that system. If it's i32 or x64, x86 or ARM or PowerPC or whatever. Then you come back and then there's a chooser program up on your system that will determine, which one of those images to go get off of the MBP or network boot program you're going to execute off the PXE server, and then the PXE server would then start doing a TFTP or copy of the MBP down onto your system. So in a nutshell, that's the typical sequence that you would see on the network, private network, basically, that you'd go off and communicate with a PXE server somewhere on the network, and then hand control off of your BIOS from BIOS post to your particular system. So typically, if you're installing an OS like OpenSUSE or some Linux distribution or Windows, WinP or something like that, this is the sequence you would go through to actually run the deployment software, the install software setup program to go off and install the OS on the system. So after the bottom of the page there, once you load, the MBP or the installation software, the OS, then the kernel runs, the local OS drivers take over the system, and then you're running Linux or the deployment software, whatever that package is, and the BIOS is really not doing any of the actual work of pulling anything off of the network. So once you hand controller off to YAST or Anaconda or whatever your favorite installation program is, the BIOS is really not in the loop. The OS native drivers and kernel have taken over and are providing all the network services to do the rest of the installation, pulling over the necessary files to install the OS. So there's something called also iPXE, which if you talk about enterprise servers, a lot of people run iPXE, where you take the iPXE option ROM, put that on the NIC card, or include that in your system as a plug-in card, or flash it into the BIOS on the system, and that has an additional scripting language, which then allows you on a more complicated network to go find various deployment servers and go off and hunt down the deployment software that you want to actually deploy onto your Blade or particular system. So this allows in enterprise systems not to have any local storage on your Blade, compute Blade or whatever. You can just PXE boot or iPXE boot off of a network enterprise Blade, and then pull all of your necessary boot files for the OS off of the SAN storage or iSCSI storage or whatever it is the storage in your data center is in your particular data center. So that's sort of the state of the art. This is how most systems work today. Remember in the 90s, this is designed long before virus scanners were invented, and people worried about rogue things running on your particular network. So when we talk about a network boot environment, zero trust environment, we're talking about booting in an environment that is not necessarily friendly. We've separated the networks. Typically, there's internal networks or VPNs. You're not sitting on the open internet or sitting on a hostile network that may have access points or Wi-Fi or things like that, where you may not have physical control over all of the elements that are on your network. So there's some basic limitations with the current PXE model today. We'll first talk about one, does it scale to large networks? If I have 1,000 servers or 10,000 servers in a network and I initiate, they all turn on and they all do their PXE boot all simultaneously. If you look at the underlying, we use ARP and UDP packets to do all of this exchange information between the DHCP server and the PXE server. You'll find that on most networks that if you have thousands of servers, each individually asking for that exchange we just talked about, you'll bring the network to its knees very quickly. You only typically get 60% of the bandwidth on a 1 gig or 100 meg connection, right? So you figure out the size of the network boot file that you're pulling. In Linux, grub2 is only 1 meg or whatever, but when you start looking at the actual deployment file that you need to deploy, if it's 160 meg, or in Windows case, it could be several gigabytes or whatever it is, pulling over that initial network boot file over your network when you have thousands or tens of thousands of systems doing that, you'll find that you won't be able to sustain that bandwidth, basically. So you have an underlying scaling problem in a large network that the typical switches and routers are not designed for scaling out large amounts of UDP and ARP traffic. So we found in practice, most people have to bring the packet size down to the 802.3 packet size to get it through all the switches and routers in a more complicated network. So that's typically 15, 30, 384 bytes or whatever it is. So now you have to ACK and NAC individual packets that are about 1.5K across an entire network, transferring with TFTP, anywhere from a 1 meg to a 160 meg file. So this is not very usable in a large environment. So I don't hear about large data centers using this to scale out and on an individual network, boot tens of thousands of servers, right? We hear about people switching the packet size to 32K to get rid of all the ACKs and NACs. There's something called fast learning tree that the switch Cisco, Catalyst, all the switch routers implement, which gives you the fastest path through the network. And they typically do not route UDP and ARP packets efficiently using that fast learning tree method on the first boot. Typically it takes several boots for the routers and switches to implement that and figure out where your client system is in the network. So there's a lot of limitations. The networks were not designed for UDP. They're more designed for web traffic, TCP/IP, and that sort of part of the network stack. If you're in a corporate network or in a network where there are hostile elements on the open to the public, or in your network where you don't know necessarily IT doesn't have control over every system that plugs into the network or the Wi-Fi, you have to modify the DHCP server to do that initial transfer of advertising where the PXE servers are at and doing the load balancing of which clients end up responding to the PXE queries. So typically what happens is the PXE clients advertise to the DHCP server that they're there on the network, and whichever one's closest and responds first to the client wins. So you don't deterministically get to choose as to which PXE server will respond to the boot request from that undie option ROM or that initial PXE boot from the BIOS. It's just whoever answers first. So on a network that is not balanced or tuned, that could be a severe problem. You also have a security issue in that anybody can create a PXE server, and there's nothing that will stop you from booting to that rogue PXE server on a network. You can even put it over Wi-Fi if you wanted to, right? So there's a lot of inherent security issues that were never anticipated. The original, as I mentioned before, the original wire for management stack was designed for a private network that you would add to a server or a client system, and that network would be separate from the main network that you would normally create or use in your infrastructure or enterprise. So there's a lot of issues with the legacy model. I mean, it was designed in a day that was not cognizant of security. It wasn't a concern at that time when it was designed. And, the PXE services, that sort of thing, were done with very small images that didn't necessarily scale to large numbers of systems. These are some really basic scaling and security limitations that we were looking at when we started inventing or creating the UEFI network stack. So just keep these in mind when we start talking about the next thing. Well, here's the zero trust network statement. So some of the marketing people or evangelists are talking about, we have all these secure teams now revealing all of the firmware code as a standard process that we have within Intel and a lot of our customers. So they pulled this quote out from CSO Online saying you can't make that assumption that when you boot PXE on a network that you plug into these days that this is not an environment you should necessarily trust implicitly. Just let any PXE server take over your system. It'd be like walking outside in the street and say, hey, you want to help me set up my network and OS installation on my systems? I mean, just walking out the door and asking the first person that comes along that responds to you is probably not the smartest thing security-wise to go do. Now we want to add some additional trust anchors and find a security model or a network stack that allows us to apply some sort of security to the system that we're doing to the modern systems that we're producing today. Okay, so starting from UEFI, we took a look at that network stack, and early in the 2010 or 8 days, went through and decided that maybe it'd be a better idea when we look at the OS network stack to adopt a stack that's similar to what the internet uses today, the TCP/IP stack that you see that's been around for a very long time. So in the specification, we created a UEFI networking model. There's a whole section of the spec dedicated to that. The first thing we did was we duplicated PXE boot. So we do the same thing as we do in legacy on the wire, except that we do it with UEFI drivers and use the UEFI driver model and API interfaces instead of the legacy BIOS. And then we also had added, from the very beginning of UEFI, we added secure boot. That was something we implemented. There's something called an SEC phase that allows you to boot the firmware securely. There's choke points within UEFI that you can go through and check the images and make sure they're signed before you hand off control blindly to something you're executing in the pre-boot space. And then we ported, in addition to duplicating PXE, we also ported HTTP or HTTPS to our network stack. We've added that since UEFI really 2.5 or a little bit before that. So you can do a secure connection out to the network over a URL, adding DNS services. So taking a look at the new network stacks that were added starting from UEFI 2.3.1. So in 2.3.1 we added the UEFI PXE boot, duplicating on the wire what is done in legacy PXE, except now through UEFI. So on the left-hand side, you can see the original IPv4. That's what all of the legacy PXE does today. The basic stack that we use. I'm sorry, this is the new network stack that was released with 2.3.1 that duplicates the PXE boot services you see on the wire from a typical PXE server. So the only thing we had to change was in the DHCP, the advertisement, we had to add some new IANA architecture types for the executable image to be UEFI, A32, and x64, and Itanium versus the legacy architecture images. So the MBP coming over is a UEFI image versus a legacy executable, an i32 or an x64 executable. So these network drivers were all included in the initial network package on Tiano Core and implemented in most of the system BIOSes today. So your typical Linux distribution or Windows distribution would use this UEFI, consume this UEFI PXE network stack to install the OS or do a PXE boot from a PXE server somewhere. So one of the things we did add in the initial implementation in 2.3.1 was IPv6. So we created a parallel stack. So in addition to the native UNDI driver, the NIC UNDI driver that is ported over to UEFI, it produces the MMP stack. We added an IPv6 stack, and then I had that taken to UNL, University of New Hampshire, and then run through the full IPv6 certification tests at IOL. So then we would have both an IPv4 and an IPv6 network stack, and depending on what you chose in your BDS in your particular UEFI BIOS, you could pick which stack or which option in the boot option list you wanted to, which network stack you wanted to boot through. The reason why we added IPv6 was the server vendors and a lot of the data centers and enterprise clients came back and said, you know, we're moving our internal networks to IPv6. We've run out of IPv4 addresses. When we talked to the storage guys, people making large SANs and fiber channel storage and that sort of thing, they said we have thousands of LUNs on the network. Each has its own worldwide ID. We've run out of IPv4 addresses in the data center if every single drive has its own IP address, right? So in a large data center with hundreds of tens of thousands of drives, you can't have IPv4 is simply just not large enough to handle all the possible boot targets out there. So they asked us to put IPv6 in there so that we could address all of the storage that would be out in the typical data center. So that was to address the concerns we had with the data center. So that was the first implementation of UEFI, migrating it over to the existing PXE model that exists in all of the deployment software back in the day. This is the stack, and typically you can get this today in most server systems. This is what ships in most, HP, Dell, Lenovo, IBM systems today you can purchase, and that's the typical thing that we use. In addition to PXE, we also added iSCSI at the request of the enterprise server people, because typically those SANs that are out there typically have a worldwide ID LUN, and the storage is sitting in racks separate from the compute blades or nodes. So they wanted a way for us to name the actual LUN and storage device worldwide ID of an iSCSI or physical LAN storage device out in the data center somewhere, and put that through legacy PXE. So this was the sort of answer at that time, back in the early 2.3 days when UEFI was first adopted by Windows and Microsoft, and then the Linux distros as well. This is the first instantiation that we implemented in the firmware stack and got this into most of the servers out there. So typically for client systems, you don't have iSCSI, you don't have network boot is not typically a normal mode of booting on a system. So there's really more of the enterprise server devices, servers that went out there and implemented this particular piece of the stack. So from here you can see in the red dotted line area the chunks of UEFI DXE drivers, what we call them in the network package, that you'd have to implement and port over to your particular BIOS. All of these pieces are standard. They don't need to change from system to system. The only component you would need to change is getting, for your particular hardware, the UNDI driver for your particular NIC card that you're planning on booting off of, basically. So this sort of eliminated, major ports you would have to typically do on different platforms, and all you had to do is go find a NIC card or the NIC manufacturer that would post their UNDI driver, basically for UEFI. Typically, that would be x64 format, and have that included in your system BIOS in your server. So this sort of standardized a lot of the stack, eliminated a lot of the work importing. Just by having this, going to find your local NIC vendor and getting your UNDI driver included in your network stack in your particular firmware for your system, and you have your full stack that enables you to boot UEFI, PXE, or iSCSI on your system. So moving to the models that we used, like I said before, a lot of the UEFI PXE boot and iPXE boot was using IPv4 or IPv6. That was the main migration in that period of time. We still have all those same limitations we just talked about before. A lot of the limitations with the scaling and the security issues were not solved by this. This is just getting people to move over to UEFI first. And the only added security feature we had at this time was UEFI Secure Boot, where we would go off, and when we got the MVP image off the PXE server, we would check to see if it was signed, and if you had Secure Boot turned on and you had the cert for your particular in your system, in your DB, we would check the image, the MVP image from the PXE server, and make sure that it was signed and matched the key that's in the DB for UEFI Secure Boot. So if you had typically it was the Microsoft key or the UEFI CA key for the shim that's signed for your particular Linux distro, we would check that image, and we would not hand off control to the MVP unless we saw that signature on the MBP file that was handed off from the PXE server. So we had some really basic security there. At least you can develop a chain of trust where in the BIOS in the firmware you're checking the image you're handing off to, as opposed to legacy BIOS where there was no checking at all. You just blindly executed whatever was handed off within your PXE server. So it didn't establish a chain of trust with whose PXE server you're booting from, but at least the image that you're executing off of the PXE server, you would check to see whether it was signed or not, and from a trusted source that you wanted the system to execute. In UEFI 2.5, we started moving forward with some more concerns about scaling and using a more modern network stack and getting away from using PXE servers. There was a request saying, well, why can't you boot off of a web server, a standard URL, so I don't have to alter the DHCP services at the front end of the network. Most IT departments won't let you change or alter the DHCP server. They have to keep track of all the PXE servers in the network and deciding whether they want to allow PXE servers to boot network images on your particular network. With the growth of all the networks and the systems and Wi-Fi, I mean, it's very difficult to control who's on your network, so that's not really a good thing. So moving over from PXE to a standard web server booting off HTTP, a URL or an IP address would be a little bit safer. That I can then, from the user, boot options, pick the specific URL and transfer and control of where the MBP was coming from off the network, and allow you to boot off a specific file off of a known web server that you trust, or that's hard encoded into the BIOS if it's for servicing. So the newer network stack, we looked at the OS driver stack and started pulling over the pieces that we needed to implement basically TCP/IP. So you look on the right-hand side over there, we still have the standard DHCP and services that we typically use to get an IP address off a network, off a DHCP server, but now all we care about is just getting a normal IP address. So you could do your standard static or dynamic DHCP acquisition of IP address, and then from there implement DNS, HTTP, the underlying TCP and HTTP stack you needed to be able to talk to a web server on the network. So we spend a bit of time getting that working. Initially it was HTTP without the S, without the TLS cert. We'll talk about that a little bit later. So at a minimum, we wanted to be able to boot off of a specific URL or a web server somewhere on the network. You don't need to alter the DHCP server advertising where the HTTP servers are on the network. You can do that if you want to. We have provisions to duplicate the PXE services and model, but you could also just boot off a straight HTTP or URL server if you did not want to ask the DHCP server where the HTTP server is in the network. So that requires, on the left-hand side, some of the basic HTTP driver stack, and we put that into the tnocore.org and the DK2 project, and in the UEFI 2.5 timeframe, 2010, 2011 timeframe, we've been advertising, that we can do this in the network. So we once again realized some of the basic drivers that were originally in the network stack. We used the same UEFI UNDI driver, particular to your NIC, that's hard coded to your NIC, and then we have the same SMP and MMP driver stack at the bottom, that shared code that we reuse again in our network stack. So this allows us to reutilize without having to go back and have everybody rewrite all of their firmware code for their NICs, to reuse as much of the network stack as we could from PXE and continue just adding the upper layers of the stack needed for HTTP boot in the system BIOS, and not have to go back to every card vendor on the planet and have them rewrite their network stack code for their NIC. So this reutilizes the existing code. We don't need to go back, and once they've moved over to UEFI, they can just add the new code for the TCP/IP and HTTP, and you would be good to go to boot off of HTTP. So the different net environments we're looking at, obviously, were the data center and the corporate enterprise server environment, and then also your home network. So for consumers and people out there, we wanted some way of reaching the end user out sitting on the open internet, for them to be able to update the firmware on your system, or be able to boot off of some cloud storage or some sort of network storage on your network, to be able to deploy an OS, repurpose the system, or whatever. So we wanted a more flexible pre-boot firmware environment network stack to allow you to get at the machine and be able to boot off the network in a more modern network environment that doesn't have requirements in the DHCP server and PXE servers on the network, right? Having web servers on your network is very common. Your switches and routers are scaled and designed for steering TCP/IP traffic and hosting web servers, everywhere on the network. That's not something that's particularly difficult to do and scale to a very large number of systems on your network. So your typical HTTP or HTTPS boot flow is where you go through. You just have a DHCP server typically. It's handing stuff out in the cloud, and then up in your network you have a DNS server and an HTTP server. The DNS services can be combined together in your network with your DHCP server, but there's nothing special that you have that you wouldn't already have there for a typical network today. So the DHCP server is still going to hand out the IP address. You have a choice in your deployment servers whether you want to advertise UEFI, HTTPS, or HTTP servers with a particular MBP architecture type, x64 or i32, whatever the host MBP images you want to host. You can put that up in the DHCP server, or you can put that on the HTTP server if you already know the file name and the type, architecture type you're trying to boot to. You wouldn't need the DHCP server for that. The thing we also had was obviously a DNS, so that instead of typing in a hard-coded IP address, whether it's v6 or v4, you could just type in a URL name, and the DNS services that we've added to the network stack would allow you just to type in www. Your OEM.com or whatever URL you want to put for wherever you want to host your MBP files on your system, on your network. And then from UEFI, you just name the NIC MAC address or the specific NIC you're trying to boot off of, and then the URL, and then you can just download your NetMBP file off a standard web server and then transfer control to it. So this is essentially the model that we want people to move to. It uses a more modern network topology, uses standard network services that are out there, does not require large alterations of your networking topology in order to support booting the end system off the network. So booting off of HTTPS requires a cert. Basically a TLS cert that needs to be installed on the host UEFI system. That's something that in the spec we talk about how to the format of the cert and where to put it in the stack, but we don't talk about the actual implementation in the specification. So a lot of enterprise servers put the cert behind the BMC, for example, or someplace on an enterprise server that's safe, that they can get out of the band. And that's one of the security issues that the security people are very worried about. Cert management and deployment of the cert for TLS is something of great concern. So when I came to the Linux Foundation and asked them, did they want to host some certs, they told me, well, we're working with something called the Let's Encrypt project. We'd like to do our own signing of certs for TLS. They have the exact same problem up in the browsers for Firefox and other browsers, right? Utilizing that infrastructure for managing the certs would be something good. That's something, once again, the community really needs to work on, providing a way to get at certs from the pre-boot space, and then vetting, of course, of the open web and that sort of thing as to how that gets updated securely, basically. So that's not part of UEFI, obviously. It's part of managing the open web and that sort of thing. So going to the community and asking them how the form certs get distributed and how they get formatted and where to put them and where you get them from, right? That's something that is that's obviously not solved by the BIOS engineers or the firmware people. So that's something that we, from a security standpoint, we'd like to see the community step up and own that portion of the infrastructure out on the open network, right? Some of the advantages of using HTTPS boot versus the PXE boot is, of course, we use a DNS description of where the server is and finding the file, the UEFI file that we're trying to boot off of. We can use this on any typical normal network without altering the topology, since most networks support TCP/IP and HTTP and HTTPS. We can use both IPv4 and v6, and then you're not worrying about where the PXE server is, which subnet it's on, you don't need to worry about load balancing or placing the PXE server on the same subnet as the target system that you're bringing on. You can cross multiple subnets and routers and switches. You don't have the problems of co-locating a PXE server to where the target system is trying to boot. We have some basic minimal security for UEFI secure boot. So for the MVP image, we're going to check the image, the signed image, before we transfer control to it. And then once you get HTTPS, we can also vet that we're actually booting to the URL, to the actual website that you're trying to get to once we include the SCERT in the system and in the network stack. So if you combine this with a RAM disk as well, UEFI has a RAM disk as well as I believe Linux has a RAM disk as well, right? You can then not just copy over the MVP file, but the entire install image, everything you find in the ISO image over onto the RAM disk, and then run it from this RAM disk and do the full install process. So this sort of gives you what we think the ingredients you need to be able to deploy an OS on a bare metal system that doesn't have anything on it, just the ability to boot off of the network stack and from pre-boot space. So some use cases of what we think you would want to use HTTPS for, and people have come to us for, was the most obvious one is installing the OS image or just booting off of the OS if you have no local storage on your server in the data center. So like as I just mentioned before, you can install from an ISO image you've copied up onto the web server and then move it to the RAM disk and install from there. Or as in the case of OpenSUSE, your installer can recognize and support HTTPS directly and install directly from the OS MVP image. We also have had certain organizations within the government and other places, security people that have asked for firmware updates. So we've seen cases today where you see your typical IP camera and other devices on the network that need firmware updates, whether it's your system BIOS, the BMC, there's virtually everything inside the system today has firmware on it. Your storage, SSD storage devices, your NVMe cards, your NIC card itself has an undie driver, may need to be updated to the correct EFI image that you need or architecture type. There's lots and lots of things inside the system. So UEFI invented something called firmware capsule update, where we've been working with the community on getting the capsule images standardized so it can be deployed from either Windows Update or something called LVFS. Richard Hughes's FWB.org site. So we would like to be able to deploy these firmware images out to the end target systems directly through, ideally, this safe network stack, and then update the firmware in your system without worrying about whether or not the OS can boot or not. You don't need to be in a state that's completely functional in order to update your firmware. So firmware update from the security people seems to be a really big action item and something they would all like to see. And then in the case where maybe your system has crashed, the OS doesn't work anymore, or I've been attacked by some malware or firmware, the system's been taken out, it's now compromised, I just want to wipe the OS in the current state of the system, install the OS and restore from cloud storage and restore the backup to a state of the system before the malware attacked or infected the system. I'd like to be able to do that from a network boot, basically, right? So if you have you've been backing up your software or your system as you should have, having a network boot function that's HTTPS compliant and capable will then give you the ability to, put the whole system back the way it was before it died or crashed. So there's an entire NIST document that talks about recommendations on typically for enterprise and government systems of the implementations of all this firmware security and network stack and things you should go do. So the NIST document is something I highly recommend taking a look at if you're looking at all the requirements necessary for system recovery and cloud recovery and storage and that sort of thing. The other thing for systems in the data center, blades and things like that, they would just want to boot off HTTPS in their network and not have any local storage on the blade systems. Keep the blade or compute nodes separate from the storage nodes. For thin clients, your typical Chromebook type environments, you don't want to have necessarily local storage or whatever. You want to be able to boot off of a network location to update or install the OS. It's another use for HTTPS that we see some people would like to use the stack for. So these are just the first couple of cases that were brought to us or that we've seen utilized today that people are working on. So we'd like to extend these, traditional PXE boot, network boot cases to these new cases, that we have been asked of us, and the reason why we put this network stack in UEFI to begin with. So if you want to play today, I'm going to give some credit to where credit's due. So we have Gary Lin from the SCaLE community. We have Gary Lin and Joey Lee and some people in Taipei that have been watching all of this, and have implemented in OpenSUSE 42.3 and SLES 15 Leap. They've implemented the full HTTPS capability, so right off the installation ISO image you can install directly, and that's a little demo that I have here, utilizing in the latest releases that they're able to boot off of HTTPS and install OpenSUSE or SUSE SLES 15 onto your system. So these guys have been watching us very closely and have been first to go implement this and stick this in an external distribution. We'd like to see the next level of the community above them, the deployment software people for like SUSE Salt Manager or whatever, also get off of PXE and legacy PXE and use HTTP or HTTPS to do their deployments. So this is something you can do today if you can get a hold of a UEFI system that supports the newer network stack. You'll be able to try this out. I have a system here sitting on the table and a video that I've taken that will allow you to, in this demo, actually boot off of a physical device that has HTTPS fully implemented from Tiano Core. And then Gary and Joey have done the work of implementing it up in OVMF. So if you can't get a hold of some hardware that boots HTTPS, typical, like I think there's like an HP ProLiant server that boots HTTPS today. If you can't get a hold of something like that, or this Minoboard Max board, there's an OVFM environment you simply download onto your build system and try everything out inside the OVMF environment off of EDK2. So if you want to do some real work and play, we highly encourage you to contact us or just try this out, download it and try it out inside the virtual environment. Play with that if you're trying to get some tools and deployment tools working. And there's some basic getting started guide here on how to go implement the OVMF environment or download EDK2 and build the stack if you really are interested in pulling the stack down and trying it out for yourself with the source code. Backing up for a second here. So there's some other information here on where the source code is for, guides on how to boot HTTP and HTTPS, some wikis that we've put up on the EDK2 Tiano Core site, and there's some GitHub. We're transferring a lot of the tutorials and educational materials to the wiki site, to the wiki GitHub Gitbooks format. And then there's some URLs here on where to go get the source code for OVMF to do the virtual environment build and test out, as well as the Minoboard Max project, which is an open source hardware board that we use to implement EDK2 and test out the code on a real platform, something that's open source hardware that you can get and try out yourself. And then I named also the HP ProLiant series Gen 10 servers, which have HTTPS built into them. They're shipping today. So you can, if you're in the enterprise and you have one of those servers, you can actually test out the stack and try it for yourself. There might be other Dell and Lenovo servers that have this as well. I'm not apprised and didn't do a full survey of all the firmware that's out in all the servers, but you can ask them if they've implemented this network stack or not in the system. So I have a little demo here just to prove to you that this is not all vaporware. So I'm going to go off and I have this up here, but you can't see what's going on up here. Actually, I can. Let's see if this works. Plug the Minoboard. I'll plug the video into the Minoboard Max system here, which I've booted up already. So on my notebook over here, I have a HTTP server that I've set up with instructions from one of the URLs up there from Gary Lin and Joey Lee, and I've on the Minoboard Max target system that's going to boot over the network. There's a tiny Netgear switch here, a 1 gig switch, and just the Minoboard Max, and then my notebook host server that's hosting SLES 15 as a host URL server using Apache 2 and a DHCP server as well. So I'm showing you here the middleware Mac system is booted up to what we call the BDS, or the boot manager. And what I'm going to do is select the boot options that are set up in this BDS. So I've installed already on the storage device. There's an SSD storage device, OpenSUSE, just to prove that to me myself that has the drivers to be able to boot OpenSUSE. In addition, there's a bunch of options here to boot off of the internal shell and the flash. And then all the UEFI PXE boot, there's a V4 and V6. So there's two NIC connections on this particular board. So you would have two NIC addresses. And then you remember there's PXE IPv4, PXE IPv6 UEFI, and then HTTP. So I have at least 6 combinations that I can boot from. And that's what all these combinations are here. I can pick which stack I'm booting off of that's in the firmware. So this is UEFI, PXE V4, V6. Requires a PXE server, and then from the first network connection, there's an HTTP v4. So I would have 3 boot options depending which stack I'm trying to use. V4 and V6, sorry, so there's 4 options for the first NIC. And then there's another 4 options here for the second NIC connection. The same thing, PXE v4, v6, HTTP v6, and HTTP v4. So on this particular server, this little notebook over here, I've implemented a web server that is doing HTTP, or it's IPv6. So I'm going to select that boot option and boot off of the URL. So in my BDS in the far right-hand corner here, you can see I'm going to let the DHCP server pick the URL that we're booting off of, whatever it decides to. There's a second boot option called UEFI HTTP, and this names the specific IP address of the HTTP web server. I could have typed in a URL. I should have typed in the URL instead of the direct static IP address of the HTTP server. But in this particular entry, I'd entered in the IP address. That's a v4 address on there as well. So we'll go back and boot off of the HTTP v6 and let the DHCP server name the URL. So it's bootx64.EFI. That's the name of the installation software from the SCaLE 15 DVD or ISO image. So right now it's just gotten the IP address, the v6 address off of the notebook, off the DHCP server, and then it's handed the bootx64.EFI image file off of the web server, its grub, and that runs. I don't have secure boot on in the system. It's booting without checking the image, but typically you would want to do that, turn that on and put the cert for the shim that's in the system. And then once grub2 starts running, then its network stack, its kernel loads, the network stack loads, and then we go off and start booting the OS. And so as usual, it's never working on the actual time that you show it in front of a large number of people. So just for your case there, you know, grub is running. So as far as the OS or UEFI is concerned, we've already handed control off to the UEFI image on the network server. What it does after that, that's really what Gary and the SUSE people have done. So we'll try this once again. Actually, we'll try I don't think I've started the v4 server, so it's only v6. I've forgotten if there's a timeout built into the grub2 loader, so I don't know if I'm supposed to be pressing space or return automatically, or if it does that itself. Yeah, so this time it worked fine. I think there's a timeout inside the grub config file, and I was talking and I didn't press the space bar or something. So now it's already transferred control to the RAM disk. It's copied over all these files from the ISO image from the web server onto the thing. Now you're watching this is the standard install program from SUSE Leap 15 that's running, and UEFI is not in the picture anymore. It's loaded the network drivers, and we're using the SCaLE 15 network stack to come up, and we've transferred control. UEFI is not in the picture anymore, so it's now going through the install process. So I'm not sure you want to stare at an OS installation. This is all YAST and all those things running on the system. So it's typical the setup of how I got this working was through the boot maintenance manager. When you're adding boot options, you can go through and select using the BIOS setup to go through and boot off of the SD device here. So I won't go through that right now. It's implementation dependent upon my particular version of UEFI on the system. Just going to go back and finish up on the slides here. How much time do I have left? Down to the last 10 minutes or 12 minutes here. So the call to action here of why I'm up here talking to the community is we'd like you to stop using legacy PXE if possible for a variety of trust, security reasons I just mentioned. If you really want to just boot off of something, a PXE server on a network, the first one that comes and answers to you, that's probably not the smartest thing you should be doing. Even if you have iPXE, their trust model is a little bit different. They have for HTTPS, they have a fixed location on the network that it drags the cert over, and that's, security people have a cow when they hear that. We'd like you to take a look at our HTTPS boot implementations, try out some of the stuff that's out in the marketplace today, crawling servers, or go get the Miniboard Max, or just pull down OVMF and build it yourself, and work on the deployment tools to actually go off and stop using legacy PXE. Try and move over to HTTPS as your deployment method if possible. And pay attention to some of the security aspects of what you're booting to. You don't necessarily trust the network that you're booting from. We don't have dedicated back-end networks for deployment and for these things typically today, so we want you to do that. And then review the OpenSUSE documentation, help out with both documenting this for end users as well as how-to guides and that sort of thing, and utilizing your particular distribution and getting the open source community to utilize the newer stack and educate them on how to use your deployment tools once you migrate over. So I did want to open up to, there's one other slide here besides these references to these locations. Our community, the UEFI community, gets together once a year in the US to a plug fest. We're holding one next month in April up in Bellevue, Washington at the Embassy Suites. So there'll be a bunch of lunch sessions educating the industry where the state of the art of UEFI is, the latest advances we're doing at lunchtime. And then testing. You can actually go and see all the vendors will bring their systems there, and you can go off and try out UEFI and various OEM systems. The OS vendors might be there as well. Microsoft is definitely there. We're down the street from them. And then try out in the test room suites. We hold a plug fest where you go in and try out your software or hardware on real UEFI systems. So Intel will typically bring our latest systems there in the closed rooms for you to try out, and then the OEMs typically also have client and server systems for you to try out. So we highly encourage the community to come out and visit us and meet the people who are actually building and constructing the firmware and the specifications with the industry. We also cover ACPI. We've absorbed that spec, so there's some ACPI people there if you want to talk to them as well. So I think I have maybe a few minutes here. If there's any questions, there's a microphone up here. If anybody has any questions.
Test.
Hi, my use case is a contract manufacturer who's going to do the initial install of our new hardware that is a very untrusted environment in some sense. We're running ARM processors. We don't have Grub. One question is there a hard dependency on Grub? You showed the Miniboard. Does that actually have one of those UNDI drivers? I'm just wondering, for an ARM platform, how practical it might be to implement some of this stuff. And also, just another quick question, would you advise in a situation like that to host the images inside the contract manufacturer, or host them in our own infrastructure and pull them down via HTTPS? Thanks.
Okay, so first of all, for ARM, I would contact the Linaro community. So a lot of the people in the Linaro community are in the middle of porting to UEFI right now. So you would have to talk to them about getting an UNDI image, as well as the ARM, well, they ship ARM images with SUSE and OpenSUSE, right? So, but as far as getting an MVP, if it's not Grub2, whatever they're using for ARM, you know, having the installation program that you would use, you'd have to talk to the Linaro community about that, along with the SUSE community as to whether they support ARM. I'm pretty sure they do, but you know, whether they include an MVP image for installation using HTTP boot versus, I'm sure there's a PXE boot image, but whether there's an HTTP boot, I'm not sure that's been ported. So you'd have to contact them. That's something at the Plugfest and the Linaro Connect events that you can get the latest on what they're doing. And then your other question about should you host the MVP image internally, locally in your facility, intranet? In your cloud. So with the stack, I mean, it's a question of security as to which environment you would trust. A lot of people, there's a certain fruit vendor that we know, right, in Cupertino, that you hold the key down and it goes out to the URL and then it checks your Apple ID and says, hey, are you a legal customer for this unit? And they do it over the open web. So that's one model. Another model is if you have blank systems, you don't have that security business model in place already, that, yeah, you'd want to do that behind a closed intranet and you know, not have that out there. Some other BIOS vendors and OEM vendors have a hard-coded URL. They're still using the TFTP and PXE stack to go to a location, you know, on the open internet to drag down an MVP image, right, to reflash your firmware system. So it depends what you're trying to do. And you need to look at the security aspects as to, you know, what kind of environment you trust and how much security you have in your system to decide whether you should allow control to be transferred in that environment. So you can talk to me afterwards. I mean, I can understand your use case better in that one. I'm going to hand the microphone.
I had a question about, sorry, where can we find the slides for this? I actually work on a tool that does PXE TFTP boot installations called Stacky.
So I assume SCaLE is going to post the slides up to... Oh, okay. I mailed them to you, but I'll post them on the event, and then they should appear in the SCaLE, the website then.
Okay, yeah, thank you.
One more question after this, and then we're going to have to cut it.
I'll be around here or just outside if you want to talk to me afterwards.
So when you did the demo, it looked like you had a lot of stuff already set up on the board. How much manual configuration in the UEFI configuration interface do you have to do to get this up and running?
So what I didn't have time for was to step through. We have in the reference BDS, so the reference boot manager in EDK2, there are some menus you can go through, so you do have to just add the boot entry. So once you have the stack already implemented in there, there'll be a selection of typing in the URL basically. So all I had to do to set up that boot option was to go into the boot maintenance menu, you know, and type in for the URL, basically the IP address for that particular Mac device. And that was all the setup I had to do inside of the user setup I had to do inside of that particular implementation I made aboard Macs.
So it's not really quite plug and play. You can't buy 500 brand new servers and provision them using this.
So in the server world, there's something called Redfish, and so what's not standardized in UEFI today is a standard way to deploy configurations. So they're working on that with the DMTF. If you're interested in going, I think at the OCP Summit or in the DMTF organizations under Redfish, you should take a look at that. So if you want to deploy on mass numbers of servers, both in-band and out-of-band, these network configurations, among other configurations, not just the network configuration, but the rest of the BIOS setup, you need to talk to the, the Redfish organizations and that current work that's going on right now as we speak.
Okay, last question.
I have two questions. So first question, is there a published resource somewhere, or is there interest in building a published resource on UEFI 2.5 compliance among manufacturers? So basically, my concern is building a product around UEFI 2.5.
I see. So we have...
So many servers support it.
One of the things we have on the UEFI side is something called SCTs. So you can run the self-certification test to see are the API interfaces in stack, is your system capable, right? Because yes, you're right. Walking up to a system, and unless you boot to the shell and you're very familiar with UEFI drivers and which driver stacks are available, you don't know what's it capable of. So running the SCTs is one way of checking which API interfaces are available in any given system. I also recommend there's a pointer to FWTS. So existence of the API does not mean they actually are implemented and working. FWTS is another, from Ubuntu, is another test suite that everybody uses for UEFI and ACPI. I'd have to check with Alex Wang whether they are up to 2.5 or 2.6 or not. I haven't asked them in the Launchpad to implement the FWTS test for HTTPS, something we would want them to obviously go do. And then there's something called LOVE. Intel has, on 01.org, has the Linux UEFI validation tests. They combine FWTS, chipsec, a whole bunch of things together to test, functionally test your system. So there are a number of places you can go to go test your UEFI system to see what it's capable of.
Okay, great, thanks. Last question, are there resources on leveraging TPM as the backing key store for validation?
So what I didn't, as a call out, one of the things that we were working on was, where to store the TLS certs and for the system, right? So that's something that's not well spelled out today. We just talk about the format, and you should have this capability. But as far as implementation details as to where to safely secure the store the certs in a system, we do have on the website. We do implement TCG. This session was not talking about measured boot or which is more than secure boot, right? I didn't talk about TXT or BIOS boot guard or any of those things. You can talk to me afterwards. That's a whole 1 or 2 hour session in itself. So I think they're going to want us to move. Right? Thanks.
Thanks.
All right, thank you.
All right, thanks a lot.
Actually, if you upload them to like either Slide Deck or I think there's another website, then you can just put the link in and everyone sees your talk, and then I can also get that to the guys at SCaLE.
Testing. Test. Am I on? You can hear me? Do you want to hear me? That's the real question. Yeah. Thanks. Is it time? Oh, good. Yeah, it's time. My name is Craig Gardner, and I'm speaking for the first time here at SCaLE, but I've been giving this particular presentation, or variations of this presentation, for 20 years. And, I've got to turn my clicker on. There we go. I subtitled it this time after one of my favorite poems, one of my favorite poets, Robert Frost. And the woods are lovely, dark, and deep, but I have promises to keep and miles to go before I sleep. I'm a software engineer by background professionally, but I'm also an instructor at a university. And I spend a lot of time teaching computer science at the university. And I also spend some of my free time trying to get into the elementary and secondary schools to talk about this kind of a topic. I've adapted this particular presentation for you lot. Usually when I'm giving this kind of presentation, it's to students, it's to educators, it's to people who are less familiar with open source. We're at SCaLE, and you know all there is to know about open source. I'm not going to teach you very much about open source in particular, but I would like to take a moment to talk to you about some of the challenges that we have in the industry that revolve around this thing, this concept, this ideal, this movement that we all feel very strongly about. As I mentioned, I have a lot of engineering background, but as I teach at the university, I teach computer science classes, particularly in terms of software engineering, but I'm also currently teaching a class about technology and ethics, which is strangely related to this particular topic that we're talking about today. Likewise, I create training materials for a variety of different SUSE-oriented products, which I won't get into today. The real challenge that we have that I would like to talk about is that we have a very large demand for people contributing to the growing set of open source projects. Now, you all know the power and importance of open source projects. It runs the internet, right? Open source is a movement that is providing new solutions in new ways, in new sectors, through a variety of different means, through a slowly growing number of people. The challenge is that we don't have as many people entering the realm of the writing of source code that is open source to solve the solutions in an open source mechanism. As a matter of fact, our friend Greg Crow-Hartman, who works at the Linux Foundation, was speaking at Core OS Fest not too long ago, it's now 3 years ago, but he made a very insightful observation that I would echo, in that it's hard to find people to hire in these fields, people to hire to work in these projects, because everybody's already been hired. And so we need to invest in the growth of people adopting these paradigms and in adopting these methodologies, and do so in a way that we can grow the field of people who will continue to contribute, and at a pace that the demand is demanding. I've titled this "Looking for Rock Stars and Ninjas in All the Wrong Places." There have been lots of interesting news articles and even academic studies about what's going into this myth of rock stars and ninjas in our industry. Now, make no mistake, my friends, really, there are quite a few of our friends that we would consider to be rock stars and ninjas. And maybe there are some of you in this room that maybe you're contrite and maybe you're humble and you wouldn't call yourself that, but you may be a ninja or rock star. But the recruiters in the industry are putting out these job descriptions for people to join the software world and giving those job descriptions titles like ninjas and rock stars. And they're failing to attract the people that they are coaxing, that they're trying to entice. Now, why is this? 2 reasons. Number 1, no one has any idea what a ninja or a rock star job is. And number 2, the people who may be able to do the work that the recruiters are trying to entice are humble enough, or maybe even dumb enough, to think that they don't have those skills, where they may really have the skills that a company wants. So we're failing to match these things up. We need to get away from this whole concept of ninjas and rock stars, as cool as it is, and as appealing as it sounds. We're not doing ourselves any favors when we are trying to hire ninjas and rock stars. We seem to think that this world of open source can only be filled by ninjas and rock stars. And I'm hoping that I can convince you that that's not the case. So as we talk today, I'll talk a little bit about open source that you already know. We'll talk about where you and I can make the biggest impact. And I'm going to start by saying that the schools is a good place, but I'm not going to end there. I want to talk to you folks about how you can make a difference in or out of a classroom. We'll talk a little bit about how we use open source to bring people into open source. And lastly, I want to make sure that you understand that your everyday run-of-the-mill staff, software engineers, are going to be and need to be the people that you are trying to describe as ninjas and rock stars. And you've probably seen this kind of chart before. I shamelessly ripped this off from Wikipedia, right? Why do we use open source? We don't need to talk about that here today, but when I'm talking to educators, when I'm talking to students, when I'm talking to people outside of our realm of influence who need those ninjas and rock stars, I have to explain to them the value of open source. And there are many. And some of them are obvious, some of them are less obvious, but they're the kinds of things that you already identify with. The point I would wish to make as we move on from that is that in our schools and in our institutions of learning, we recognize that we have lots of jobs that are available and a growing number of jobs that will become available that we need to fill with those people that can program. And so in our institutions, we teach programming. And that's a very common thing. Now, I'm going to show you a little bit later that it's not as common as it needs to be, but that is something that we've all taken part in. We've all gone to classes. We've all perhaps even gotten some related degree in a university to where we've learned how to program. And we sit in front of an instructor, and the instructor teaches us this is an algorithm, this is a procedure, this is recursion, this is a subroutine. These are all these different things that we come to appreciate in terms of programming. That's a very common thing, and it's very worthwhile. But teaching open source is a foreign concept in our institutions of learning. We'll talk a little bit about that here in a moment, and I would assert that if we were to apply open source principles, and if we would use open source in our education, that we could make a bigger difference in preparing people to fill those roles in the industry. Now, you're thinking to yourself, and rightly so, right, what does Google care about where people learning about programming are doing so in an open source way or not? I just need programmers. We'll get to that. Not too long ago, the GNU revolution started. That kind of was the opening of the door of the free software and the open source movement. And you have these values that were established by Richard Stallman that you're all very familiar with. Let me provide some variations on this foundation from Richard Stallman, and this is Craig's alterations of the free software movement. We need, with open source, an opportunity to have more freedom to move from project to project. Have you sensed that? Have you been in organizations where project A has been good, but then it kind of dies and is less important, and now there's project B, and you need to figure out how you're going to staff project B? With open source methodologies, with an open source mentality, with open source values, we have a greater ability to move from project to project. We have greater agility and greater flexibility to move. Number two, the freedom to grow and adapt our own talents according to our own needs. I would assert that open source facilitates that. It's even at the heart of what that is. Number three, we need open source to be able to redistribute ideas. The ideas that come out of Project A to proliferate into Project B and all the way down to Project Z. And the freedom to improve ourselves not only for the good of the projects that we're working on, or the good of the industry that we're trying to improve, or the problems that we're trying to solve, but the freedom to improve ourselves. And this leads towards an open source mentality. That gives us greater freedom. Now, in our schools, I'm not trying to badmouth the schools. I'm not trying to make any particular school or school system look bad. But I want you to think about what schools do, particularly in the context of technology, right? They're trying to tell their students that we're preparing you for the real world. And what's the real world all about? Well, it's a lot of things. But at the end of the day, we're trying to put food in your mouth and a roof over your head and support yourself and your family, whether that's just for hardcore day-to-day needs or for the toys that you want to buy and participate in extracurricular activities, right? You're trying to tell these students that they're getting ready to make money later on. And they don't understand how free software leads to paying jobs. And schools, they're generally funded by taxes and to a certain amount to benevolent corporations that are donating their time, their hardware, and their software, but with their own agenda. Number three here is that most schools just don't understand what open source is and what open source does, and that it has this broad outreach of business applicability. And it requires that schools need to be more adaptable and more open and to change their old paradigms, right? But schools don't have time, right? Schools have so many distractions. Schools have so many different things that they're trying to juggle. And it's hard for them to be flexible and adaptable. I'm simply saying I can understand why it's hard for them to understand the value that open source can bring. The standard approach to schools in terms of technology is broken. And again, I'm not trying to poke holes. I'm not trying to offend. I'm simply trying to say that if these schools are going to succeed in preparing this next generation of open source geniuses, ninjas and rock stars, they need help. They need help understanding what open source can do for them because they're tied to their tried and true academics. And they're a bunch of good people, but old people that understand things in a strictly academic way. Okay, and I'm an old guy too, right? You can see I'm kind of a gray beard kind of person, right? They're closed systems typically. They're not open to new ideas. They're not open to they're very rigid, formed, tried and true kinds of things that are tied to paradigms that are related to the individual being tested. The individual being given an A to an F or an E, right? You either know the stuff, or you kind of know the stuff, or you don't know the stuff, and there's no collaborative involvement in their learning of this stuff. Do you know how to write the algorithm, or don't you? And open source isn't like that. And open source threatens that. But they can get along. I'll tell you in a moment about that. We use the tools, methods, and hardware that come from the vendors. Now, please do not misunderstand me. Microsoft does a great job of donating their wealth to schools. And in the process, they give a lot of hardware and software with the intent that the students are going to become Windows users, aren't they? Right? That's good. I'm not saying that's wrong. But Microsoft is buying mind share in the schools and making it harder for the open community to work its way in. That's a difficult thing for schools to negotiate. I'm not trying to say Microsoft is bad in this. I'm grateful that Microsoft tries to do, and I'm speaking on Microsoft as an example. I'm not saying that that's the only situation here, but they have a vested interest in making sure that they have future purchasers of Microsoft technology, right? We get it. We understand it. That's part of their business. This ends up being a broken approach because in an individual environment, you're not really approximating what the world is all about. I understand that a student needs to prove that he or she can read at a certain level, can perform algebra, and can create some subroutine in C or Python or C++, C sharp, what do you call that? C sharp, right? We understand the individual attributes of learning, but schools are tied too much to that. And they don't understand that collaboration needs to be part of the education because collaboration is life. Everything that we do in this life is a team effort, and especially in our industries, and especially in software. And they also get kind of tied down into just writing software for writing software's sake, instead of realizing that and making good use of, there's a lot of code that's already been written, and that part of the real world is reusing code that already exists. Yeah, I understand. You got to figure out how to write recursion. You've got to be able to show that you can write recursion. But they need to have a collaborative environment wherein they can learn how to work as a team. And those educators are thinking, I can't do that if they're borrowing somebody's code. I can't give Johnny an A or a C based on his borrowing Mary's material. Okay? That's a tough thing to have to overcome. Now, we understand all these benefits of institutions using open source, of all companies using open source. Schools are no less the case, right? Typically lower cost in using open source, all these different things, freedom from vendor lock-in. Yeah, that's all great and cool. But let's think then about where you're trying to get these students to go, where you're trying to get them hired, where you're trying to get them involved, and where they're going to be winding up to solve some of the world's most challenging problems, right? 77% of software companies, we'll talk about non-software companies here in a moment, but this is information from a variety of different sources, largely from this one down here at the bottom, but 77% of software companies foster open source. So why don't the schools teach about open source if 70% of the software companies are needing to hire people that know something about open source? This is up from 50% just 4 years ago. 73% of software companies have a formal open source strategy. Well, then why shouldn't the students be learning about open source? Beyond that, 78% of tech companies, and of course that's kind of a squishy definition right there, have some reliance on open source. Moreover, there has been, and it depends on who you ask, and so I don't put any numbers on this particular datum here, but monumental increase in the use of open source even in non-software-oriented companies. Mining, materials management, medicines, medical, mom and pop. All these industries are using more and more technology, and what's behind that technology? Open source technologies, okay? We recognize this, right? But our schools are challenged with this, and we need to be working with these schools to help them understand. That's why I've got miles to go before I sleep. I'm trying to spread this message that it's not just a school problem, it's a general problem that we need to help solve. 87%, this is from Linux Foundation, the 2018 Linux Jobs Report, 87% of hiring managers are having a hard time recruiting enough open source talent. That's a huge space to fill. And Greg Kroh-Hartman says, we can't hire them because they're already hired. We need to fill the pipeline with people who understand this. Now, Microsoft is doing a great job. Right back in 2015, they have launched a stance, an approach that embraces open source, and I applaud them. And let me tell you, I have many friends who work at Microsoft, and they're moving there. And this is a great thing, and they're going the right direction. And Apple is too, right? A little bit. But if you open up your iPhone or your iPad and you look at the license information, and you'll see the hundreds of open source licenses of projects that they're incorporating in their projects. They buy it, they understand it. They're a little less outspoken about it, but they're moving there. They're using it. They take full advantage of open source. And these are the big industries that every junior high school student knows a lot about. Our future needs in the outlook that takes place from the Bureau of Labor Statistics is that 71% of new STEM jobs are in relation to computing. Yet only 8% of STEM graduates are in computing. They're usually in some other math or engineering organization. The imbalance is obvious, right? Only 1 in 4 secondary schools teaches programming. That's tough. That's a problem. And one of the reasons that they're not teaching programming is because they can't get teachers who know how to teach programming. And I don't blame them, because every year it's different. It's hard to stay current and up to date as an educator about teaching programming. And just because you've got the one great lady who took a class to teach that particular programming class that year, she's likely not going to teach it again a year later. It's a tough place. Now, there are lots of schools that are working to remedy these kinds of things. You've got Harvard that has fully embraced this open mentality, including all of their MOOCs, right? You've got all of the material that they're putting out and their massively online education efforts. This is great. RIT does this. Oregon State is huge on this. San Diego State is embracing this. So, yeah, good. What about CIT? Does anybody know if CIT here next door, are they an open source? Nobody knows. Good, thank you very much. Yeah, but great, thank you for sharing that. There are even some high schools that are trying to do this. There's this one of my favorites. I'm from Utah, and there was a school that failed called Wasatch Institute. It failed for financial reasons, not because of its attempts to get open source mentality into its students, but they tried it. And Penn Manor in Pennsylvania, let me tell you, they're killing this. They're doing the right stuff. They have understood what the future is, but we don't have enough of this. A few examples, we need more. All right. You probably know this as well, right? Open source is the new CV, the new resume. I have been a hiring manager. I've hired scores of employees in my day, and I'll tell you how I hire people. I like seeing their resume, but the ones I end up hiring are the ones that I can see what they've done. I see what code they've contributed. GitHub, these guys sitting right outside here, gosh, they're smart. And all of those people that I go to find out what they really can do as a potential employee, it's because I can see what they've done on GitHub. We can as this changes, we need to make sure that the students understand this and that they're putting what it is that they're learning out on GitHub. Now, let me tell you a sad story that I'm embarrassed to tell you. I don't even know if I'm authorized to tell you, but I'm going to go out on a limb and tell you anyway. At the university where I teach, they recently rescinded the diplomas of students that had graduated from the university because the department found out that they had posted their code on GitHub. That's a travesty. Now, I know why they're doing that, right? What they're saying is the students are giving away information about the courses and the answers to the tests that are going to be taking place at the university, and that's a violation of their contractual obligations with the university. I understand that. But students need to be allowed to put what it is that they're writing out there for their own benefit, for the benefit of their peers, and for the benefit of anybody who might stumble on it and say, holy cow, look what this person has done. This is going to be instrumental in solving the next great problem. We need to be more open about this stuff. And this approach helps employers to know who the smart ones are, who's going to really be able to solve the problems at my place of employment. All right, so turning people into programmers is one thing, but turning students or newbies into contributors is hard, right? Getting programmers to contribute is hard because they might not know where their interests lie. They have to figure out, well, where do I fit? And then not after they figure out what they get interested in, then they have to get inserted into the project. And depending on the project, that might be a big hurdle, right? Now, we're all grateful that Linus has taken a class on interpersonal relationships. But before that, trying to contribute to the Linux kernel was a Herculean effort. It's reserved only for ninjas and rock stars. They're getting better. I'll tell you, Greg Crow-Hartman has done a lot to help Linus figure out what it's like. All right, so I've got a little metaphor of hurdling, right? Hurdling is typically, the running part of hurdling is a generally easy thing to do, right? You just kind of control fall forward in a fast way. And you get to the part where you have to jump over something, and that might not be very easy, right? All of a sudden you have to kind of leap, and you have to leap at a certain height, and you have to leap with a certain amount of timing, and if you miss, it hurts. This is a lot like trying to contribute upstream, right? And I've got a few examples here. This guy didn't make it. This happens to be in my backyard. This is at Brigham Young University. This is the steeplechase event. That's BYU typically generates some really good steeplechase competitors. But this guy didn't make it, right? That hurts. And this guy, obviously, that hurts, right? That's the same thing as with contributing to an open source project, right? Programming is pretty natural, right? I learned how to do this in school or from that book that I read. But contributing upstream, it doesn't come quite as naturally, and it sometimes can be hard. And trust me, when you fail, it hurts. Right? Somebody flames you, somebody makes it sure that you are not interested in contributing anymore. We got to change that. That's on us. So where can we make the biggest impact? Some of it's in the schools, right? Students in China and Thailand start programming in grade 3. Do I think that's the answer to the United States? No. I mean, there's some good and some bad, right? There's pros and cons to this. I get it. But I'm trying to tell you with this, students in China at grade 3 outperform United States seniors in high school on standardized computing tests. We got to do something about that. And I'm not saying we got to start U.S. students at grade 3, but we got to do better about this. 88% of global businesses can't fill positions. We got to do something to fix that, right? And there's a huge pipeline, and it's fairly well defined, right? If we can get people started earlier, they have a better chance of succeeding. It's harder to train people. I'm not saying it's impossible. You can teach an old dog new tricks, but generally speaking, the earlier people start, the more they latch on to those kinds of things. And so let's get this kind of thing going at a younger age, and get students interested in the open source projects that exist. Well, let's think then for a minute, though. The schools aren't necessarily interested in open source, right? They They need the money to do the educating, so they're going to follow the money. And the schools that can't get the money from government, they get it from industry, or they go without. And we had a great talk. Thank you, Dr. Richards. What? Sam Coleman, thank you. How did I forget your name so grotesquely? I don't know. Great talk yesterday about his secondary education approach to handling this kind of stuff, right? And we got to get the industry to understand this, right? If 88% of the jobs are going unfilled and 73% of the industries need open source talent, then let's get these schools to understand it. Let's get the industries to push back and get them to be supporting open source. But I recognize that we have a limited control over this. Maybe we've got more. Maybe there's somebody here that is, Tim Apple's, he's called Tim Apple now, right? Yeah, President Trump calls him Tim Apple. Isn't that great? Yeah. So Tim Cook's right-hand man is probably sitting in this room, and he's going to go back and say, yeah, that Craig Gardner, he says, we need to change our song. Do it, right? I'm not very hopeful that we're going to have a huge influence on industry to change their tune, but I'm not giving up home. If we did control the classrooms, right, I teach this stuff at the university, and I want other schools to do this. So Oregon State does this, and San Diego State's starting to do this, right? We're doing better at this, but we've got to get more university environments and secondary environments to use open source in their curriculum. Pick a project. Have the students pick something that they can contribute to during the semester. Lots of variety, from easy to hard, that can match your student's skill set in a real-life environment. Okay, we have to put the fundamentals first, right? We got to teach them that this is syntax and this is structure and this is classes, right? We understand we got to start with basic, but as you're moving along, get them to where they're actually contributing, not to some arbitrary, contrived coding example. Pick a project that matches your interests and that matches your skill set. Have your class assignments modeled after what's going on in the open source. Now that takes time and energy from the instructor, but some of us are willing to do that. Recognize and reward collaboration. Yes, you need to be able to say, okay, you understand what an algorithm is, I'll give you an A on that assignment. But get to where you are having the students working together, because that's what the real world does. Takes effort, takes time, takes patience, but good instructors can and will do this. And the last thing is, don't punish failure. I hate giving students C's and D's and E's. Failure needs to change. We've got to start teaching these people that failure is simply an element of success. It's part of the process of success. Now, it's okay to tell students, oh, yeah, well, that didn't quite go the way you intended it to, right? What did you learn from it? And move from there. Instead of saying, sorry, you didn't cut it. You suck. What good comes out of that? All right, it might motivate this few number of people, but it doesn't. It just doesn't. That's not human nature, to have someone tell you you're a failure and try and pull success out of that. So start with programming, but solve real problems with real software and give them a grade based on how well they progressed, right? Demonstrate that failure is part of success. As far as Nietzsche was concerned, I don't buy a whole lot of what else Nietzsche said, but he was pretty good when he said, that which does not kill me makes me stronger. Yeah, that's decent, right? So let's move on then beyond the classroom, outside of the classroom. How do we get into here? Yeah, we're going to have some involvement in classrooms. We're going to have our kids. We're going to have our neighbors. We're going to have our grandkids. We may even be teachers, right? We may have some involvement in the classroom, but how are we in our jobs, in our spare time, going to make the biggest difference? Outside the classroom, we have to be the recruiters. Let me tell you something. I know I'm going to offend somebody when I say this, but recruiters in the tech world are not very good at their job, right? They just don't know what we know, what it takes to hire someone in the industry. Now, there are exceptions to this, obviously. But generally speaking, recruiters know how to gather resumes and search for keywords and try to line them up. But we are the recruiters. Let's make the industry a place where people want to come and contribute and be part of, right? We need to be inclusive. Instead of the flame wars, instead of telling people, yeah, where did you learn to program? That is the worst example. There's no way I'm accepting your contribution. We're driving people away. We need to be more inclusive. Hey, that was pretty good. Now, let me tell you, there are a few things that are missing from this contribution that you're trying to make here. And let me try and help you understand what it is that needs to happen for us to be able to accept this contribution. We need to be inclusive in our communities. We need to encourage and not discourage. We need to make sure that we follow our own rules and make sure that our code is maintainable and good, right? It doesn't have to be perfect. We get it. We're coding against deadlines, and we're not all rock star programmers, but we need to make sure that our code is maintainable. We need to write our code like the one who's going to come after us is a homicidal maniac who knows where I live. Be kind in how we code stuff and not say, well, whoever comes behind, that's their job to figure out what crap I put together. We need to hold ourselves to high standards, and we need to live by them. Do we have standards? Sometimes we do, sometimes we don't. Okay. Parting shots here. I didn't do this. This came from a Google search, and I put the references, the links to all of the images that I've used in here, either on the pages themselves or in an epilogue here at the end of the slides. But we would love to have ninjas. We love to have rock stars in our organizations. And we may run across a few, and you may even be one. But most day-to-day accomplishments are of that middle-of-the-road, good enough variety by your staff programmers who are ordinary mortal humans. And so we need to invest in mortals and make sure that they feel like they have a place to go and that they're welcome, and feel that they have the means whereby they can get better, and feel like that they are contributing to solutions and not part of some vast set of problems for which we ostracize them. And as we invest in those mortals that are doing the day in and day out grind of solving some of the world's most challenging problems in technology, if we tell them they're doing a good job, and we encourage them, and we make them feel included, and we certainly correct them and make them feel like, yeah, you can do a little better, let me help you to do that. As we invest in that way, we will probably have a better payoff in the long term and even in the midterm than going out and trying to hire the ninjas and rock stars. And the simple truth is, in the right environment, with the right encouragement, we may even grow a few of those ninjas and rock stars in our own organization, if we do it right. My call to you is to find someone, whether it's a young person or some sort of newbie to the industry, and become a mentor. Now, I'm being simplistic here and talking about code.org. That is certainly not the only place, right? And we all have our problems with Scratch. But whoever it is, and whatever their skill level, whatever that he or she may be willing to do, find that person and teach that person not just how to program and code, but inspire that person to contribute, to be part of something cool, to become part of a community of software engineers, to find some open source project that interests him or her, and to start figuring out what it takes to contribute. Now, this might not even necessarily be code, right? There are lots of ways to contribute to these communities. Graphics, project management, processes, a variety of different things that are part of the overall engineering strategy. And then lastly, I would say, to the extent that you're able, you're already spending a lot of your free time coding, aren't you, right? You're coders for your jobs, some of you, not everybody, right? But you're involved in this, in technology to some way, shape, or form in your day-to-day job. But then you go home and you do something that interests you. As part of the free time that you spend, find an opportunity to vest yourself in a school. Now, it might not be a big thing, right? It might not be donating 72 Dell Latitudes to the school so that they can have a better lab, right? You might not have the means to do that. But go find that high school teacher. Go find that junior high school administrator and say, I'm in the business, and let me tell you about open source. And not only am I just going to try and indoctrinate you in open source, but let me come once a month and donate some of my time with your students to help them understand what open source is and where it's going and why it matters and how it will matter to the open source environment, but how it will help those students to become better at what they do. Whether they end up being full-time programmers at IBM or at Microsoft or at Apple, you don't know. But they'll start to understand the ideals and the values of open source. And they'll start to understand that life is a team sport. And they'll start to understand how to collaborate. And they'll start to recognize, hey, somebody cares about me, and someone is vested in me, and someone's encouraging me. That's what open source is about. This means something. I think the world ahead of me is worth working toward. I'm going to do better. I'm going to get better grades. I'm going to get involved better. You'd be surprised what kind of influence you can have in the schools. Now, if you've got the 72 servers that you want to donate, yeah, do that too, please. That's great. The schools need that. But the real love that we have to share comes from our sharing our time. And you may not care about those snot-faced students today, but if you spend a little time with them and start helping them to understand what this is and where this is going, you'll start to see that, yeah, this is that future rock star. This is that future ninja that's going to make a difference. So I leave that with you, hoping that what it is that I've said today is meaningful and helpful, and I would love to hear what questions or criticism or difficulties that you have. Anyone? Doug's got the mic. Go get him, Doug.
Questions?
Hi. I help a lot in the schools.
Thank you.
But I'm a little concerned about one thing. So what I help with a lot is the robotics programs that are huge in the schools these days. And it's got a lot of kids interested in STEM. But what I see is very little to no open source component of that. It's all proprietary software. It's all run on Windows. And little microcontrollers, but there's no open source component. Have you experienced that or know any way around that?
I'm sympathetic. Now the Lego folks, what's the name of their C compiler that they use? NextC?
Well,
NXC, right? Yeah, NXC. That's pretty good, but it's not open source, right? But it's general enough that what they're learning in NXC can be meaningful, but I don't know. They're not using NXC to program it. What are they using? It's that other language.
So the organization that runs the biggest one that I know of is called VEX.
Yeah.
And it ticks a lot of the boxes for the kids, the collaboration part, the STEM part, but the open source, there's not even close to that. It's very closed source and proprietary, and I'm kind of disappointed with that, and I don't really know how to get around that. Because they have this huge. It's almost like how everybody uses Facebook, and it's like, you got the whole network type thing going on where there's a ton of people involved, and to try to make something separate from that that is open source, is a big uphill climb, right? Because you're working against this network effect, right, where you got a ton of people involved already. So,
and my only answer to that, I don't have an answer to that, right? if those companies that are coming along start to see the Microsofts and the Googles, Google's a double-edged sword there as well, right? They love open source to a certain extent, and then they hate it, right? And they're writing all of their own proprietary stuff. It's a balance. But Apple and Microsoft and IBM, right? IBM buys Red Hat. They're committed to open source. Some of the other companies will start to take notice, but that's not enough, right? We need to speak up, and contacting the manufacturer, contacting the producer would be very instrumental. It might be a drip in the bucket, but if we get enough drips, we can do it. We've got a response to that, is that correct? Yeah. 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 Thank you, thank you. And I knew that unofficially, so have someone bolster my knowledge of that is very helpful. Thank you.
This is a little bit more of a comment than anything else, but along the terms of turning programmers into contributors and the Your Challenge slide, Google has this thing called Google Summer of Code for university students and Google Code-In for high school students, for open source organizations to contribute and have students contribute to their projects in a meaningful way. And they use GitHub, they do pull requests, they do things from design to project management to whatever. And it helps out your organization, it also helps get students interested in open source. So I would definitely recommend that if you are a member of an open source organization, please try to get your organization involved in this. And if you know young students, get them involved in it as well.
Google Summer of Code is awesome, and I'm so happy for that. And I encourage my university students to get involved in Google Summer of Code. There's also Outreachy, which I also give props to, right? There are a few approaches to this that pay money for students to work on open source projects during the summer. Great, thank you for that comment. Next.
Hi, I'm from Long Beach City College, and I'm part of the Cybersecurity Club and the Women Information and Technology Club. We are trying to do more open source projects for high schoolers and middle schools, but I wanted to know how to get more started and other projects. So thank you for the Dexter's. So I just wanted to know if there was any other places to go get information or Google. Okay.
We'll talk with you about that here outside outside the doors. We're glad to help you with that.
All right, thank you.
Okay. Swing the mic back over to him. Dr. Coleman's got.
One of the things a lot of people forget about is the Raspberry Pi, and so one of the things that I'm involved with is the Raspberry Pi Foundation, and they provide teacher training at no cost, but you have to kind of apply. I guess the nearest place would be in Irvine, so you might want to just go online and just, if you're a teacher, check out the Raspberry Pi Foundation. Also, we have Raspberry Pi Jams, and I'm also a member of the Raspberry Pi Club in Riverside, and we work in collaboration with this place called Vocademy, which is a makerspace, so we have Pi Jams, and so me and some of the other graybeards, we actually bring Raspberry Pi projects there, and we get middle schoolers, elementary school kids, high school students interested in these different projects. So I've done that and collaborated with Harvey Mudd University to do some of the same things at schools like in Upland and Rialto. So if you're interested in that type of thing, get in contact with either your local Linux users group and your community, because there might be somebody who's a Raspberry Pi guy or gal. Or if you guys have questions along those lines, give me a call, because sometimes I'll bring projects to different schools, and I'll show kids, this is how you make this is how you make that. I mean, there's lots of options out there. You just have to, reach out to, people in your community. But I would always start with the Linux users groups in your neighborhood, so to speak.
And those pies are cheap, right? I mean, if you want to make a big difference with a small amount of money, not every middle school or high school has a teacher who would welcome a gift of 5 pies, but there are plenty that would just die to have that kind of a donation to help spur the interest and curiosity in the students beyond a Facebook consumer perspective into the creative contributor realm, which we really need to have. Next question.
So in this education process of trying to expose people to open source, do you think that this is the right time in the process to kind of let the people know about kind of misleading open source pitfalls? You know, like, oh great, everyone's using Linux, but we're all using Google Docs. Like, or is that like down the line too much, or like what do you think?
What do I think? I think that you have to be a realist, right? Google Docs, it has changed the substrate wherein we write and that we collaborate. We certainly hold some resentment for the fact that they're not willing to keep that as an open source environment, but it is a collaborative world that they're trying to promote, and I think that they should be applauded. And then every now and then we just kind of dig a little bit and say, come on, open source or not? Yeah, good question, and certainly worthy of criticism.
Hi, I'm volunteering once a week, every Friday.
Thank you.
Teach programming to second grade kids. And I've been doing it for the last 3 years. But what I notice is after they move on to third grade, they don't receive any more training or teaching. So I wonder if somebody have an idea what's the next step, what should I do? This is in LAUSD, it's a second grade kids and in somebody.
So I can't give you specifics about the Los Angeles school district, right? And there are thousands of them. At least throughout California, there are thousands of them. In my experience with school districts in a variety of different settings, the pressure from outside helps, but what ends up helping more is to find someone inside the school district to champion it, right? So if this lower grade educator is buying into this, but it's not getting upstream enough, give that lower grade educator some tools and some help and some insights so that he or she can start pressing, saying, hey, the middle school needs something like this. I'd be glad to help organize it and implement it there at the middle school or at the high school level, right? You've got to get some of that rallying within. The pressure from outside is always a double-edged sword. You know, going to the school board meetings and clamoring, oh, we got to have this, usually makes the school board dig their heels in and say, you don't understand my problems, buddy. But if you get somebody inside that can own it, you can go a lot farther with that. Dr. Coleman's got another thought about that.
Very effective way to kind of like bring positive pressure, get the parents fired up, because parents want the best for their kids.
All right, and I think we got to cut it off.
Okay. Thanks for coming. I really appreciate your attention, your attendance, and enjoy the conference. Thanks.
Hello, 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 hello. Perfect, perfect. And Doug, do you have any slide, the thing to pass the slides, or no? We'll just go from here. Looks good. Should we get going, Michelle? Should we start? It's 12, right? Good morning, everybody. Thank you for coming. How many of you guys are from the healthcare industry? Good, good. So today we're going to talk about libre software and free software and GNU Health, specifically for the public health sector. I mean, of course, we can deploy these in private institutions, but the idea is building large health network in a country or a region. About GNU Health, it's pretty much a social project. That's the main idea of the project, is to deliver health and education with free software. And it has very cool technology behind it. But we cannot forget about the social project part, because there are many cool technology projects around that don't take in consideration the social part. So who's behind GNU Health? It's GNU Solidario. This is an NGO. This is a group picked from a GNU Health Con in Gran Canaria last year. And again, the main idea here is to deliver health and education with free software, and GNU Health is one of the projects that we do. It is an official GNU package, and one of the main focuses we have is it must be, all the components must be libre software. Because at the moment that we find one that is not free software, the whole chain goes down the drain, right? And we just had to actually, a month ago, have to change MongoDB for Postgres on the health information system, because they changed the license and there were a lot of issues with MongoDB and the license change. So, but lucky enough, we have another DBs that work very well in that scenario too. So we were able to move to Postgres 2 on the health information system. So GNU Health is an ecosystem. It deals with different areas of work. We always start with the person and the community, domiciliary units, health institutions, and so on. Then we go to the traditional patient-doctor relationship. We also take care of the hospital management, stock management, finances, pharmacies, hospitalizations, and so on. And at the end, we want to make sense of all the data that we've been collecting through all these transactional systems and bring that data to the health authorities so they can improve the health promotion and disease prevention campaigns, among other things. This slide shows a bit the main components or the main projects within the GNU Health umbrella. So the first one is the hospital information management system. We also have a project that deals with GNU Health Embedded. The same functionality that we have on the HIS, we have it also on the Raspberry Pi. And also for LIMS, Laboratory Information Systems. We have the federation, which will be part of, we'll be talking today. A work in progress is the mobile application. And we also deal with bioinformatics, all these molecular basis of disease. Very quickly, these are some snapshots of different functionality that you will find on this ecosystem. Okay? So from the very transactional system that you have running in hospitals and health centers around the globe, to reporting, to imaging, lab, cameras, and so on. Agendas, calendaring. And now let me talk specifically about dealing with large implementation. One of the issues that we have today, and we'll talk about it now, it's that most systems in the health arena are silos, meaning they work in a way that they don't share data between each other. So we try to do something that deals with distributed networks of autonomous nodes. That means every single node is independent, and you decide what type of information you want to share with the federation itself. So in case of, there is a network outage, nothing really happens because you still are independent. You will be able to run your health institution without the network. And this is done through these three components. So on the left side, you have the nodes, which can be a hospital, it can be a person with their application, it can be a research institution or a laboratory or whatever. Then you have a message and authentication server, and finally you have a health information system that also deals with patient and person master data. The way that we deal with information on the health information system is a bit different than the way that we deal in a transactional system. It's semi-structured. Okay, it's data that is good to make sense out of it. It's not a transactional system per se. We have already that on the LIMS, and we already have that on the hospital management system. Now we want something that it's easy to be read by humans and by machine. And it's also easy to share among the different nodes within the federation. So I came with this concept of the Book of Life. And the Book of Life, it's made of many pages within the person. And here you have different categories and pages. So you have pages that represent a medical context or an event, demographic, biographical, and social. And within those, you have categories. So on medical, you have health condition, genetics, encounters, and so on. And the social, again, this is a social project. We talk about all the socioeconomic determinants of health and disease. Whenever you do something on the transactional system, whether it's your lab information system or whether it's your hospital information system, immediately it will create or update one of these pages of life. So you don't have to be doing double job. The main information collected on the transactional system, it will create this page of life, which then will go to the federation and be shared. Of course, provided that you give authorization for that specific model to be shared on the federation. It's a very simple way of dealing with complexity, because you need something that, when it's in this health information system, it can be easily grabbed from different heterogeneous systems. So we deal with this transdisciplinary approach to health. Now we have many people, doctors, nurses, psychologists, social workers, persons, patients, community members, feeding the federation and feeding this health information system. And if we don't do that, we are dealing with a reductionist system. We would be more on a system of disease instead of a system of health. And we need to have a holistic picture of who we have in front, not just the medical records. Medical records, it's the consequence of something that we have been doing wrong to have somebody sick most of the time. So let me put you an example dealing with genetics and the molecular basis of disease, and in this case, cancer. What you're seeing here are different natural variants of the BRCA1 gene. BRCA1 gene, it's involved in breast cancer. And here we have about 70 different natural variants, or in different positions. You have amino acids that change, and that will make it a conformational change within that protein, making it not functional and making that person more susceptible to have cancer. Now, what we can do with the Health Federation is contextualize all that information. Because, you see, it's easy when we know what are the clinical implications of specific natural variant. Then, if we have that list, we know, well, this is quite benign or this is pathologic. And then we can do something about it. But what happens is most of the times we have natural variants of unknown clinical significance. And that's where the problem comes. You send somebody it's genotyped, and it comes a mutation on that specific gene, but hey, we don't know whether that variant is pathological or not. And one way to tackle this is having a federated network. And multiple information coming from diverse nodes across the country or even across the world will be able to say or make a correlation between genotype and phenotype and knowing, hey, now we can find a direct link on this specific mutation that we didn't know before whether it was pathologic or not. And the GNU Health Federation is a great tool to deal with this type of things. Big data, a lot of information coming from different, and not only the molecular basis. There is a lot of stuff into the epigenetics and the lifestyle and nutrition and other things that we should take into account in order to have this global idea on a specific mutation. This mutation will be to contextualize to this person. So now if you see this slide, not only we have the gene, we have the locus, we have the protein code, we can go and see the amine information, we have the family history, but we also have the lifestyle of the person. Okay? So putting all this together will provide good information and be able to tackle that specific mutation within the context of that person. So now, as you see here, we are going to be able to deal with each of these nodes, each of these participant people or health institutions or research institutions or social workers put the information contextualized to this person. We also need a way for not only GNU Health, but others applications to be able to retrieve and feed the GNU Health Federation. That's why we provide Thalamus, which is a Flask RESTful API that allows you to send information and retrieve information and update information, no matter which system you have on the other side of the federation. And this is what I was talking before. You know, most of health systems today are silos. You log information in, and that information has no value whatsoever. In many places, I don't know where here in the States, I think it doesn't differ much from Europe. If you go today to Health Center A because you had a knee issue, and tomorrow you go to Health Center B, you will have to provide again all the information because Health Center A doesn't talk to Health Center B. They are silos. And I know this not only as a person, because I'm also a health professional, I'm a physician, and if somebody from Barcelona comes to the Canary Islands, I have to start from zero, her or his health history. You know, private institutions don't talk to public institutions and vice versa. And GNU Health Federation will actually break these silos thing, you know. So right down here, that's the Canary Islands. When I asked to do this, I said, hey guys, make sure that we are still here because we're far away from Spain in every single sense of the word. So why don't we do this? Why don't we have a public health system, first of all, with free software? You know, Free Software Foundation Europe came with this beautiful saying that public money, public code. You know, not only for education, but also for health. Now, not only benefits on being able to read the code and empower the health institutions to make that program their own, but also there is a lot of saving in licenses that can actually go to benefit the public health system. Also, as a physician in the public health systems, you have pretty much 7 minutes per patient. If I already have the history of the person, I'm saving a lot of time, and I can put that time to actually improve the encounter and the care of the person that I have in front. You know, we are also becoming over-sophisticated, and we are getting rid of the human factor, and that's something that we really have to face and improve in the healthcare arena. So now with this proposal, now with this model, no matter where you go within Spain, the information will be updated automatically. And now if you go from Health Center A to Health Center B, your information will be fresh and not obsolete, as it happens in the other places, in the other cases. Most cases, by the way. So this is what we propose to our government officials to, of course, move away from private software on healthcare and public administration in general. And we already have a solution. You know. It's just a matter of having the will of moving away from proprietary software. And if we do it at national level, why not we can do it worldwide? If I'm here now in the States and I break my knee, God forbid it, I will have again to give all my clinical records to the US health professional that sees me. Now, if we have this in place and we have a unique ID per person in the whole world, which is perfectly technical achievable, that wouldn't happen. The doctor will just ask for my ID or get my card, and all my clinical information would be there, provided that I give permission, of course, for her or him to read it. You know, it might look a bit utopian, but this is something that it can be perfectly done. I think that the unique person identifier is something we really need to do worldwide. Now, why choosing OpenSUSE, or why do we work with OpenSUSE on this federated model? Well, first of all, the guys from GNU Health and GNU Solidario are also part of GNU's OpenSUSE community. They are already the packages, both on lib and tumbleweed, and it's well documented and well supported. So, as I said, you can install GNU Health on tumbleweed, which is the rolling release version. That's the one that I usually have. And then for production, you move to lib, which will give you more stability. And for large implementations, you can actually switch that lib implementation to SUSE Linux Enterprise, and that will provide professional support. Again, you know, I get a lot of calls from people that install GNU Health in hospitals, and this is not a word processor. This involves a lot of things, from performance to security to privacy, and you know, we're dealing with people here. This is serious. This is something that you should have a technical department that knows about databases, operating system, security, encryption, to make sure that that implementation runs smoothly, because we do the best we can to provide something that is kind of easy to install, but if you don't have concepts on databases, you shouldn't be installing GNU Health. Ask somebody that knows how to run databases, how to make backups, how to know that that information, if something happens, you know, you have standby databases, you have replications, and so on. If you have those people, then perfect. Otherwise, ask for the people that knows to install you GNU Health and run it. GNU Solidario does not provide implementations because we are an NGO. We are focused on you know, dealing with the community and, of course, the development of the software. We work hard with local people. We have Dr. Roof here from Jamaica. They have their own team in the Ministry of Health. That's what makes a project sustainable. You cannot go there, make the implementations, and leave, because that will not work unless you have capacity building locally. And also, OpenSUSE has been showing commitment to the GNU Health project, not only by providing, you know, support and packages, but also, you know, being sponsors and donating. You know, the Raspis are being donated by OpenSUSE. I'm going to Haiti now, and they already have these Raspi computers that will be placed in a local hospital on a GNU Health implementation. So we are very grateful to the OpenSUSE community for all the commitment shown, continued for the last years, and that's why we are actually here. They invited us to give a talk on GNU Health and OpenSUSE. We also have, talking about OpenSUSE, we have this Federation Community Hub that allows the community to actually log into this public server and play around with the hospital information system, play around with the laboratory information system, play around with the federation, and so on. Not only developers, but also health practitioners and research institutions. This server restarts itself every night, so no matter what you put there, don't worry if you break it. In a couple of hours, we'll be up again with some demo data. It's just more to get a feeling of what is GNU Health ecosystem about. And finally, let me just glimpse about real implementation projects. We go from small clinics in the rainforest in Africa. In this case, this is Cameroon, where they have small hospitals that cover specific area in the rainforest, to very large implementations. AIMS is the largest hospital in Asia. It takes over 1 million evaluations per year, and they adopted it a year ago, and it's been done by them. They have a huge IT staff department, and they are autonomous, and that's what we need. We cannot be behind. I mean, in the case of Africa, sorry for saying Africa, in the case of Cameroon, yes, because these guys don't have an IT department, so that's part of our role to provide them support. But these guys have huge IT. They have over 50 people just working on the IT department. So they install it. I just went there for a week to give an overview and a bit of training, and from there they took the task. We work with the World Health Organization in different projects. This is a Bafia district hospital, but we also adopt many of WHO coding, ICD-10, for example, immunizations, pediatric growth charts, and so on. And then that was one of the training sessions that we gave to the guys of Western Africa from WHO. Jamaica, that's one of the pioneers projects. I think we started back in 2013, Dr. Roof, yeah? So it's now 6 years that they've been using GNU Health, and again, local team. They decided to build their own team to deal with the project itself. Otherwise, it won't work. I mean, these are huge public health projects that, first of all, you have to be from Jamaica to understand the context and deal with your people and what they need and so on. And second, we don't have the resources, GNU Solidario, to be able to provide, to every single implementation help. Red Cross, this is in Mexico, with over 300,000 evaluations a year. Laos Public Health also. This is 2 implementations, one at Mahosot, which is the largest hospital, and other in the CMR for rehab. And finally, we have this alliance that deals with academic institutions that want to collaborate with our project. And within this context, we have people from the University of Entre Rios, for example. They go now, remember this project that we were talking in Cameroon? They are taking over it, and people from Argentina will actually go to pick up and and collaborate with them. And that's wonderful, because that's what we need. We need to have a large community that tackles the challenges in different areas of the world. And I always thought that academia is probably the best way of finding people that is enthusiastic and that they have the time and the resources to actually do these type of jobs. So just naming Mr. Stallman, this was the very, very first project that we did as GNU Solidario, and this is over 10 years now, 13 years actually. It started in Argentina, Santiago del Estero, in the school. These kids are now full-grown ladies and gentlemen, and it's great. It's great to see that seed that we put someday there, it actually is making sense today, and that makes me very proud of this little but beautiful project that we have, and I'm also very proud and happy to be able to share it with you guys today, and hopefully some of you will join us on the quest of making sure that health remains a non-negotiable human right. Thank you very much. Thank you.
Questions? Anybody?
So the interconnect probably uses HL7 messages?
There is a project. We didn't go through every single sub-project, but there is an HL7 messaging server that connects with GNU Health in specific, for example, the lab and the encounters. It's not all of them, but HL7 Fire is the one that we are actually implementing. Yeah, HL7 Fire. Yeah. Oh, sorry.
Is there a small guide to setting up GNU Health for, say, a small clinic in the United States?
We don't have specific localization projects. We have the documentation on Wikibooks, but we don't have yet a guide for localizing GNU Health on specific countries. We have members. Actually, the guy that is doing the HL7 Fire is from the United States, and he knows well, all the specifics. The States is hard. There are a lot of things that you must comply in order to have it. But he knows well, all the requirements, and we can actually put you guys in contact with Chris.
I'm sorry, can you repeat his name?
Chris Zimmerman. Yeah. He's also working on DICOM, not only on HL7, but also on DICOM. And he's also becoming a doctor very soon. So he pretty much has everything. Oops, sorry.
I came in a little bit late, sorry, but just real quick on some of the obvious questions I think are, for use in the U.S. for HIPAA compliance, quote unquote, for in the EU for GDPR compliance. Is there encryption built in end to end? Like how far along is that? And my wife works for a large health system here in the U.S. and they're using proprietary software. It drives me crazy. Costs. So, and you did mention some of the orgs using it, and sorry if I missed it. Are there healthcare orgs in the U.S.? You mentioned the Red Cross, I think it's elsewhere. In the U.S. and using it or trying it out, and you mentioned how widespread is it? You're proposing it in Spain, I think you're saying, right? It's not. And how far along is that proposal being considered? Thanks.
Well, thanks for the question. GNU Health it's pretty much a framework. Okay, so we provide the framework to be able to deploy into a health institution or into a network of health institutions. We provide encryption, we provide digital signatures, we have the packages to connect with the GNU PG libraries, and all that is already there. It has a very fine-grained way of dealing with security and access control. But again, I'm not the right person. I just don't know well what are all the requirements. I know there are a lot, okay, for every single country. It's I know some cooperative, and this is coming from a couple of years ago, were using GNU Health within the United States. Now, when you move to the public health arena or whatever, I just don't know. We have some specific modules, for example, for Argentina and other countries. Whenever you go to a country, say Jamaica, Laos, Argentina, Spain, or whatever, you do need to have your own localization in terms of reporting, in terms of security, in terms of privacy. But that goes more into that specific context and having somebody to actually adapt GNU Health for that country. Yeah.
Any other questions?
Hi, I'm a physician as well, and I've dealt with several EHRs here. And yes, unfortunately, they're all proprietary for the most part, except for the Veterans Administration, VISTA. That's an open source project that's been around since '95, I believe. I'm wondering if you've ever reached out to them to try to interface with them. That might be a good place to start.
Yeah, we know Vista, and it's been doing very well in States. From the technical point of view, they are completely different projects. The type of databases that Vista uses, it made it a bit hard to actually interconnect. Now with this HL7 and also the Federation RESTful APIs, it's easy to send messages across heterogeneous systems. To be honest, yeah, I'll kind of check it a while ago, but it was a completely different infrastructure from the technological point of view. That we use Python and PostgreSQL, and they use MAMS and other type of databases that it kind of make it incompatible. Now with the RESTful APIs, it makes things easier. Yeah, Michelle.
Yeah, thanks, Luis. Just a couple of things. So, as you mentioned, we have done some implementation in Jamaica. The security aspect, somebody had a concern about that. What we find will work best is first defining the security and privacy requirements and use that as part of what's required to build out the system. We're still in a transition mode, as you know, working with the government and various other agencies. The other thing, though, is the Federation. I find it very exciting. The use of HL7 fire and so on. But if we look at it even on a national scale, say a country like Jamaica, 23 public hospitals, about 11 or 15 or so private hospitals, everybody will be using their own software in the private sector. Public sector is under one authority, the Ministry of Health, so we all have to use the same thing. So just interesting how to handle the data standards, etc., to arrive at that, the federation coming from the different nodes, and how that might work out.
Right. So, in terms of privacy and security, that's a great comment, and that's what I was saying before. We shouldn't rush to implement the software, because this type of software requires a lot of design in terms of human resources. Who can do what can do each health professional, what can do the patient. And you do that before actually implementing the software. You do that on paper. And once you have that on paper, it's easy to map it into software. Otherwise, you are compromising the security and the privacy of the data that you have in your health implementation. But people usually tend to rush and just install it. And then the problem is they have to go all the way back and do a rollback and waste a lot of time. So yes, designing it's key, not only for security, but also in terms of scalability, what type of software, what type of infrastructure am I going to put so we can actually scale for the next 5 years or whatever, you know. The messages, there is, we have designed on each of the resource and endpoints the type of message that you will send on each method. So if I send a put, if I make a put, or if I make a patch request, you need to know what are the specifications on that message, how it will go. Okay? That's how the federation works. Now, if you use the HL7 Fire server, then that's the coding specification is already there. There are pros and cons always. You know, if the way we do it is it provides you maximum flexibility, so the people that is making the mobile application for GNU Health knows, okay, if I want this node to be part of the federation, how am I going to send the message of a new encounter or a new domiciliary unit or whatever I want to do with it, or a lab test, you know. But it's clearly documented on Thalamus. So it's just a matter of going there and say, okay, this is the way I need to send the message. It's JSON-based, by the way, all the messages that we send and receive. And we love that standard. It's very nice and quite universal too. But it's documented on Thalamus. Yeah. Any other question, guys?
I noticed the previous slide mentioned the lab information system. Do you guys have a lab information system, or are you interfacing to an external lab?
We have, I don't know whether I have a slide here. No, I don't think so. We do have a LIMS. It's actually called Occhiolino. Okay, and it's a lab information system. Actually, in Ghana, they are using it today specifically as a, sorry, Gabon, as a lab information system. Okay, so it interfaces with the hardware, with the analyzers, but all the processes within the lab are already there. Okay, so sample and everything is already there, and you can print out the results. So it's a LIMS by itself, yes. Independent, yeah.
Any other questions? All right. Thank you, Louis.
Yeah, thank you. Thank you, guys. Thank you, guys.
Test. Test, test. Test. Okay, is the microphone working? Yes? Okay, thanks. Okay, maybe better now? Okay, now I know where to place it, thanks. I'll be showing some code snippets, so if you don't have good eyes like me, then I would recommend sitting in the front. Sorry? No, don't need to. Thanks. Okay. Okay, so it's 1 p.m. Let's start. Welcome to my talk about buffer overflows and mitigations. First, let's start with the obligatory Who Am I slide. My name is Johannes Segitz. I'm a security engineer at SUSE, and I'm based in Nuremberg, Germany. It's my first time in LA, and finally I see some sun because I made my wife jealous by telling her, hey, I fly to LA, and then it's raining all the time, which was kind of annoying. Okay, my main daily tasks are code review and product pen testing, and that's the reason why I'm interested in those mitigations, because they make my life easier or harder depending on which side I'm currently on. I joined SUSE in April 2014. That was a great time to join SUSE because that was the exact day Heartbleed broke. So joining a security team was really the perfect timing there, no panic at all. Okay. This is the outline what we are covering today. We will talk about buffer overflows and how to protect against them. We will talk about stack canaries, Fortify source, ASLR, and no execute memory. These are all used by SUSE products. There are other protection mechanisms that we are using, and of course these are also used by other distributions. This talk will require some C and assembly background. I will explain most on the fly. If you space out at a certain point of the talk, don't worry, we will cover those 4 areas and you will be able to resume, hopefully. Yeah, at least my hope. And please stop me if I'm going too fast with the examples. We will probably need almost all of this hour. So if it's going too fast, please tell me so. We will have to keep going a little bit faster than usual because usually I do this talk in 1.5 hours. This is also, of course, just a short overview, so you're not going to be elite hackers after listening to that, but that is usually the case if you go to a talk. You are never experts after hearing about a topic for 1 hour. And I will also try to keep it at least a little bit interactive. That depends on how much time we have, and it also depends on you. So if I ask questions and no one answers, I will stop with that. So if you don't want me asking questions, then just stay quiet. Okay, so we are talking here about stack-based buffer overflows. There are other kinds of buffer overflows. The stack is a certain memory region in a process that is used to handle data. This is usually a problem in languages where you manage your own memory. So especially C. If you have a language like Java or Python where memory is managed by the runtime, then this is usually not a problem. And if it's a problem, then it's a bug in the runtime or virtual machine, can be fixed in this one component, and then everyone is safe. On the other hand, with C, we will probably never run out of buffer overflows because managing memory is hard. So this is a really simple example here. We have a small program. It has a statically sized buffer of 20 characters, so usually 20 bytes. And then we copy the first argument given to this program into this buffer without any size check. So this will work until we give it more than 20 characters on the command line, and then it will start crashing. So this is really the basic principle of what we will see here. So the general mechanism is that you have a given buffer size and you put too much data into this given buffer. Usually the problem is that you are just missing a size check. So if you think about the example that I just showed, there was no check at all for the size. So whatever size the argument is, it will just copy it in there. Sometimes you have a check, but it's either faulty or it can be circumvented. And circumvention, usually it involves some form of integer overflow, so you might have a multiplication in the check. The multiplication might overflow, you don't check what you think you're checking, and the attacker can still use the buffer overflow. So why is this a problem? I mean, you could think, well, we overflow some data, why do I care? This is a problem because in our architectures, we mix data of our applications and control information about execution on the stack. So here's a really simple example. We have two functions. We have a function A, we have a function B, and function A calls into function B. And so this data structure called the stack currently holds the local variables of function A. So we are here before we invoke function B. And now if we call into function B, we first place our parameters we want to have for function B on the stack. And then we also place the return address where we want to continue execution after function B also on the stack. So if a buffer overflow happens, you can overwrite this control information. And if you overwrite the control information, you can execute arbitrary code. But only if you do it carefully. If you just do it blindly, you will just crash because you overwrite this control information and the program doesn't know what to do with that. So this is a little graphical representation. So if you do that carefully by first adding a knob sled, so knobs are instructions that don't do anything, not no operations, and then have your exploit code and the return address and take care that you overwrite the return address that is stored on the stack. Then you might jump back to your knob sled, fall through to the exploit code, and then run your exploit. That is not the only thing you can overwrite. So RIP and EIP are registers in CPUs that store the currently executed command or the address of the currently executed command. And you're not only able to overwrite this, but you can also overwrite, for example, function pointers. So if you use a function pointer in your code and I'm able to override it, the next time you invoke this function pointer, I'm in control. You can override exception handlers. So an exception handler also has an address stored somewhere on the stack. If I'm able to override the exception handler, an exception is triggered, once again I'm in control. Sometimes you don't even have to override these control information. Sometimes you can just override some application-specific data. So maybe there's a flag that indicates if you're a privileged user or something like that. If you're able to write whatever represents true into that field, then you might already have won. So what can we do against these problems? The simple solution would be just use Java for everything and we're done. But based on the reactions, I think you also know that that's not really helpful or happening. First of all, we have a lot of legacy code that we will continue to run, so we can't just port everything to Java. Also, I don't like Java. And the next thing is that for some applications, you just need low-level access, and that usually requires you to have some ability to work with memory directly. So let's dive into a simple 32-bit exploitation example. So we basically have a main function that calls a function that is helpfully called vulnerable. It has a statically sized buffer, and it reads too much data into this buffer. And we will now exploit that. So that is why I mentioned maybe come to the front if you have bad eyes. I'm not sure how readable it is for you. It's readable for me, but I'm standing here. So if you can't read it, just come a little bit closer. I mentioned that we have some exploit code or some shell code that allows us to run own commands. So in this case, we have a shell code that adds a new root user to the system. You can either craft that by hand, or you can use a tool like MSF Venom. This is a tool shipped with Metasploit that helps you to generate shell code. So this nifty thing here is the shell code. That is what we actually want to run. Then we generate a knob slat. So those are the instructions that don't do anything. It's usually helpful if you have more space than you need for your shellcode to prepend a knob slat before the shellcode, because then you don't have to aim very carefully. You just need to land somewhere in there, and the knob slat will not do anything, so you fall through to your exploit and then it runs. The final thing here is that with this line, we set a static address where we think our code will be and where we want to jump. And this only works without any mitigations. And then in the last line, we just put everything together and run it. So let me jump to the next window. Currently, we don't have a new root account on the system. And now we will run this in GDB. GDB is a debugger on Linux. I use a little extension called PIDA that's helpful for exploit development. You will see a lot of colors right now. So let me cover that briefly, because we will see that a few times. Up here, oh, okay. That is not great, because my screen is actually at a different resolution apparently. Okay, I'm sorry for that. The problem is that I have my screen here set for the exact same resolution as the projector, but for some reason you see something differently, so you should see a little bit more, just 2 characters. But we'll have to deal with that for now. So here we have the registers that are currently used in the processor. Registers are small variables in the CPU. They can be accessed very quickly, and they are used for various calculations. Down here we see the current assembly instructions, so where we are currently executing, and this is the command that will be executed next. Here we have the stack, so the structure we want to overflow. And if we now continue with that, so every time I press a key, we will step 1 step further down here, and potentially something changes here, which will be indicated in red. We step through, and at this point you now see that we are at the read instruction. So if you remember the code that I showed you before, at the read instruction we will cause our buffer overflow because we read in too much data. So if you look at the stack, you don't have to remember what's exactly here, but if we step over the read instruction in the next step, you see that a lot changed, and you also see those 90 hex values. So this is our knob slat where we actually want to land. Stepping a little bit further, we are finally at the red instruction, which returns control to the previous function. And the red instruction will take the topmost stack value and start execution at this place. And PIDA has this helpful feature, so it shows me directly where it's pointing to. So it's pointing directly into our knob slat. So if I step 1 step further, We are right here in our knob slat, and if I continue execution, then we will see that we now have a second root user on the system, and we're also able to log in here and have root privileges. Okay, so that was the good old days. Exploitation was really easy, or the bad old days, depending on which side you're on. The first mitigation we will talk about are stack canaries. So you see a little canary here. The name comes from canaries that were used in mines to alert miners of the buildup of deadly gases. And stack canaries basically do the same for software, so it alerts you for stack overflows. The general idea is that the compiler generates some extra code that puts a so-called canary value at a certain location in the stack frame. And before we return from the function, so before this red instruction that we just saw, we can check if this canary value is still untouched. And if it's not untouched, we can bail out. We have 3 different canary types. They are so-called terminator canaries. They consist out of a null byte, a carriage return, a line feed, and -1. And the reason behind that is that you're usually not able to write those bytes because they are not really friendly to string handling functions. Then there are random canaries. So you just generate a random number, write it there, and the rationale is that the attacker doesn't know this random value, so he can't write it. And then there are so-called random XOR canaries. So you use a random value and XOR it with certain data on the stack that gives you a little bit more entropy. We have not 3 as it stands here, but 4 different variants in GCC. So that's the joy if you change your slides right before the talk. We have fstack protector that will add this code only for functions that add buffers of 8 or more bytes on the stack. Then there's fstack protector strong. So after a while, people noticed that fstack protector and this heuristic it was not good enough, and there were several other criteria that causes this checking code to be added. I will not go through all of these to save a little bit time, but in general, if you have, for example, an array, you will get this checking code. Then there's fstack protector all. It will just add the code everywhere. That is not very great for performance. And then there's fstack protector explicit. There you can annotate functions where you think you want to have it, and then GCC will add the code. So just a short reminder of the example code. We have our statically sized buffer, and we put too much data into the buffer, or we are able to put too much data into the buffer. This is the assembly listing of this original function. If you don't read assembly, it doesn't really matter, because this is the protected code, and now I will show you what changed between those 2 versions. The first thing that changed here is this snippet. Here we take the canary value, the known to be good canary value, and place it into a register, and then we take this register value and write it onto the stack. So here we place our canary at the value at the point where we want to check it later. And then here, after we executed whatever we wanted to do in the function, we get our canary value back from the stack, and then we XOR it with the known to be good value. And XOR has the interesting property, if you XOR 2 values, or the same 2 values together, then you will get 0. So then in the next line, we can check if we have 0. If we have 0, we jump to our normal instructions to leave the function. But if we don't have 0, then the stack canary was touched. And then we will call this function called stack check fail, which is a pretty descriptive name that then bails out. So another demo time. Hopefully you will see that what I wanted to show you. So this is a binary compiled with a stack canary. It's exactly the code that I just showed you before. If we run it and give it 12 A's as an argument, then everything is fine because we have 20 bytes of buffer. We do the same thing with 32 bytes. Then it fails, and we get this helpful message that stack smashing was detected. Can again look at this in the assembly. So if we run it here, we are right now at this place where we take the stack canary from this predefined memory location, move it into the register, and it will be placed into RIX. This is unfortunately not visible for you, but you will see it soon. So this is the stack canary that we have now for this execution. And if we now continue with our execution, we are now at the place where we check the stack canary. So in the next step, we will take it from the stack back into RCX. So right now, we have our stack canary that was on the stack back in RCX. And if you noticed, the stack canary we had before did not end in 41. And 41 is the hex code for in capital A. So apparently we overwrote part of the stack canary. In the next step, we will now XOR the current stack canary with the known to be good stack canary, and we should receive 0 in ECX, which we don't because they are not the same. And now in the next step, we will not take the jump because we didn't get 0 as a result, and we will now call the stack check fail function. And if you continue, then we would actually see it if the screen is big enough up there. So this is the interaction I was talking about. There are several limitations. Do you have any idea what the limitations of this technique might be? Yeah. Performance definitely is a limitation. Okay. So I will keep asking you because you answered. You can thank those two. Yeah. Yep.
You might be able to predict what the canary value is.
Yes, you might be able to predict it, but in practice that is rather hard. Because if you have a not bad random source, then you should not be able to do that. It depends a little bit on your architecture, but I mean, especially on a 64-bit architecture, it's going to be really rough to predict 64 bits. But of course, it depends if you have a weak source of randomness, that might happen, and that actually happened with some implementations. So, my list is, it does not protect data before the canary. So you write the canary at a certain point in the stack, and if you have local variables, for example, a function pointer on there, you might still be able to overwrite this. To counter this, some implementations try to reorder the variables to ensure that sensitive stuff like function pointers are also protected by the stack canary. It does not protect against the generic write primitive. So with some exploits or with some vulnerabilities, you are able to specify write me that value at this location. And then, of course, you just jump over the stack canary and write whatever you want to the place where you want it. You can circumvent it with exception handlers. So if you're able to override the exception handler address, and if you're able to cause an exception before we return, so before we get to this checking code, then you're still good. You can chain a buffer overflow with an information leak. So if you're able to get the value of the canary, then of course you can write it. And there's also no protection for inline function. So if you have higher optimization settings, then the compiler might start inlining stuff. And since this is all related to the function prologue and epilogue of your functions, if you don't have that because the code is inlined, then you won't have these checks. And of course, you can still use it to cause denial of service. Denial of service is definitely better than remote code execution. But still, if you run a public DNS server wherever, you probably don't like denial of service either. So, yeah. Okay, so first mitigation, 3 to go. Fortify source is a pretty nice one because it transparently fixes so-called insecure functions to prevent buffer overflows. So, for example, memcopy, memset, string copy get additional checks. I have insecure here in italics because there's this little tweet here. We tell people not to use string copy, and then they do stuff like that. So string copy in itself is not insecure if you know what you're doing. But usually you should tell people not to use functions like that, because there they can just forget those checks. In the other case, they can just forget how to use the functions correctly, but well. This only works for statically sized buffers, or at least maybe for even more situations, but the compiler needs to understand what you're doing here. So if the compiler sees you have a statically sized buffer, you're using string copy, it then can add an additional check, but you need the compiler to understand what you're actually doing there. If you do some fancy buffer magic, then the compiler will probably not understand that and will not add the checks. You can enable it with d45 source equals 2, and the interesting thing here is you need to enable optimization. Because this Fortify source magic works somewhere in the optimization stage, and if you don't enable optimization, you will not get the benefit. We have a different example here. It's based on Matthias Gerstner's work. He's a colleague of mine that uses that for our trainee trainings. And basically we have the same structure, so we call into a function, it has a statically sized buffer, and we copy too much data into that buffer with string copy. And we have that little snippet here to prevent GCC from removing our buffer. Because since we don't use our buffer, the compiler would say, well, nice buffer you have here, you don't seem to use it, so I will just kill everything here. So with that, we keep the buffer. This is the corresponding assembly. And if we now go to the assembly with Fortify source, the first thing you might notice that it's become shorter. The reason is that we enabled optimization, and therefore the compiler worked a little bit harder to generate better code. And because of that, we have fewer lines. And we have two interesting lines here. First is the compiler noticed the size of our buffer and places that into EDX. And it doesn't call string copy, but it calls string copy check. So it replaced the call to string copy to a call to a different function. And with that, it can then check if we move too much data into that. So another demo. We are again in GDB. I will first run that code with an input that is too small to cause a buffer overflow. So once again, we are at the beginning of the program. We have the hex 100, where the compiler noticed the size of our buffer, and we have our string copy function with the checking. And if we now step through that, we reach the part where we call string copy check, and if we step over that, nothing happens because the copy just worked, and if we continue, the program will exit normally. If we do that again and provide an argument that consists of 700 A's, we will now overflow the buffer. We are again at the beginning, we start to step through, and if we try to step over the string copy check function, we will not come to the next line because the function realized that too much data is placed into the buffer and it will terminate. So, empty slide again. What are the limitations of that? Okay. In general, it's just limited to some functions or situations. So if the compiler doesn't understand what you're doing there, it can't help out. It can still lead to denial of service, same problem as before. You don't get remote code execution, but your service still dies. One other problem is that developers might just keep using these functions. So they are thinking, well, writing all those pesky checks, that's rather annoying. I just don't do that. The compiler does it for me. So if you're a security guy in a company, then you should probably still ensure that people don't use those functions. But it comes with almost no cost, so you should enable it. We have it enabled in our build system so that every package that is built is automatically protected with Fortify source. And as far as I know, we did not really have problems with that. And also the performance cost is rather negligible because you need those checks anyway. If you don't have them, it's not a performance benefit, you are just insecure. So the question was, why do we need to have optimization turned on for this to work? The reason is that Fortify source works in the stages where optimization also works. So if you disable optimization, then this whole engine just isn't triggered. I can't give you the detail why GCC does it that way, it just is.
There's also a limitation of Fortify source, right? If you don't have optimization, then you can debug it better.
Yeah, that is definitely a limitation. Should add that to my slides. Thanks. Okay. Okay. So then let's go to ASLR. ASLR stands for Address Space Layout Randomization. And this is a technique so that certain memory segments like the stack, the heap, or the code segment are loaded at random locations. And if you think about it, computers are deterministic, at least the ones that we use. And unless you have some sort of randomness in there, you will have the same memory locations every time you start a program. So that's the way it used to be. That is pretty nice if you do debugging and stuff like that, but it's not great if you want to prevent security problems. Because if you have randomized locations, then attackers don't know the return addresses for their exploit code or for the C library, for example, to jump to. If you remember the first example that I showed, there I hard-coded the address where my code will be and then jumped there. But if my stack is moved randomly in memory, then I can't do that anymore because I don't know where my buffer will reside later on. So if you cat proc maps for a given process, then you see at which places certain memory segments are. So for example, for this process, the stack is at this location, the heap is at this location. And if you now do that 5 times and just grab for the stack segment, then you will notice that these numbers here change. So this is run on a system that has ASLR enabled. The stack is moved to a different location every time this code is run. You can check what settings your system has. If you check this file, you can have 3 settings. You can either have 0 for no randomization or 1 or 2. It then randomizes various parts. If you have a recent distribution, you definitely should see 2 in there. If not, you should talk to your distribution. I think all major distributions have that. But if you are maybe working in a embedded space or something like that, it is definitely something you could check out. To get the full benefit of that, you need to compile your programs with fpi. That then ensures that the code is generated in a way that the binary works no matter where it's located. And this is rather important because some binaries assume that they will be loaded at a fixed address, and then the loader actually has to load them at that address because otherwise it will not work. But if you compile it like that, then the binary is generated in a way that it can be relocated wherever, and then the loader can relocate it to that address that is randomly chosen. So, what are the limitations of ASLR? Spectrum? Yeah, definitely. Come again, please? It works, but not really that great. I mean, yeah, it's I have those points. Okay, so first point, for older systems that had a pretty hefty performance impact. Yeah. Sorry, come again. I can't hear you without a microphone. Sorry. Stack Clash. No, that's not directly related. I mean, you could have exploitation of Stack Clash without ASLR, but you could have a situation where it's becoming easier because those segments are nearer than they would otherwise be. You have limited entropy on 32-bit systems. So at least that is what I know. I'm not sure why you think it doesn't work at all on 32-bit systems. Yeah. Yeah. And of course, you can't really use all those 32 bits because you have various memory segments, so you can't place it everywhere. That is definitely a limitation on 32-bit systems, but fortunately, not too many around of those anymore. At least where I work. If you work in an embedded space or whatever, then it's probably different for you. So brute forcing can still be an issue if restart is not handled properly. So even on systems where you have more entropy, if you restart your process, or if you don't restart a process because you get this randomization on the start of the process, but if you only restart part of that and still keep the same memory mappings, you might still run into problems there. And it can be circumvented by chaining an information leak into your exploit. So that is with regard to the Spectre comment. Of course, if you're able to leak information from the process, then you might use that to gain some knowledge about where those memory segments actually are currently. You also might have some exotic software that relies on fixed addresses. So, for example, if you have some inline assembly, then this might be problematic. I don't see a lot of those problems, but that also depends heavily on which area you're working on. And sometimes you might have some usable memory locations in registers. So you might just have a usable pointer to whatever you need in a certain register. So then you're lucky because you don't have to find out any addresses. You just have it around to use. So for ASLR, I don't have a demo because it was pretty clear from the 5 executions of this CAT program what it does. The next mitigation we will talk about is about non-executable memory. So modern processors support the ability to set certain rights for memory mappings, and they can say that certain memory should not be executed. Another term for that is NX, or this thing I don't know how to pronounce. And the most interesting memory regions for that are, of course, the stack or the heap, because in well-written software, you usually should not execute code that lives on the stack or the heap, unless you're doing some, whatever, writing a virtual machine, or if you write normal code, you probably should not do that. So the stack overflow can still take place, but it's not possible to directly return into your shell code, because your shell code will live on the stack. The stack is non-executable, so you can't jump there and execute it. If you try it, then the program will die. And when you see my italic of directly, there's probably a way around that. If we remember what we saw before, so if we again cat this maps file in the proc directory and grep for the stack, then we will not only see the address where the current stack is, but we also see some modes here. And in this case, we are allowed to read the stack, to write the stack, but we are not allowed to execute the stack because otherwise we would see an X here. So, what limitations of an X can you think about? Come again? JIT? Mm-hmm. Yeah. So JIT stands for just-in-time compilation. If you do something like that, then it's going to be tricky to do that. I mean, you can still work around it by first compiling the stuff and then afterwards changing at least the write permission from the memory map, but yeah. You can use existing code in the exploited program. So maybe there is a privileged operation you want to run. Maybe you don't need shellcode. You just want to call the delete all database functions or whatever. And so you just jump there, and since it's part of the code segment, it's executable and you can jump there. You can use something like return to libc. So pretty much every code is linked against libc. There are a lot of useful functions you can use. So you just jump to libc and use the code that's already there. You can use return-oriented programming. So you structure the data on the stack in a way so that you always jump to small sequences called gadgets that end in a return instruction, and try to get your functionality just by jumping to those little small gadgets. And since we'll be using that shortly, I will show you that. That's a small graphical representation of that. So you add data to your stack so that you override the instruction pointer with this data, which then causes you to jump here. And there you only have one useful instruction. You just pop EAX. That means that you take the topmost stack value and place it into EAX. So the topmost stack value will be this after the after the address here is removed. So you will then set EAX to 1, and then you end in a return. So the return causes the next address to be taken and control be transferred here, which you then can repeat and get basically whatever behavior you need. So you use the stack only as only for the control information. You don't put code directly on the stack and execute it. And this is used a lot in modern exploits. So we talked about quite a few mitigations. We talked about stack canaries. We talked about ASLR. We talked about no execute memory, and we talked about Fortify source. So should probably be safe. No more exploits, right? Yeah, unfortunately not. I will now show you a counterexample. It's taken from a certain blog post. I changed it quite a bit to make it work on my machine and also to make it a little bit more understandable for this talk. I will leave out Fortify source for this example, just to be able to create an easy exploitable program. But I probably don't have to tell you there are enough vulnerable code pieces out there. So this is just me cheating to make my life easier. It's not because you can't circumvent that. So that is the code of the program that we will now be exploiting. We have a main function that then calls into a function called memleak, which is a memory leak. So we have now here our information leak where we get the information we need for further exploitation. And then after we call to memleak, we call into vuln function. That is a classic buffer overflow. So we have a statically sized buffer and read too much data into that. So not very complicated. Since we want to be able to execute our own shellcode, we need to make the stack executable again. So the default stack is non-executable, but you can use functions like mprotect to make it executable again. And we want to run our own shellcode. So we need a way to call this function. It accepts an address, a certain size, and then some protections. So the permissions we want to set on this memory mapping. On the architecture I'm using here, the first few arguments go into registers, so they are not placed directly onto the stack. And so we need to be able to set the registers, and to be able to set registers, we need to be able to execute code. But since we have non-executable memory, we can't directly execute code, so we need to use ROP, return-oriented programming, what I just showed before. For that, we need to find some gadgets. So gadgets are those small code sequences that end in return directly. There are a lot of programs out there that help you do that. I used ROP gadget. This just prints out a list of all gadgets it finds. In this case, I just checked the C library, and I wanted to have an instruction that allows me to load data into RDI. There are programs out there that you can give a binary and it gives you out complete ROP sequences. So if you don't want to build it yourself, you can just use those programs. So, demo time again. And let's hope that it's actually worked, because the last time I gave this talk, it did not work, which is kind of disappointing. So this is the exploit that we will be using. We have our shellcode. This is running in a virtual machine. And we want to be able to connect back to the hosting machine so that we get a reverse shell. The shellcode is generated with MSF Venom that will connect back to my host machine. In this line, we will open the vulnerable function. That is only the compiled version of what I just showed you before. The system has ASLR, it has non-executable memory, and it has stack cookies enabled. And first we read what the program writes, and then we write something into the program to trigger this memory leak, and this memory leak is triggered via a format string vulnerability. Format string vulnerabilities are not that common anymore, but they used to be really nice because you can do a lot of stuff. You have your memory leak, you can write some data if you want to, but in this case we just use it to leak some memory. Then we read the memory that we just leaked and start calculating the data that we need. So first we calculate the base of the libc that we need. Ouch. Then we calculate the address of the buffer. And then we extract the stack cookie, because we leak so much memory that we have the stack cookie in there. Next, we calculate the address of mprotect in the C library, because we want to jump there to make our stack executable again. And since this mprotect needs the arguments in the registers, we first need 3 different gadgets to set those arguments in the corresponding registers. So with the first gadget, we set the value in RDI, the second one sets it in RSI, and the third one in RDX. So then we do a little bit more calculations, not that interesting. In the end, we add a knob slat, so that is the same as I showed you before. That just makes our targeting a little bit easier. And we put it all together. That is the final exploit. We have our knob slat, we have our shellcode that we generated, we have our stack cookie at the exact location it needs to be for the check. Then we add our gadgets and the data they will add to the registers, the address of mprotect where we want to jump first, and our buffer address. I set up a listener on my local machine. So this is my laptop, and what we will see after that is just a virtual machine in my laptop. And if we now call this exploit, we see that this is the result of the memory leak. So this is what we are getting out of this other process. Then we use that to calculate all the data that we need. So we get our stack cookie, we get the addresses that we need, and then finally we send our payload to our program. And if we go back now, we see we got a connection. We are root, which is because this program runs as root. And we are in the virtual machine. So, what we didn't cover now is quite a lot. There are some other mitigations that we use in SUSE products. So for example, this stack clash protector really saved us a few weeks ago when the systemd exploit broke. Fortunately, we enabled it for all our current products, and because of that, we were not vulnerable. This is also one of those mitigations that are not that costly, so it was really easy to exploit them. Then there's something called relrow, so there are relocation tables and binaries. If you want to move them around in memory, you need some place where you relocate your symbols. Those are pretty nifty targets for attackers, so you want to make them read-only after you do your relocations. It's also pretty basic. There's definitely more that should be done because, as you've seen, exploitation becomes much harder with those mitigations, but it doesn't become impossible. And if you look at exploit prices, then it just has the effect that exploits become a lot harder to construct, and therefore they become more expensive. That has definitely a positive impact on us, because if an exploit is more expensive to generate, then people really think about if they want to burn them just to break into your database server. But it depends on what kind of enemies you have. The ROB technique that I just showed you before, it's used in a lot of exploits nowadays. And because of that, there are some mitigations that are coming up. You have something called shadow stacks. So we were just talking about the normal stack where you have this control information and data mixed into each other. Shadow stacks just have the control information. And then you can have checks that says, well, we have the return address here and we have the return address here. We compare them. If they're not the same, we have a problem. Then there is control flow integrity that should ensure that you only jump where the programmer intends you to jump. And luckily, we will see that in hardware pretty soon, or maybe you already have that, because if you do it in software, it's rather expensive. And then there's something called data flow integrity that even goes a step further, that really ensures that data is not changed in a way that was not intended by the programmer. But that is not something that you see in standard systems that you run nowadays. The main problem here is that those mitigations are rather costly. Especially control flow integrity is something that is rather costly in terms of performance. So we have a rather hard time convincing our customers that taking a 10% performance hit is worth it. And of course, they can also be circumvented. So I mean, it's the same thing every time. You invent some mitigation and the attackers just get better, but you make it harder every time. And those mitigations are the reason why you currently don't see or seldomly see exploits just posted somewhere. Because if someone can nowadays write an exploit for iOS or for Chrome, they can earn really big on that. And because of that, they don't post it publicly anymore. And the reason the prices are so high is because it's really hard to do that nowadays. And that is partly thanks to the mitigations that are now in those products. So, thank you for your attention. Do you have some questions? In that case, Doug will come to you.
For the ASLR, you said there is no performance degradation on the x64-bit platform. Is that true, or is that just because you didn't mention it? If you go back to the limitations.
ASLR has not really a performance issue because you do these relocations once at the beginning of your code or before you start up your program. And that costs a little bit of performance at this time, but then if you run your code, it's not really a factor on modern hardware.
Does that prevent the compiler's speculative execution to go, in a bad sense, in a sense?
I'm sorry, I have a hard time understanding you.
The compiler execution, the speculative execution that the compiler usually looks at the code and say, okay, I'm going to run from this section of the memory. But if it's random, then it might have to regenerate that speculative execution logic, right?
I'm not sure I can follow because the ASLR only moves your program in memory and then later on you just execute your code as usual. So there is really no performance impact.
Questions?
So I'm not really sure how to phrase the question, but I think the bottom line is, what the heck do we do now? So to give a more concrete talk, you talked about some hardware features that are coming online. There are some improvements in programming languages. Go is maybe better than Java. Rust is probably better than C. What do you see the system software doing in the next few years, or say 5 or 10 years?
So in general, it's definitely if you're able to choose a programming language nowadays, and if you don't have to use C or a really low-level language, it's probably a good idea not to do that, because you just solve a whole class of problems, or you don't have them not to think about. I mean, there are still enough problems there for you to care about with regard to security. I think going forward we will play this game probably forever. We will have a mitigation, then the attackers will become better, and in the end it really depends on what you're defending. I mean, with the mitigations that you have nowadays, I think we're in pretty good shape unless you're the target of a state actor or something like that. And if you look at what really owns, or how large organizations are really owned, then this is seldomly the newest zero-day exploit. It's usually a user just clicking on a link or executing something because they got told, well, I'm the IT guy, do that. So I'm not too optimistic about the future of security because we as humans are just too trusting. That is definitely something that we can think about, but in my experience, unless something is really horribly broken and a lot of people lose money because of that, we usually don't change it. So, I mean, programming languages like Rust, they are really cool and great, but it will take decades until we have replaced all the C code that we still carry around with.
Any others? All right, thank you.
Thank you.
Testing, 1, 2, testing. Is it working? Kind of, sort of, maybe a little bit?
Sort of.
Is that all right? All right. Now, no judging on non-professionalism. I don't do this part for a living. Oops. All right, stop that. Time is it? All right. I have 2 o'clock on my watch. I guess it's time to get started. All right, so here we are. UNI. What are we doing? What are we talking about this talk? Who about me? My name is Patrick Swartz. I am in my first year at SUSE. I've been a systems admin, systems architect for the last 20 some odd years for multiple companies. That's how you can find me, whether it's on Twitter or LinkedIn. So what are we here to talk about today? What are we trying to solve? As systems admins, we're responsible for everything, right? Whether it's patches, it's configs, it's whether we have to install software, account management, security, system security tuning. I mean, the system admin, the system architect, we've got to make sure that things are right. Things are stable. Things are where they're supposed to be. Things are what the users, the developers, whoever's using that system, the consumer of the system, depends on the system admin to make sure it's right. Can we all agree on that? Whether it's making sure of software drift, making sure the containers are safe. I was reading an article recently talking about some massive percentage of the containers that are deployed today are vulnerable. They're constantly fighting that containers that are that are not safe. They've got vulnerabilities already in them, and we're still deploying them even though they've got vulnerabilities. So as system admins, we're responsible for a lot of things to manage. In today's world, and as I give this sister presentation of this about our commercial product called System Manager, our world is getting more complex, not less, as we have to deal with not only the number of OSs we have to work with, but also the hardware platforms we're dealing with as well, whether it be x86, ARM, Z, Power, you name it, we have to, we deal with it in some way, shape, or form. So the bottom line is, what are we trying to do? Stay in control. That's what we're after, right? So the solution I want to present today is called UUNI. And you're going, what in the world is UUNI? Well, I'm going to answer that question for you. It's not this UUNI, although we'll give this UUNI the credit. This one is the largest salt flat in the world. Why did we name this project after the largest salt flat in the world in Bolivia? Well, it's because it's based a lot on salt stacks salt, which I'll talk about in a minute. So what does UUNI do for us? Well, like this slide reads, it deploy and manage all kinds of workloads, no matter where they're deployed from a single UI. Gives us the ability to automate audits and reporting capabilities. And when I get into the demos, we'll do an audit. We'll look for a CVE, and we'll see what we can do to fix that. We can do hardware and software inventories. What have we got in our systems? A lot of times we get out there in the world, whether you've been in the job for years or you're brand new to a particular position, you need to know what's out there, right? And a lot of times we get out there and we get into systems, we have like, oh my gosh, this system's been running this for how long? We didn't know. To be able to maintain standard configurations. And that's one of the key issues that we have to fight constantly is configuration drift, right? So what's the UUNI I'm going to propose that gives us that ability to maintain that. And last but not least, and not even, this is just a short list, but build and deploy physical VMs and container images also from a single interface. Now think about that. The ability to deploy physical systems, virtual machines, or containers from your interface. At the same time, then when you know they're deployed, they're going to be deployed the way you meant them to be in a managed, controlled infrastructure, right? All right. And to let you know, I'm not a big slides guy, so we're not going to have a ton of slides. We're going to get into more demo stuff. Is that all right? Okay. So where did UUNI come from other than that big salt flat way down south from here? Originally, my slide kind of cut off here, but we started off with a project, Red Hat sponsored a project back in 2005 timeframe, I believe, called Spacewalk. How many have ever heard of Spacewalk? Couple? So we get our origins way back in the Spacewalk project. Well, as Red Hat has decided, that was the foundation for Red Hat Satellite 5, great product. And we took that same, SUSE took the same code stream and developed our SUSE Manager 3, 2 and 3 product line from that. But in the meantime, Red Hat has moved on from Red Hat Satellite 5 to Red Hat Satellite 6 and completely rewrote the interface. The whole project has been completely redone, and they abandoned, or they decided to no longer maintain Spacewalk, and it's got an end of life somewhere around 2021, whenever Satellite 5 completely goes end of life. So SUSE Manager, or SUSE, said, well, we need a project that we can continue on and continue putting upstream code into. So we've decided to fork the Spacewalk project into UUNI. Okay? That will be, so UUNI now will be the foundation for our upcoming enterprise product called SUSE Manager 4.0, which is due out this summer with lots of advantages to that. So this Spacewalk origins, way back here, is continuing its life through UUNI and through SUSE Manager 4. All updates will go from UUNI into SUSE Manager 4. So what is really we're talking about here? Well, UUNI, it talks about being an opinionated branch of Spacewalk to provide a simple installation using Salt. I talked about Salt. How many are familiar with Salt Stack? Okay, good, good. We use Salt extensively behind the scenes, underneath UUNI. We talk about, because the world is becoming containerized, and Kubernetes is becoming a huge opportunity within our world. So UUNI ties into containers as well. We've redesigned the website to use React UI. And I'm not a web developer, so that's a little bit foreign to me. But anyway, I'm liking what we've done to it. Python 3 and JDK 11 will be the foundation for everything going forward. As well as, and this is right now the current supported clients, OpenSUSE, SLES, CentOS, RHEL, and by the summer, even Ubuntu. So from this single project, I can manage just about every Linux flavor out there. These down here are the platforms that we support, and the ones in bold are the ones that you can actually run the UUNI server on. The other ones can be strictly clients. You're not going to want to run the server side on x86, Raspberry Pi type. A little bit beefy for that. But so that's what we are right now. All right. So just like OpenSUSE Tumbleweed, UUNI is a rolling release. It's constantly being updated. There is going to be, there's no community versus enterprise, editions. It's just UUNI with a rolling release. But it is the upstream, like I mentioned before, going forward for SUSE Manager from this point forward. All of our code bases are going up into UUNI and then coming down into SUSE Manager 4.0 and on. All right, so this is what makes up UUNI today. Like I say, it uses Salt Stack to do all the configuration management and the provisioning with physical, virtual, or cloud boxes. It has the ability to tie into Kubernetes, has the ability to tie into VMware, and the next version will even next version or next dot release will have the ability to tie into KVM as well. We use PostgreSQL behind the scenes. Oops, let me turn that one on. And to get to it, typically you're going to use the web UI. Most commonly is the web UIs. However, there's a very extensive API back into this that you can then use any of the typical API tools that you want to use to get to the back end of UEFI, and also from the command line. You can do just about everything you can do from the web interface, either through the web, APIs or the command line. Okay? And I'm talking really fast, but that's okay. So, like I said, those of you who know about SALT, this isn't for you so much, but the others. Like I said, we're backed by SaltStack. And if you want to know more about SaltStack, there's the GitHub link to that. SaltStack isn't a configuration management tool, and they'll tell you that. They are a remote execution framework, meaning that you can do lots of stuff to your systems, including configuration management, all from SaltStack, or SALT. And orchestration, automation is the foundation by which SALT was originally designed for. Tom Hatch and I have had long talks on the foundation behind SALT, and he's a fascinating guy to talk to. Okay, so SALT, though, it pretty much runs everywhere. It's written in Python. It runs on Linux, traditional flavors of Unix, even Windows. So it runs just about everywhere. It can be ran in agent or agentless, and behind the scenes is using the 0MQ to put things out on the bus, so you've got a little bit more secure method because you don't have to open up ports directly to every client, nor does there have to be behind the scenes issues with clients and firewalls. All right, so let's jump into some demos and see if I, did my appropriate to the demo gods today. So what are we going to talk about? Well, I'm going to try to show you some salty goodness. All right? We're going to start back at the command line and work our way up. We're going to talk about this thing called formula with forms. And to do that, there's this whole functionality that I want to show you that uses SALT and SALT pillars behind the scenes to deal with a lot of complex installs. We're going to look at some audits and see them to be able to see the audit and fix it. All right? We're going to talk about these things called action chains and what we can do with action chains. And then lastly, if I have time, which, because I'm really fast, I'm going to talk about some software channels that we can do with our world. Because software, the repositories, I found to be one of the most complex things to deal with, having to manage multiple layers of systems, whether they be test, dev, QA, prod, pre-prod in an SAP world, and having to manage all of these repositories in a unified method without spending, terabytes upon terabytes of disk space to do these rsync, backups of, became really challenging, and UEFI gives us that ability to do that. So let's see if I can do this. All right. Do I need to switch that to white on black? Would white on black look better? Okay. I forgot how to do that. I forgot where that's at. Oh, there it is. The which one? Oh, Breeze? Okay. No. Let's try. Let's try black on white. Is that any better? All right. You see that now? If I move this, move that over a little bit. All right. And I totally left my sheet of paper back in my room. All right, so this is all on memory here, so step one. So what do we want to do here? So I want to show you, for example, the world of having to do this without my cheat sheet. Anyway, all right, so SALT is very easy, if you could see my bad typing. I can target my systems, and the first step is targeting my box. I'm going to SALT. First thing I'm going to do is targets, and right now I'm targeting everything, and I just want to do a simple test, .ping, to see what I've got out there, and boom, that yellow is ugly though. It comes back and tells me, hey, all these systems are true. I got one error though. It says this one's in blackout mode, and we'll talk about that when I get to it. That's there on purpose. But just like that, I was able to get back individual things. So if I want to target, and that's one of the things with SALT, there's a back end called grains. And by default, SALT pulls in a ton of information about the system. So let's look at that for real quick here. One new client, grains dot items. All right? And I can look at this, and I can see, if I scroll up, back up here at the top, I can see all kinds of data about my system that SALT pulled in all by itself without me saying anything. Told me it was running, it's got some SSD, it's got an SSD, the BIOS release version, and every one of these things in blue, I can now target on. If I want to target every box that's x86, if I want to target on every box that has a domain of susazoom.com, or target on any, GPU, host name, or Ethernet address, I can target on any of these things going forward. And we're going to talk about, we're going to show real quick here, is just strictly OS. Let's target on our OS. So SALT, I'm going to do a -G, OS : SUSE test.version. Let's try something different. Okay, so I'm going to target all my SUSE boxes. They came back with a grain of the OS grain equaling SUSE, and sure enough, I only got back this list of clients. Now I can start doing all kinds of stuff from that now. I can start breaking things down and doing more with these individual systems. If I wanted to get even more granular, I could go, is it SUSE OS version, 15? Or SUSE OS version 42.3? I can now start targeting my systems in a much granular fashion, and they all respond. And what's nice about the 0MQ message bus is it puts the SALT master, which UEFI is, puts the messages out on the bus. All the clients are listening to the same bus at the same time, can respond immediately. There's no more of this loop shell stuff of a list of systems that you've had to compile. I mean, how many of us have done that, right? We create a list of systems, hoping that that's complete, put it in a systems.list file, and then run our bash shell loop across our systems list file. And it works. It's going to hit each one individually in serial format. And hopefully you got every system you needed to in that list, right? Well, with SALT, though, it puts that on the message bus. All the SALT minions is what they're called for the clients, are listening to the bus, and they all respond at the same time. So I don't have to wait for this individual one after another method to get my data back. And I can compile all this data from the command line and actually port it out to a list if I want to, port it out to a collection program like Splunk, for example, or any other log collaboration correlation engine. All right, so I can do that in targeting my backend. So if I need to target something, so that's all my targeting. I can target all kinds of stuff. I can even put my own grains into the system if I want. It's in data center 2, rack 5, U32, whatever. Okay, those can be individual grains as well. You can put in SALT. So SALT is the foundation by which UEFI is built on. So everything starts here. All right, so if I want to do something with my system, and I've got a couple of simple, very, very simple demo-worthy SALT states, as they're called, then I can show you. And let's look at one of them, for example, of root profile. Because how many have your own root profiles, right? I certainly have. root profile init.sls. So in this few lines of code, I'm able to push down the bash profile that I want for my systems. I tell it file, this is where it's going to go, root.bash_profile. That's the location, that's the destination of where this file is going to end up. It's a file.manage. These are called modules within SALT. And there's hundreds of them. And each one is can do a lot of things differently. Where's the source, though? What file am I pushing down? What's in my root of my SALT infrastructure and it's called bash_profile. And then, of course, I want to make sure I set my permissions correctly on that box. All right, so if I wanted to push this, if I wanted to actually make sure I got that, I can show you where that so just so you know, I'm not lying. This is the SRV salt is the root path, and then of course root bash profile, root bash profile. Okay, and of course I'm going to push that bash profile out, so I can just write salt. If I can spell, I'm going to target to you client 1, and I'm going to say state.apply on my root profile. Okay, cross our fingers. Oh, except in this one's in. I picked on all of the ones I picked on. I picked on the one that's in blackout. Well, it helps me go to prove a point though, because I've set a pillar on this box that says don't allow any changes to the box. Okay, so I tried to push a config change to this box, and it said nope. The pillar says you're not allowed. Okay, the only thing I'm allowed to do is actually run a salt refresh pillars on this box to actually update its pillar data. So let's try a different box. Let's try it to client 2. All right. And sure enough, just like that, I push that box out. I get a lot of data about that. I can see that I get a diff. If it happened to be a root profile already there, I would have gotten the differences between the two in good Git format. And I would have seen that. I can see that it was successful. It changed one file, nothing failed. It took 66 milliseconds to run. I could have done that. I could have targeted all of them, and they would have all happened that fast. Because, again, it's happening in a parallel to all of them. It's putting that out on the message bus, and they all just happen. Okay? So that's the foundation behind SALT. It's a very, very quick overview of SALT. Yes, sir? Well, I can roll back to, I can push down a different profile. There's not a rollback feature per se, unless you, that goes back into the question is there a rollback feature? And it kind of goes to what is your underlying OS support? If you're using OpenSUSE with ButterFS, there's a lot of rollback options then. If you're using ext3, there's other ways you have to go about it, okay? But I could have made this profile a lot more, I could have made this state file more rollback proof, for example. I could have made it do a copy and make an original file. So I can do a lot more in that state file. I made it very, very simplistic on purpose. Where am I at? Oh, yeah. So I could have put more data. I could have made this a little bit more complex here to give me some rollback options. But in typical, I tried to keep things simple. All right, so good questions, though. And I don't mind questions along the way. All right, let's move on. I make sure I don't run out of time here. So the next thing I wanted to show you, though, was the how this looked then in UNI itself. All right. Let's give a quick overview of the system. This is our, I don't care about that, because it's local. Okay. I didn't test that. Well, it's my apologies. If it wants connection. Let's try this. Can get a network here. All right, much better. Fine. All right, we're back on track. Okay, so let's look up here at home overview real quick. This is the interview. This is the interface. Now I'm having to squeeze it all in to fit the screen up here, and you can see that it's a little bit cut off, but that's okay. I can see an overview of my systems. I can see I have no inactive systems. I've got one pending minion waiting to be accepted. I can see my most critical systems, so it's got updates to them. I can see what's happened recently. We're going to come back to this on relevant security patches. We're going to come back to these and actually deploy these. So this is just kind of an interesting overview. I can see I'm fairly evenly distributed between my CentOS and my OpenSUSE clients. But what I wanted to show you, though, let's go back up here. Let's go to close this down. Systems, system list, all. And I can see that I've got a lot of clients where they're at for patches, packages, where they're at, what base channel. We'll talk about that more in a minute. But I want to scroll down here and look at my configuration channels. And you can see that I can do the same thing. I had already set up one called bash profile. And I can look at the init file for that. And I can even edit this init file from here. You can see the same format. So I could have pushed this out from the UI as well across on lots of systems. I wanted to show you a couple more real quick, since that's kind of a simplistic one. The permit no, this one I had set up called no root permit, and where we can turn off the ability to SSHD. So in this 10 lines of code, I've basically saying here, this service, SSHD, needs to be running. This service needs to stay running, but watch this file. If it changes, restart SSHD. And then I'm going to push file.manage. I'm going to push a new config file down to the box with my permissions, and it's going to land in this directory, in this path right here, which matches what I'm watching. And if that changes, it restarts as SSH. Okay? So in my 10 lines of code, I was able to easily push down and restart SSH without much trouble. Okay? So for sake of time, I just wanted to show you a couple examples of what we can do. Another one, real quick here. This one, because I'm a lab and I do a lot of stuff with my lab box here, I don't want to deal with all the Spectra stuff, so I don't want to slow me down. So I turn it off. But here I'm doing a file replace on my grub, my etsy default grub. And of course, I could have put more targeting here. Jinja, they use a lot of things called Jinja. But I can actually target saying, if it's a SUSE box, use this path. If it's a Red Hat box, use this path, for example. But here I'm saying, in this file, look for this pattern. So think of sed. I'm looking for this pattern that ends with the line show ops quote. I'm going to replace it with this line, show ops, no spec, Spectra off, example, close quote. And then if this changes down here, on changes of this up here, run this command. I need to run grub2 make config because I've made changes to my default grub. Because I told it to, on changes here, run this command. And this changed, so run that command. So again, very simplistic, only 12 lines of code, only 11 lines of code actually if I take the one out, the one space line out. All right, so that's a very simplistic look. There's there's some that get very, very detailed, but I wanted to give you a quick overview of what we can do with salt from the UI. All right, so let's go back up, and one of the other things I want to show you, let's pick on a system here. I don't have physical systems. And I can go down here, and there's this idea of, we talked about formula with forms. And you can see that I've already rolled out this one formula called Splunk. Well, what are these formulas? Well, this formula is a very simple one. And it's asking me whether the install is either a universal forwarder or a full version of Splunk. Very simple. But behind the scenes, the formula behind the scenes says if it's a UF, install from this path with these parameters. If it's a full, install with this package from this location, and do all these other kernel changes that I need to do for a full Splunk install. But from this simple UI, though, all I had to do was pick whether it's one or the other. So let's look at a different formula, though. It's yeah. Oh, that's right, because I need to put it back to where it was. All right, so let's look at a different one we could have added. I can get my mouse to work here. There's the one I talked about on that one. We have blackout. But let's look at one a little bit closer. Let's look at DHCP. I save that, go up here. Now I've got another menu item up here. You can see this one's a little bit more detailed. And I can add my domain name servers, my interfaces. So all the things that you would configure within a DHCP server, I can now do it via this formula, okay? Via this form, and push that out. And if I add it to a particular group, DHCP would be a bad example, but all the machines I add to that group now would get this formula and get these parameters. Okay? So let's clear the values there. All right. Any questions so far? I want to turn that off. That's a little bit longer talk. Yeah. Actually, there is a presentation at SUSECON coming up first week of April that would get into that, a whole 2-hour session on formulas. I will show there's a topic on, not topic, but a web page from SALT on formulas, and then there's another, the documentation on how to create the form portion of that as well. I'm doing okay. Yeah, half an hour. All right. So let's go back up here and look at our systems real quick. And from here, actually I want to go, yeah, let's do this. Go back to him. So I talked about my states, and I'm sorry. You want to do this? Yeah, configuration channels. So here I can do my configuration channels. You can see I've already pushed this one called Zoomer host. Well, because of the way my little lab is built on this one single laptop and the way I'm doing DHCP and here, I had to actually push out a file up and edit my local host on each box so it pointed back to my laptop for him. So I had to do a config file there, but if I wanted to apply I could search for other configuration changes, SSH, and I can search. I can see that I can add, for example. I'm going to just click on that. I can even see what it's going to do. I can see I'm doing SSH running. I'm changing the message of the day, and I'm pushing out a banner. Okay? So I could add that. I can even edit it from here if I wanted to. I can apply that. I'm going to assign that. Save changes. I can then rank these depending on which one needs to make sure they get done first, if there's something that has to happen before the other one, and confirm it. Apply it. And now the config channels change has been scheduled. If I go up here to high state, and when it builds the high state, I can then see where that's validates. And if this builds cleanly, I can see that, sure enough, there's my changes that I'm going to be pushing down to the system. Okay? And as soon as I apply this high state, these banners, this stuff would change. And we'll just go ahead and do that. And I can see that my high state has been scheduled. And from here, I can see what it's been doing, what the details are, and when it completes, it'll show up here. I can see it's in progress. Or if, heaven forbid it fails, it'll show up here, and it'll give me a little bit of a clue of why. Okay? All right, so that's on our schedule. One thing I wanted to do, oh golly, okay. Yeah. So I wanted to show you on our audit, for example, 2 ways to go about this. One, I can see from my overview page that I've got some relevant security patches on different systems, and then they're updated with the most current ones at the top. As recent as 2 days ago, this one, OpenSUSE 2019-295, was a Docker change. I've got one system that's affected by that. Okay? So if I click on this one, I can, from right here, click that, apply patches, and he's done. That security vulnerability has now been remediated for this system. Okay? And boom. He's now been scheduled. Oops. Get back to where I'm at. He's been now scheduled for that box to push this patch down. If I wanted to see what that patch did, I can, the details about that patch, I can see what it's fixing. I can see the CVEs that's relevant to this. It's also relevant. And I can see what it's fixing in that. I can see then what packages it's pushing down as well, and what repository I'm pulling those packages from. And then, of course, the affected systems. And, ooh, it failed. Okay, let's find out why. Okay. Again, I picked on the blackout box. Typical. So, let's go to that box. Let's get rid of the blackout. And then we will be able to do things to him. And now, if I go back to that, I can then quickly come down here and see my actions. This one failed. This high state failed because I had it in blackout mode. If I click here now and go back and do it, and real quickly, apply patches, confirm. All right. Schedule. And that's the old. Okay. So anyway, we're moving on. Another way I can do it, though, if I need to see particular audit on across all of my environment, I'm looking for a particular one, let's say 2018, I don't know, 3665, I think is one I have in my back of my head. And from here, you can see that I'm allowed to not only audit my servers that I already have, but I can also audit my container images to make sure that before they're deployed, they're clean for this particular CVE audit. Okay? I don't have any containers set up right now, so we're just going to audit our servers. And you can see I've got some that talk about, I've got a couple of options here, some that are clean, and one that has the audit against it is available. All right? And I can do the same thing I did then, click on this guy. I can see the clients that are affected, details, packages, highlight the system I want, or all of them, and apply patches. Okay? All right. Now, let's talk about repos real quick. So, in our world of managing, you've got all of the repositories, whether it be SLES 11, SLES 12, OpenSUSE 42, OpenSUSE 15, CentOS 6, CentOS 7, and soon to be Ubuntu, I forget which version. We've got all of these repositories, and they're changing every day, right? you know, there's new patches being deployed to the main repository upstream every night, practically seems every night. Well, you don't want to apply, you know, changes to a system today based on today's repository, the upstream repository, and then apply this another, you know, update tomorrow to a new system, and it have newer patches than the one the night before, right? You need a baseline. You need to be able to say, and I can guarantee that from this point, and I update my prod, it was dated March 1st, and every box I apply then to March 1st is going to be exactly alike. Agreed? Well, that SUSE UUNI gives us that ability to create those baseline. We can do it either from the command line or from the UI. And then you can see here, for example, I've got several out here I created from, you know, February 5th baseline to February 18th baseline, February 22nd, January 28th, March 4th. I've got all these different baselines, and I can then I can push my system to those individual repositories. And so that when I push it to that repository, I know that they're going to get the same patches as the one system prior to that. All right. And then I have just barely scratched the surface of the interface of what we can do. Here is our images ability. We can deploy systems from within UUNI, whether they be virtual or containers. And I don't have this. This is one area I didn't plan on demoing, but I wanted to show you the interface for it. I can deploy either a Kickstart file, use a Kickstart file, or AutoYAS file to do it. And I have a presentation we're getting ready for SUSECon on how to do system upgrades from SLES 11, SB4 to SLES 12, all automated, all through SUSE Manager. And SUSE Manager today is synonymous with UUNI. Okay? So UUNI is a great place to, you've got that development space, you've got that lab, and you need to be able to have, you know, system control over lots of machines. You can do that effectively from UUNI. So let me jump back to my slides real quick. So encourage you guys, let's get involved. And how do we do this? Lots of ways. The project itself page is here, in which all of these are then, you can find them from here. Our GitHub page, the Open Build Service page, the mailing list, the Twitter follow, and of course, IRC. All the developers are on IRC. Okay? So I really encourage you guys. It's a brand new project. There's a lot of functionality here that we've already brought in, but there's a lot more we want to get to. And it's a very active community. I want to build it more. This is you guys get to be the first US-based UUNI talk. So let's make it happen. Let's get some US people involved in this project, right? So just like the couple of talks we've had today already about getting the community involved, this is a great project to do that, whether it be in documentation, because there's a lot of documentation that basically has just been modified from SUSE Manager to UUNI that needs to be updated. And we need to be able to, we need people to jump in. I mean, I'm not a developer, so I can't commit code, but I can commit to doing documentation updates and changes. And that's highly needed in this project as well. The project also needs testers, people to go out and try this, find out where the bugs are, where are things missing, what features are needed that are critical. Getting involved to find those things from a user's perspective instead of just a bunch of developers writing code that don't do this on a daily basis. That's where we come in as the admins to make things happen. So get involved. That's what we really need. So that's my presentation. I'll open up to questions. Again, you know, the typical disclaimer.
Have any questions?
Hi.
Hi.
Yeah, I was just wondering, is this dependent on an OpenSUSE environment, or will it work on any?
Well, the server today requires OpenSUSE 42.3, the server side. Actually, I think it will run on Leap 15 now as well, on the server side. The client side can be Red Hat all the way back to 6 as well. if you want to use SALT. If you want to use the traditional client, which I didn't talk about, you can even go back to CentOS Red Hat 5 as well. The traditional client is being depreciated, so as well as CentOS Red Hat 5 support too, but it's still available today. But the server itself needs to OpenSUSE 15 or OpenSUSE 42.3.
Okay, so I walked in late, so I missed the first part. But is this just a front end to SALT or any configuration management solution?
This is the front end. This is our front end to. We use SALT underneath. It's not a per se front end to SALT. Right. Other than the fact that we use SALT and do a lot of front end work for it. It's not a replacement for SALT Stack Enterprise. We're not trying to compete there. That's a completely different market and a different mindset. They do things we do things they don't do.
But it won't go on top of Ansible, it won't go on top of Chef.
Right. No, that's agreed. It's meant for, it runs SALT underneath and only SALT. However, there is several SUSE developers we have an internal SALT stack or SALT team that writes code for SALT. And several of them have pushed upstream code that will allow us to run Ansible playbooks within SUSE Manager. So we can run Ansible code via SALT inside SUSE Manager. So you don't have to take all the Ansible code you've already written and throw it away and start over. You can continue using those playbooks. Other questions? Thoughts? Comments? Rotten tomatoes? Eggs?
All right. Well, thank you very much.
Thanks, guys.
We're on the cusp of getting, my voice is much louder now that I've turned on the microphone. Probably don't even need the microphone because I do this a lot. But for the recording purposes, they told me to keep the microphone on. They also warned me not to dance. They told me to stand in place, try not to wander around, which is impossible for me. I'm completely incapable of standing still. Repeat questions from the audience, and don't forget to tip your waitresses. I think that's an important one right there. All right, I was just telling everybody this is one of my favorite places on the planet. This is Henry's Lake, just outside the Tetons, West Yellowstone. It's in Idaho. It's called Island Park, Idaho, Henry's Lake. I used to spend a lot more time there than I do now. But that's not my presentation. This is. And does it work? Good, it does. Thanks for coming today. I know that there is high competition for time. Everybody's got lots of interesting presentations they want to see, or booths they want to visit, or Simon Cowell out there with the America's Got Talent show. But I'm going to spend the next 40, 45, 50 minutes talking about software-defined storage. And if you don't like my presentation, Alan Ott will be giving a similar presentation on Sunday. I don't remember when. And he's a lot smarter than I am, and probably better looking too. But he doesn't have a beard, so. Up until recently, was one of the engineering managers at SUSE for the software-defined storage product that SUSE has called, unimaginatively, SUSE Enterprise Storage. And now that I'm no longer one of the engineering managers for that team, I feel a lot less qualified to give this presentation, but I'll do my best. I'm currently writing technical training materials for the SUSE Enterprise Storage product, so that still qualifies me to give this presentation. In addition to that, I'm an adjunct instructor of computer science at Utah Valley University, which gives, the only credential that gives me is that I can stand up here and talk to you fairly comprehensively. It does not allow me to do interpretive dance, though. But for a long time, people have kept records. People have wanted to keep track of their stuff. And if you can imagine, Fag, if he were still alive today, and if he didn't ever delete his data, you can imagine the huge storage of communications data that he would have stored up. How many caves of data do you think Fag would have, right? And they used rocks to communicate things, and this is some sort of Meso-Asian writing script, some Sanskrit-oriented base of language stored on stone. Really incredible stuff that we have about storing data. And this is Greek. This is some sort of official edict from back around 300 BC. And this is my office right here. And this was 5 megabytes of IBM storage around about 1956. So, we've been dealing with this data thing for a while, and this is nice data storage stored digitally, and we're not much farther along than that. But it's a big problem. Obviously, we need data, and we're keeping lots of data, and whether we want it or not, we never delete the stuff. And from 2009, we're some down here, and here we are in 2019, and the data growth is about 40% per year. Ouch! That just blows my. If you think that blows your mind, wait till you see the next slide. And now, although it's interesting though that storage costs are declining, that's good. We're grateful. However, you can see the disparity, that's the word I was trying to fish for right there, that although the costs are going down at roughly 25% annually, the rate of growth is 40% annually, so it's still very expensive to store our stuff. All right, so now if that doesn't blow your mind, it's alive. Nobody ever deletes stuff. You're not allowed to delete anything anymore. And IDC predicts that there'll be 10 times the amount of stored data in less than 6 years, about 6 years. And that by 2025, there will be 175 zettabytes of data being stored on this planet. Now, if that doesn't blow your mind, this is a zettabyte, right? A zettabyte is 1 trillion gigabytes, or 1 to the 21st. That's 1 with 27 zeros of bytes. And I'm forgetting how many DVDs worth of data that is, but you can't watch that many DVDs, trust me. And just to make it all the more complicated, last year, the same IDC folks said that by 2025, we were going to be at 135 zettabytes, and so they're already inflating the number. Where are we storing this stuff? That's a complicated answer. There's a shifting paradigm in how we store data, and we have to. Traditional storage just isn't doing it for us anymore. If you're a mom and pop shop, or if you're at home, you probably don't need to listen to this talk, right? We've got the standard today model of storing data on legacy storage systems, and that's fine, and that's probably going to do us for our lifetimes. But if you're in any sort of business, any sort of organization that is not allowed to delete data, you've got to figure out larger and faster and more comprehensive ways of not only storing it, but making sense of it, keeping track of it, knowing where it is, right? Just because you've saved it doesn't mean that you necessarily know where it is and can get it back, right? You've got to be able to manage and organize all of that ridiculous data. In our current day today of storage, our legacy approach to storage, we've got our data centers that just basically have storage silos with a direct attached storage. And if you're lucky enough to have something that's at least a little bit greater scale than that, at least you have the means of expanding that direct attached storage and having some sort of array within what do you call those things? A closet, a cabinet. That's the word I'm looking for. A cabinet to expand. And then when you get to the point where you have to have now 2 cabinets, it gets a lot more complicated. It's hard, and it's a lot of work, and it's a big headache. Then you got to back up that stuff, which is really nasty. And the process that's behind it is a very slow reaction to change. And as a matter of fact, the way most proprietary vendors handle their software, their hardware for storage these days, is what we call in the industry a forklift, right? You don't come in and add storage, although you can do that, right? You come in and add a shelf, and then you add another shelf, and it's fiber channel, and you can at least get some scalability there. But then when you get to a certain max size for that architecture, then what your vendor does is they do a forklift, change out and replace. They basically come in and take your cabinet out, go out and throw it in the dumpster, and then they bring in another cabinet that's got higher density disks, higher capacity disks. And it's hard to scale that kind of stuff, and it's difficult to manage that kind of growth. And not that I haven't put this particular detail on the slide, but it ends up getting really expensive really fast. And the hardware vendors know this, right? That once they've got you for life. What people want is not that. What people need going forward and long term is something that's far more agile. And we end up calling this a software-defined infrastructure, software-defined everything, right? SDI infrastructure. And as a part of that, you've got software-defined networking, and you've got software-defined this and software-defined that. And in that whole hodgepodge of software-defined everything, you've got software-defined storage, where your ability to deliver storage to the people who are using the storage ends up being more agile, more flexible, more along a DevOps delivery mechanism, and more ability to move the data around and change the size of the data. And it typically ends up being more business driven. Your ability to react to the business needs is far more facilitated. And you can be faster in terms of deploying what it is that those users and customers need for what it is that you're keeping track of. And this is where most organizations want to go. And even if organizations don't know that that's where they want to go, when they try to tell you what it is that there's their use case, they're pretty much describing this, which is a software-defined storage approach. Now, one thing that a lot of people start looking at as they're going this direction is they say, oh yeah, well, they've got cloud storage. And great, cloud storage is awesome, and there's a great application for it. It's very flexible. You don't have to do any capacity planning, because all you have to do is just tell your cloud storage provider, hey, give me some more disk, and they go, hey, we'll be happy to give that to you. Yeah, here it is. You know what they're doing in the back end? software-defined storage. But that's another story, right? And from a hardware perspective, you're really happy that managing all that hardware is somebody else's headache. Yeah, good stuff, right? You don't want to be in the business of managing all that hardware. But, there's always a but, that comes at a cost. And I mean literally a cost, right? Remember, growth is about 40% per year. Today, for 2 petabytes, that costs you $50,000 a month. And of course, prices are coming down, but your growth is going up, and they don't intersect, and so it just gets more and more and more expensive for you. Plus, in your cloud environment, although there are a few options, typically speaking, you're talking about object storage. And maybe you need something different than object storage. What if you need block storage? What if you need file storage? So once you get hooked here, too, if you ever want to change, has anybody ever tried to get out of the cloud? Now, if it's your MP3s, that's pretty easy to move out of the cloud, right? But if you're talking about all of your medical data for your hospital, getting that out of the cloud, that's nigh unto impossible. So there are some challenges with cloud storage solutions. There's a lot that's appealing about it. That's fine. That's good. And there's a good reason to be there. Just be aware that this isn't always what everybody wants. So how do I store all my stuff? Well, along came an open source project that was free and open source and was a clustered, distributed model of software-defined storage. It predates the cloud movement, right? The first stable release of Ceph was in 2012 by a guy who was his PhD project somewhere. It was here in California. I think he was at, yeah, there you go. And his name is Sage Weil. Good guy, really smart guy. He starts a company called Ink Tank. Within a few years, Red Hat, they come along and they say, look how valuable this is. And they buy up Ink Tank. And so now all those Ceph guys, all of those Ink Tank guys have moved to Red Hat. But they're really good friends of ours. And I work for SUSE. And we're also involved with the development of Ceph. And I'll show you a little bit more about that when we get in the next slide. Ceph has a lot of really good goodies, really incredibly powerful and useful features. For a distributed storage cluster, right? Now, of course, it stores all of its data all back as an object store, but then makes it available in 3 different formats that we'll talk to in a moment. Another important feature about Ceph is that it excels at durability. So the redundancy and the fault tolerance of the stored data is second to none. Very, very rock solid, making sure that you can get to your data when you need to get to your data. It allows for a very efficient and fairly effortless scale out to the tune of exabytes. If you need more storage, you just add another node. And it's built on commodity hardware. A lot of those proprietary software vendors today, they're selling you their hardware that will only work with certain disks, that only have their controllers, and you have to be using their software. And it's all proprietary stuff, whereas with Ceph, keep in mind, right, there's limits to this. You don't want to go out and buy the cheapest controller card that you can find, and you don't want to go out and buy the cheapest hard disk that you can find, but generally speaking, it's all on commodity hardware that you choose. You don't have to buy the vendor's hardware. You can go out and buy the stuff that you like, that you have the confidence in, HP, Dell, EMC, whatever it is you want. And it's all open source. It's entirely open source. It's almost entirely C++, although there are some other bits to it that are other bits of code. And to be honest, it still is, year after year, the most popular choice for the back-end storage mechanisms for OpenStack. Now I have a reference down here, the 2017 survey report from the OpenStack Summit. They didn't do a survey in 2018 for some reason, probably because it's expensive to do surveys, but it is still, even today, unofficially, there's no report to back it up. But OpenStack pushes the fact that Ceph is the way to go to store your stuff in an OpenStack environment. That's a big testament to how robust and how relevant that Ceph is. Just in 2018, Ceph was removed from direct control from Red Hat, and the organization now is governed by the Linux Foundation. That's a really cool thing, right? Nothing against Red Hat, right? But even the old ink tank guys, Sage, they're all saying, as much as we like Red Hat, and Red Hat's paying us very well, it provides greater flexibility and greater openness to be managed by the Linux Foundation. Now, that doesn't mean that Sage is employed by the Linux Foundation now. Sage is still a Red Hat employee, but Ceph as a community is governed by the Linux Foundation. So we have a new Ceph Foundation, and its founding members are listed here. I, of course, because I work for SUSE, I'm biased, and I put SUSE here at the top. It's interesting that you'll see over here on the number of lines of code that are contributed to Ceph, with the most recent release of Ceph, which is the Mimic release in 2018. We're currently working on the Nautilus release, which is actually on the verge of being released. It'll come out probably the beginning of April. But as far as that we have for lines of code contributed for Mimic, you have 537,000 lines of code contributed by Red Hat, and close second to the tune of 1/3 the amount, but the second greatest contributor to Ceph is my company, SUSE, and a lot of other great people, right? This is a bunch of people that are unaffiliated, just their own everyday run-of-the-mill garage contributions, right? A company known as Mirantis still, they've kind of left the game. Mirantis is a great company, but they've de-emphasized their involvement with Ceph. So although this number in the early part of 2018 was significant, it has dropped off a lot since they made that announcement. And then a company called ZTE, that's one of the other founding members, and a bunch of others, right? I just picked the top 5 that were here. SUSE produces, we have about 30 engineers that are involved in contributing to Ceph. Red Hat has, I don't know, what was the last count? They've got more than 100 that are working on, and not exclusively Ceph, right? They're still committed to Gluster, but their storage solutions, they have significantly more people that are on board with the development of Ceph. So they have a lot more contributions here. And of course, they've got Sage there who's running the project, and a lot of the other original Inktank guys that are senior officials in the governance of the project. But it's a great cooperative effort. Those folks at Red Hat, old Inktank guys, and we at SUSE, we work very hard, we work very closely together. And I'll mention that here in a moment. Actually, I'll mention it here. One of the great details that are coming along, first is sort of a preview in Mimic, and now is going to be seriously supported for Nautilus, is the Ceph dashboard, which is now a graphical interface to do the management and the interaction, the graphical interactions with Ceph now, that Ceph didn't have before Mimic. And we at SUSE had a product adjacent to our SUSE Enterprise Storage product called OpenAttic. And we got together with the Red Hat guys and said, you know, what we really need to do is bring these two things together. And so our OpenAttic developers ported all of the functionality from OpenAttic to make it native within Ceph, called now the Ceph dashboard. So it's a really great cooperative effort between both Red Hat and SUSE. At SUSE, we make 2 variants of Ceph, or that is to say, we're involved in making sure that we have an enterprise product, which is called SUSE Enterprise Server. But we also, in the efforts that we go through with Enterprise Server, we publish all of the bits that we are working on, as well as all the rest of the upstream Ceph efforts, compile it, release it on OpenSUSE for both Leap and for Tumbleweed. On Leap, we're currently shipping the stable Ceph Mimic, but actually available in Tumbleweed today, we have the latest and greatest pre-release bits for Nautilus, which is going to be released here in the next few weeks. All the work that we do in SES gets rolled down into the open source, the open distributions of OpenSUSE Leap and of Tumbleweed. Of course, the OpenSUSE bits are all community supported, whereas for those who want to buy into a support model where we'll help you fix all the bugs that you may have, then there's the SUSE Enterprise server that's available. And I have the links here that you can get to the leap and the tumbleweed bits for of Ceph. Ceph is composed of a storage cluster, which makes perfect sense. N number of nodes within this cluster. It's basically self-healing, self-managed. Now, self-managed, that's kind of misleading, isn't it, right? What it's trying to make sure is that it's keeping track of where it's storing all of the stuff, and all of the technical details it's keeping track of, and just says, hey, when you ask for the file, you don't care where it is, I'll get it for you. Generally, there are no bottlenecks. There are obviously caveats to that because you can implement or design a poor design of any cluster and have the whole cluster itself be bottlenecked. But when properly designed according to best practices, according to what it is that we recommend for it, there is no bottleneck. It'll just find the data wherever it needs to at equivalent speeds, no matter what it is that you're trying to find. And as I mentioned earlier, it excels in data durability. Let me make sure I'm clear about that, right? That's how it was originally designed. That has always been its particular focus, to make sure you don't lose your stuff. There are proprietary solutions that are going to be much more performant than something like Ceph. Don't let me mislead you. Ceph is fast. It's clippy. Those little cephalopods, if you've ever seen them swim, man, they can get around where they need to go. But there are faster alternatives if your value is speed, right? If you want the IOPS, you can buy a product that's faster. But for all the combinations of things that exist, with the durability, the scalability, and the open sourceness, you can't get any better than this. This is absolutely the best. There are basically 3 different ways to access the data. It's got its native object store, which you don't access natively, but it does provide an interface for object access for Amazon S3 or OpenStack Swift. There's block access. If you've got some native Linux application, you can just use LIO to attach to the data that's there, or a few different gateways that are available, right? You can get to these, the storage store through KVM or iSCSI, a variety of different ways. And then we have, in a recent release of Ceph, now the introduction of distributed file system storage, which is called CephFS. That's really a unique name, right? Everybody loves it. It's great. CephFS. We couldn't have come up with any better name than that. And associated with that CephFS, you can also access that file system data with the likes of NFS through NFS Ganesha. So there's lots of flexibility in how you get to your stuff. A basic Ceph architecture looks like this. You have the baseline object store that's been called Rados or Rados, and it is much more imaginative than CephFS, right? You've got the reliable, autonomic, distributed object store, or Rados. You can hear someone like like the Arby's commercial guy, right, saying that with a really deep voice. We have the meats, right? Rados. And on top of Rados, you have these basic interfaces for those 3 access methods. You've got the Rados gateway, which provides for object storage interface for S3 and Swift, and it's a nice RESTful interface. You can get to the block storage through the native LIO access, obviously, but with a gateway to allow provisioning and snapshots for iSCSI and the like. And then you have the CephFS that we were just talking about that provides a POSIX-compliant file system mechanism that's very tantalizing for the likes of Hadoop or just regular file system storage that you might want to have if you don't care so much about your own EXT or ButterFS kind of environment. 3 great ways all rolled up together. So a quick look at how this is, right? This is, I pilfered this from an old set of slides that I have. This is actually slightly wrong, and I didn't have the disposition to actually change it yet, but I need to. On a node, on a storage node, you have 3 basic sets of functionality. You have the physical disk itself, and then sitting on that disk, you have some file system. And this is the part that's a little bit misleading because in the recent passed, we just took advantage of XFS because we thought, hey, we don't want to be in the file system business. We'll let somebody else take care of it. And that's good, right? We let it be somebody else's headache. But then we thought, well, for performance reasons, maybe we don't want some of the overhead that's associated with XFS. So we're going to build our own. And there are pros and cons with that, but we created now a new file system mechanism that's exclusive to Ceph that's called BlueStore. And of course, it takes advantage of a few other not ours technologies. This whole database is based on everybody's favorite Facebook database. What's the name of their database? RocksDB, right? So we use RocksDB to help manage all the metadata that's on the file system. But it's our own proprietary. It's open source. What am I saying proprietary for, right? But it's our own invention of a file system that provides for effective Ceph usage. Please ask your question. Correct. Yeah, it's part of the Ceph development here. I'll try not to say stuff that's just SUSE specific. We're just a Ceph discussion here. And then sitting on top of that is a daemon called the object storage daemon. And for each disk in a node, they all have their own OSD that runs, that just keeps track of, hey, what am I storing in my database, and what am I storing on this disk? So that's the OSD process that runs. So if you have 8 disks attached to a node, you will have 8 OSDs that are running on there. And these OSDs all know how to talk to each other amongst all of the different nodes. And as they're talking to each other, they all know what they're storing, and then they are able to serve their stored data out to whatever client it is that says, hey, I need my file. Oh, I've got it here. Here's the file you're looking for. And if anything were to happen to disk N inside of this node, then all the peers know that, oh, some disk has gone bad. Where's the other replica for that? Let's now make up for the fact that that doesn't exist anymore. That disk has gone bad. So they all are able to talk to each other to keep the data relevant and replicated all throughout the entirety of the cluster. Those disks usually are made up of 3 different varieties. The most common is still our everyday run-of-the-mill cheap HDDs that we affectionately call spinners. There's also the solid-state devices, SSDs, which nowadays are really getting less and less expensive, more and more affordable. And I'm told that we're on the verge of another SSD innovation, a revolution there that's going to bring the capacity up and the costs way down yet again. So that's good. Now don't be fooled, right? If you're going to buy the SSD that you can get at Walmart that you're going to put into your home system, no, that's not going to do it for you. You've got to get enterprise class SSD devices. As a matter of fact, Kifu, no, is it Kifu? It's not Kifu. Somebody in the community keeps a web page up to date on a weekly basis about what SSDs are available and which ones are going to provide you the mean time between failure results that you're expecting to get and the IOPS performance that you're expecting to get. So make sure that you're getting enterprise class SSDs. And the cheaper these become, the less you'll be inclined to use spinners. But there's still a good case for spinners that we'll get to here in a minute. And then the most current technology that we have, which is kind of similar to SSDs, the non-volatile memory express flash capabilities that exist. Still pretty dang expensive, but if you've got the money, this will give you the performance that you want. The best thing that you can do, though, is that you can use all of these things in concert, right? You can tier these, or you can say, keep my raw data on the spinners and just keep all of my metadata and my journals on the faster devices, and you end up having a great combination of storage capabilities there. So you have a bunch of disks and their associated file systems, and hence further the variety of OSDs that are running, and they're all represented as a particular node, right? So in this node representation that you're going to see on the next few slides, this is a node with the disks and the file systems and the OSD all combined together. Each physical disk has an OSD, and of course you don't want to use all of the disks on your system because you have to have an operating system on that server. So save one disk or maybe 2 if you want to mirror the OSD, or the OSD. If you want to mirror the OS, that's a good idea. That's a good best practice there to have some redundancy for the OS on that node. But then you just give all the rest of the disks to Ceph, and it takes care of it, self-managed. It just takes the disks, sucks them up, hoovers them up if you're English, and makes them all part of the storage cluster. There's also one other kind of node in these clusters called the monitor. It's the brain of the cluster, and it's not in the data path at all, right? None of the OSDs even really care about what the monitor does, but the monitor just keeps sanity going on in the cluster. It knows what the OSDs are, it knows which ones are healthy, it knows which ones are sick, it knows which ones are overworked, and it just keeps this map of what's going on with all of the different nodes within the cluster. And it has to be it has to form a quorum, right? It uses the Paxos protocol to make sure that the data that it's managing is authoritative. So you have to have at least 3 monitor nodes in your cluster, and you need to have an odd number of them. Now, strangely enough, you don't have to have more than 3 monitors in your cluster. There are some customers that come around and say, oh yeah, well, I'm going to have this really ginormous cluster, so I'm going to have 5 monitors. And between SUSE and Red Hat, we've been monitoring this, that was a pun. We've been monitoring this for a really long time, and we still, even with CERN, one of the largest clusters that we're associated with, they only need 3 monitors. If you want to have 5, go for it. Yeah, you got the hardware, hey, knock yourself out. But you basically only need 3 monitors. They'll handle the load. So you put those nodes, those storage nodes together with 3 monitors, and you got yourself a nice little handy dandy Ceph cluster, I can say that. And maybe we want to get some data, right? Of course, you don't want to store data if you can't get there, right? So you've got some sort of client that's running. Maybe this is a CephFS client, and it's trying to then write some file system data, and it's going to go over to the cluster, and it's going to say, I want to write this file, and the cluster says, hey baby, we got it. Leave it to us. And so somebody in that cluster grabs the data, and it makes, by default, 3 different copies, replicas of 3. That's configurable. And of course, you don't even have to use the replica mechanism. You can use erasure coding. That's one of the RAID-y kinds of technologies that we implement also in Ceph. But for the purposes of this demonstration, we're showing replicated distribution here. And so he takes the copy and he makes 2 friends. And now we've got the stored data. And then as soon as the cluster has verified that it has the data and it has given that instruction to 3 nodes to write the data, it sends it back and says, that's ours, we got it, your data is safe in my cluster. And of course, what clustered storage solution would be complete without the ability to get the data back out? And so you've got a client that comes along and says, hey, remember that file I gave you a little while ago? I need that back. So you talk to the cluster says, hey, I know where that is. Let me give you the one that is fastest. And so this guy says, oh, here it is, boom, client's got it. Now, do you need a little more storage? Just add a few more nodes. Need a lot more storage? You just add a few more nodes. I'm simplifying it, obviously, right? All of a sudden you're in 2 cabinets, 3 cabinets. You've got to have some robust networking in the top of the rack there for that to work effectively. But you think it up, we can do it. You get the right networking, you add as many nodes as you want, you have 3 monitors, and you're good to go. Now, can you do data center replication on this? Yeah, you can. It's not great performance, but it's hugely robust. You want to put a backup set of your data in a data center across the hall? Piece of cake. Now, if you want to put that backup data center across the country or across the planet, things get a little more complicated. But it certainly can be done. And it's because of this robust mechanism of these clusters all talking to each other. If you want to use CephFS instead of block storage, you do have to have one separate dedicated node called the metadata server that provides all of the POSIX capability. Now, it's entirely technically possible to have a CephFS system without a metadata server, but anytime you want to do a find, anything you want to do, anything POSIX-E, you've got to have something that's keeping track of all that POSIX metadata for each of the different files that are stored, and that's what the metadata server does. And you could conceivably, for high availability purposes, have n number of metadata servers and have them fail over one to the other. It's not necessary to have multiple metadata servers for performance, at least not that we've found yet. You don't need to have multiple metadata servers, but we do allow for the duplication of metadata servers in case you want to have that kind of redundancy. Yeah. Now let's see, now what do I have on this slide? For Rados, its native object store, I mean, this was its base design. This is exactly what objects were designed for, is for large scalability, right? But even so, with Ceph, that was exactly what Sage Vial was after. So with the object store, we just simply keep everything together down in our native object store, and then can certainly make it available for what other object application that it is that you have, whether that's S3 or Swift. And it's better that we're dealing with large-ish objects, but it's okay. You can have small objects. That's certainly not a problem. And of course, we're avoiding single points of failure. Everything is very robust, redundant, at least 3 replicas, or with erasure coding, you've got that spread out in a RAID-y variety kind of way out throughout the entirety of the cluster. And it's entirely distributed, so you can configure it to have replica 1 in cabinet 1, and replica 2 in cabinet 2, and replica 3 in cabinet 3. And there you have those 3 replicas so that you have a lot of that robustness that you expect to have. To be able to do all of this stuff, though, then you do have to have some robust servers with some RAM, and with some cache, and with some CPU, and of course with some disk. And so you don't want to go out and just buy the cheapest hardware that you can get. You want to have some enterprise. I mean, if you're toying with this in your garage, you're just making a Ceph cluster for your, storing your DVDs in your basement, then you can buy whatever you want. But if you want to have something that's going to do what Ceph distributed software-defined storage is intended to do, make sure that you're getting hardware that's equal to the task as well. So there are 3 essential components to storing and managing all this stuff. And we'll talk a little bit about pools, placement groups, and crush maps. Here I'm checking the time. Pools are just a way of logically grouping your objects. You could create a pool for Department A in your business, and a separate pool for Department B, and a separate pool for Department C, that then those different departments have control over their own sets of storage for their particular department. And typically these pools are all organized in a very comprehensive way. It makes sense to you, right? You have to give the pool a name. You need to tell it what kind of redundancy that's associated with it, whether the number of replicas, or how it is that you want to manage your K plus M erasure coding mechanism that you've decided is the best for your organization. And you have to identify a number of placement groups. I'll talk about placement groups in a minute. You also are going to have a bunch of crush rules. You could take the regular crush rules as they are by default, or you could customize them, and we'll talk about crush rules in just a moment. And then as part of that pool, you also need to say an owner. So for the pool that's going to be controlled by Department A, you're going to make sure that Department A is the people that have access to it, and the Department B aren't going to have write and read access to what's in the pool for Pool A. And of course, as any good storage mechanism is, that set of core functionality is going to allow you to create objects, read them, write them, and also you can create snapshots for those objects. Now for placement groups, this is kind of a weird thing that kind of trips some people up, and that's okay. If you don't understand it, it's actually not going to cause you any problems. You will have to understand it a little better, but I'm going to give you a nice promise that with Ceph Nautilus, you have to understand it less. We're going to do some automated placement group manipulation if you want to. If you want to give that kind of control over to Ceph and just let Ceph handle the headache for you, you can do that. If you want to be cool. If you want to have more control over what's going on with your Ceph cluster and then control those placement groups more manually, you still can do that. You have some more options here. This is just the way that the OSDs, that Ceph balances the data across n number of OSDs. And there's a kind of a ridiculous math algorithm that you use. There's actually a tool on the Ceph.com website that helps you to calculate the best way of how many placement groups that you should create for a particular pool. One placement group will typically span several OSDs, like is shown in this diagram right here, and one OSD typically serves many placement groups, and it's entirely tunable based on what's going to happen in this particular pool of storage. If your pool, if the data in your pool is going to change really fast, rapid change of files within there, or it's going to grow really fast, you should have a larger number of placement groups. And of course, these formulas that we provide for you, or your consultant provides for you, or the website provides for you, helps you to make that calculation appropriately. If you're going to have really, really static data, you're just going to write it once and then people are going to just read the brains out of it, then you don't need a large number of placement groups for that particular pool. And then there's this other acronym called CRUSH, the Controlled Replication Under Scalable Hashing. That's cool, right? Somebody got some money for that, I'm sure. That is the way that you, as the storage administrator, now makes designations of how best to organize the data in your data center, so that you can decide that for this particular group of users or this particular application, you need to have that in a set of nodes that have the fastest disks and the most CPU and RAM, so that you can have the fastest IOPS for that particular application. Or you can customize your CRUSH map so that you are spreading it out over a specific set of racks in your data center. Or that you can organize your data so that it has the most optimum disaster recovery resilience, right? The CRUSH map is the system administrator's tunability of how all of the data is supposed to be organized across all of the different nodes. And the users don't really care how this works. They just need to be able to get their data. So when the client system comes to find out where the data is, the user doesn't have any idea that any of this weighting is going on and all of this measurement is going on and all of this access is going on. It just comes and asks it, and the CRUSH map and the monitors all know, okay, go find the data over there, and boom, the client goes over and gets the data and brings it back. So, with all of this, the components working together, there's some kind of object, some file that you're trying to store. You're going to go through the client. It's going to get lined up in some pool designation. The pool is spread out over a bunch of placement groups. The CRUSH algorithm says, well, the best place to put that is in this placement group. That placement group says, hey, yeah, well, then because I'm talking to these bunch of OSDs and that OSD is not doing anything right now, put that data over here on the OSD. And then the OSD says, yes, now I have that data. Let me give that to my two brothers over here for three-way replication. And then it sends all the information back, says, hey, we got your data. And the object says, great, I'm safe in Ceph. So, a few bits with the time that I have remaining here, right? Let's talk for a minute about legacy storage arrays. Now, if you go to your NetApp organization, they're going to have a different list, and I accept that I'm biased, and I accept that they're biased, right? So we've got these kinds of limits associated with these traditional storage mechanisms. It's a tightly controlled environment. It's not open at all. There's some scalability, but it's limited compared to what it is that we can provide in a clustered system like Ceph. It's relatively expensive. Don't be too fooled by this, right? Once you get what's the word I'm looking for? Competent. Once you get competent hardware in your software-defined system, it's also going to be expensive, but not as expensive as your proprietary guys are. And you don't have as much flexibility and as many options that are there. Now, they're going to tell you something different, and to be honest with you, the folks at EMC or at NetApp, they have a lot of functionality. They've been in this business for a long time, and they're good at it. I'm not faulting them at all. Boy, they're good at it. They have got really well-designed hardware and software. I love them. They're really great. but you can only use their specific drives. You've only got what it is that they can tell you in their shelves for those number of slots. You don't have as many variants in what it is that you can do with RAM. You're just stuck with what it is they're going to provide you. You're stuck with their networking hardware. You can't just go get commodity networking. You got to use NetApp's networking technology. And you're limited to what CPU and RAM that it is that they can provide for you. The benefits are, though, they do have a long track record. They're really good at what they do. You know that you're going to get value out of what it is. You know they're going to give you the support. As long as you're paying your support contract, they're going to take care of you. They're really going to take care of you. And it's a very predictable pricing structure. But let's talk a little bit about software-defined storage. And of course, NetApp's list is going to be very different here than mine is. But the biggest complaint about software-defined storage is it's slow. And I'm going to tell you that's not true. Ceph is really fast. It's just that it's not its forte. That's not what it was designed to do. Its emphasis is durability of the software, of the system. So don't think that just because we say that it's slower than NetApp or slower than other proprietary systems, that it's slow. It's not. If you design it right, you can get good performance out of it. That's one of the challenges, though, about this. I should have put this as a bullet point, right? Who's responsible for making sure that it gets tuned right? You are. If there's something about your NetApp system that's not tuned quite right, you pick up the phone and they're going to tune it for you, aren't they? Pros and cons. The best thing about software-defined solutions like Ceph is that you've got basically infinite scalability, infinite adaptability, just a nearly infinite number of choices, and just all the flexibility in the world of what it is that you want to do with the beast. When you're thinking about a software-defined storage system like Ceph, though, make sure that you have a good idea of what it is that you're trying to accomplish. Because maybe your legacy, everyday, run-of-the-mill, current-day shelf technology is the right thing for you, depending on what your use case is. You need to think about the pros and the cons, the balance that you need to strike between availability of your stuff and the density of the stuff that you're trying to store. Ceph does not do well at 90% full. You got to keep it 80, 82% full, or you're going to start seeing problems. Your data is going to be rock solid safe. It's going to be there. It's never going to get lost. It's never going away, but it's going to slow down. Right? You need to think about your performance in terms of IOPS. Now, whenever anybody talks about storage, they say, oh, IOPS, yeah, I need IOPS. I gotta have the fastest performance. That's not true, right? You need to really think about what it is that's your data usage. What's your use case? Because you might not need the very fastest access that you think you need. If you do the calculations, you'll have a much better idea of how you need to balance these kinds of things. And then, of course, you always need to consider what the cost is. If you just want the latest NetApp stuff that's going to give you the best iSCSI performance, and you've got the coin for it, do it, right? But if you want to have a lot more flexibility, and if you want to have a lot better long-term growth, and if you want to be open, then NetApp is not the way to go. I'm not bad-mouthing NetApp. I love NetApp. I've been a NetApp customer off and on for a long time. Boy, they know this. They know the business. They're good at what they do. But it isn't everything, right? And I'm going to mention that here in this last bullet point right here. You have a lot more hardware options, but it doesn't mean that you can just buy anything that you want. But you need to also understand that now you get into something like software-defined storage and Ceph, and now you're in control of that software environment, and you are the one who has to do the management of all of that. So there's trade-offs with that. One size does not fit all. You may not really be the best use case for software-defined storage. Software-defined storage does not just say, we're going to solve everybody's storage problems on the planet. It's just not the case. Ceph is not the best answer for everything. One thing that you need to keep track of is the network. The network is just as important as the nodes in your cluster. You've got to have a competent network in terms of hardware. You have to have a competent configuration of that network in terms of the software, and you got to have some competent people that aren't going to screw up your network configuration, right? So you as a storage administrator have got to cooperate with and have some coordination with your data center network people. And if you're able to do it, make sure that you get in your agreement with your data center people that they don't touch your hardware, especially your network. I'm in control of my network because I don't want you guys coming in and messing up my storage. Because if you mess up my storage network, then nobody can get their data. And who are they mad at? Me, not the infrastructure guys, not the data center guys. They're mad at me because I'm the storage guy. You let them mess up my data. As with everything, choose the fastest network that you can afford. Please don't buy a network that you can't afford. It's not worth it. You'll need to have 2 separate networks. This may be 2 separate physical networks, but it could be 2 separate logical networks on one set of hardware. It's perfectly capable of managing that sort of thing. But typically, you need to make sure that the back-end communication between all of the OSDs, the private network, the storage network, is roughly 2 times faster, has 2 times the capability of the public network. And the public network is the network that's where the clients are coming in. And of course, the fatter your infrastructure, the better. Of course, I want you to use Gig E. Can you use 100? Yes, 100 is better than 40. 40 isn't necessarily better than 10 because 40 is just 4 tens. Yeah, so it's just kind of weird. But anyway, we can talk about that more outside if you want to because I'm running out of time. You need to have competent hardware. You'll need to make sure that you've got good CPUs and good RAM, but just get what you can afford, right? You'll want to have good storage controllers. And you don't want to just get some storage controller that can put 20 disks on it, right? Because then where's the bottleneck and where is the liability? The storage controller. If the storage controller goes bad, did you lose data? If you've got it all crammed into a shelf of 20 disks, you've got kind of a problem, don't you? So spreading it out is better, and to have good storage controllers is a good idea. Use your SSDs and NVMEs for your journaling and for your RocksDB, your metadata, taking care of all the metadata on the disks. And use your spinners for just your raw data, and it's easy to configure this with BlueStore. It's just simply a matter of saying, yep, put my data on the HDDs, and now I've got one SSD with these 4 or 6 spinners, and now that one SSD is the journal and the metadata server for all the rest of the spinners that are there. It's a great performance combination. That's what I meant to say. More about journals, right? Spinners, good. This is something for a different talk on a different circumstance. If we had more time, we'd talk about these kinds of things. The great takeaway here is that SSDS, as good as it is, and as much as I'm trying to sell it to you, it's not a golden hammer, right? It doesn't solve all problems. In small, simple environments, if you only have terabytes of data, and if your data is fairly static and it's not going to change very much, then just go get yourself a nice shelf from Dell or from HP and call it good. And particularly for single-threaded, ultra-high performance requirements, Ceph is probably not your best choice today, right? We keep working on higher performance, higher throughput kinds of changes and tweaks to it, but the emphasis is on reliability and durability of data. So, software-defined storage in Ceph best accommodates long-term growth to give you the best opportunity to increase capacity, to manage more complex data over a long period of time is the best. But it's not the best if there are other things that are in play that might have you think not to use Ceph. So sizing considerations, and then we're here at the end. So thank you for letting me spend some time talking about software-defined storage. Like I said, if you don't like my presentation, go see Alan Ott on Sunday. I forget what time it is, but I think he's over in room 107. I can't remember. I'm sorry. Look him up in the schedule. Alan's a really smart guy. He'll tell you all the stuff that I didn't tell you today. But I'll open it up for a few questions. Doug's got the mic.
So I have 2 questions. So the first question is, you mentioned if it's designed poorly, that leads to a lot of problems, and you hinted at it with how you set up the components and how many you have, but what are the big 3 things that people do wrong when they set it up that causes problems? And then my second question is, isn't Ceph good for certain types of workloads, as is Gluster, and then there's other workloads that it's just really not suited for and you shouldn't go down that road?
Great questions. Let me answer the second one first. He's talking about specific workloads. Definitely true, and if we had had more time, I would have drilled down into that in a little more detail. Gluster, so EDC, the consulting company, the analyst company guys, they call storage mechanisms by two different types. In fact, they call them type 1 and type 2. And type 1 is the traditional variety that is more what Gluster is after. And that's the more legacy, common kind of storage, traditional storage that we see today. And then EDC calls type 2 the software-defined approach that's intended to be more flexible, more agile, and greater scalability capabilities. So if you just have a type 1 application for your business, for your work need, for your use case, Gluster is great, or just your everyday run-of-the-mill ext4 on a Dell shelf, and you're happy, right? But if you have long-term scalability needs with high demand for durability and reliability and manageability, then Ceph and SDS is the way to go. Likewise, if you're talking about a bunch of small files, then Ceph is not the best. Gluster is a better choice. Traditional storage is a better choice. If you're talking about large variety of files, particularly large files and rapidly changing files, then Ceph and software-defined storage is a better choice for you there. Now back to your first question, which now I've already forgotten. What was it? Just shout it to me really quick. Oh, design. Yeah, what are the 3 bad things that people do? Yeah. 2 wrong is that they forget to enable big, what do you call that? Jumbo frames. They forget to enable jumbo frames, and you have to have jumbo frames node to node. It has to go all through the data path. That's one mistake that people make. Another one is they're just too small, right? They try to put their cluster on 100 megabit network cards, and switch, and that ends up being a problem. And you'll be surprised, right? One mistake that a lot of customers make, particularly in terms of hardware, is that they don't realize that cables matter. They go into the closet and they pull out those old dusty Cat5 cables that aren't being used and they plug them in, and you're not going to get what you need out of those Cat5 cables. You need to have, and you need to test. You need to test your infrastructure, hardware and software going into it. Those are the kinds of mistakes that people make. Next question.
Just a question on SSDs. You mentioned that you really get an advantage out of the enterprise SSDs. And I remember researching this when I did my Gluster setup. I haven't used Ceph yet, but it seemed to me like the main advantage of enterprise SSDs was the over-provisioning, and it was actually cheaper to buy just more prosumer SSDs than to get the over-provisioned enterprise ones.
Okay.
The only other difference I saw was in the firmware of the SSD, and that was related to RAID controller, but it seems to me like it would be better off using a JBOD setup and letting Ceph manage it.
Fair enough.
What should I do?
Well, so I'm still going to tell you to use enterprise class. And if you go look at Kifu's, I can't remember if it's Kifu or some other engineer. I can't believe I'm drawing a blank here. But one of the engineers keeps this website of all of the performance data of all of the SSDs. And you can see that those consumer grade SSDs perform great for 3 weeks. And then the performance just crashes. And we're not talking about tailing off. We're talking about spike straight downward, right? And it's just because they're not engineered to the same specifications. Yeah, I highly recommend that for a few pennies more that you get the enterprise ones. Next question.
So, well, actually, we're going to
So sorry.
Frank's up next, and if you have questions for Craig, you could.
Thanks, everybody.
Go outside. Thanks.
Test. Okay. Okay, let's get started because I have too many slides for not enough time, so I have to be really fast. My name is Frank Karliczek. I'm an open source guy for a long time, for 20 years. It's a bit scary, but yeah. I started to contribute in all kinds of different projects, KDE at the beginning, or part of the OpenSUSE community, obviously, like everybody in Germany, I guess. and then founded OwnCloud, and then the successor, Nextcloud. And this is also the topic of the talk. So I want to talk a little bit about Nextcloud, obviously, what it is, how it can be used, how to get it, how to contribute, and then time for questions, hopefully. So, who knows Nextcloud? Okay, so that's like half. Okay, so I want to give you a little bit of an introduction. This is like the elevator pitch at the very beginning. So Nextcloud is an alternative to Dropbox, to G Suite, and to Office 365, with fundamental differences, obviously, that it's self-hosted. You can host it where you want. You can run it where you want. You can host it on a tiny Raspberry Pi. You can run it in a big data center. You can actually run it on AWS or somewhere else. You can choose where it's running. It's 100% open source and free software. So all the components, the server, the clients, everything is 100% free software. And it's all built around distributed and federated ideas. I will talk about it later. So this is the web interface. It has a web interface. If you log into Nextcloud, you see something like that. It looks basically a file manager. You have your files and your folders, and you can search them, and you can filter them, and you can, in the sidebar, look at versions and comments and all kinds of things. You can manage your files with it. But a lot of the users of Nextcloud actually never see this. They never see the web interface because they use our clients. So because we have really rich clients, on the left-hand side is an Android app for smartphones and tablets, where you can do all the same thing natively on your phone and your tablets. In the middle, you might think this is the iOS client. We actually have an iOS app, but this is the normal file manager from iOS itself, where we have a plugin. You can see that there's iCloud from Apple, and just below it is Nextcloud. So Nextcloud is a first-class citizen on iOS. You can actually open and save and store and do all kinds of stuff from all iOS apps directly inside Nextcloud. Very similar or the same as with iCloud from Apple. And the right-hand side, you can see a tablet interface, also iOS in this case, where you can see that there's more you can do. And if you have a bigger screen, you can do more stuff. You manage your files, look at PDFs and other stuff. So we have very good clients. And also, we support also all kinds of other rich use cases on modern devices. And here, for example, push notifications. We have rich push notifications where you can get a notification if someone wants to talk with me or mention me in a comment of running out of quota and all kinds of other things. And even works on other devices like smart watches or televisions and all kinds of things that support this kind of stuff. And we also have desktop clients, of course, for Mac, Windows, and Linux. This is built with Qt and with C++. It's basically for synchronizing folders from your laptop or your desktop to your Nextcloud server. It's very similar to OneDrive or Dropbox, but it's more flexible because you can actually synchronize to different servers. You can say, I want to synchronize my photo folder to my private Nextcloud, and then I want to synchronize my work documents folder with my work Nextcloud, and so on. And also there we have very rich integrations. You can just click on a file and directly from the file manager. And again, this works on Mac, Windows, Linux. And Linux, we support GNOME and KDE Plasma. You can directly share with the person directly on the desktop. You get this nice dialog where you can configure expiration dates or set passwords and all kinds of things. And you also got push notifications on the desktop. So this is all basically all possible on all platforms, and you never have to use the web interface. You can do everything in the web interface if you want, but it also works natively in all in all common desktops integrated. Okay, now I have all my files in Nextcloud. That's great. What can I do with them? First of all, you can look at them, of course. Here, for example, is our built-in PDF viewer. You can look at PDFs if you want. If you uploaded pictures, then there are automatically picture galleries generated from all my pictures. So again, all on my own infrastructure, self-hosted, right? It might look similar to Facebook and Flickr and other stuff, but this is all on my infrastructure. And you can also, with this share dialog on the side, always share with other people, set expiration dates, set a password, and so on. Support two-factor authentication. So usually you integrate into some kind of LDAP or Active Directory in the backend, and this can do some kind of advanced security, but we also support two-factor authentication with hardware tokens or second factor via SMS or OTP protocol. So it's very, very secure. We have this federation feature, which is very flexible. So let's say we have many, many of those Nextcloud servers. Let's say one of the Nextcloud server is so that one is my Nextcloud server at home, and this is my work Nextcloud server, and here's another Nextcloud server at a service provider, and we can all share folders with each other. So it basically behaves from a user perspective as one big service. It has the same usability and can do the same thing than Google Drive or Dropbox, but there is no central server, right? There's no central components, all completely federated and distributed. We use the Open Cloud Mesh API, something that we designed, but other vendors support this too. This was built together with CERN and other organizations, so it's a fully distributed system. Another concept is data access engine, where you can mount other existing data sources into your Nextcloud. Let's say you have a Windows Network Drive share or SharePoint S3, FTP storage, something. You can all mount this into your Dropbox, into your Nextcloud, and consolidate like Dropbox into one thing. A lot of organizations, they have like legacy Dropbox accounts or legacy Google Drive accounts, and you can say, look, employees, you're no longer allowed to use it, but you can mount it into your Nextcloud, and then you have a migration period of, let's say, a year or something. You can move your files over one after another, and then we kill the connection completely. So this is useful for that. But if you have your data, then all aggregated in your Nextcloud, you can do useful stuff like full text search, where we can use Elasticsearch to index all your files. Doesn't matter where they are. You can be in SharePoint or in some other Windows server or something, but it's all visible in Nextcloud and can all be found. You can also use other features like this file access control or file firewall, where an administrator can say, my people, my employees, they can share Word files bigger than 10 megabytes that are tagged with secret to iOS devices on a Saturday to an IP address from China, only if in the marketing group or something like that. Not a very useful example, but I think you get the point. You can really model this kind of permissions in a very nice, fine-grained way. We support end-to-end encryption. So you can actually encrypt your files on your clients automatically, that on the server there are only encrypted files. And we also support like recovery keys and enterprise-grade key management, so it's actually useful in bigger organizations. So Nextcloud is used on very small devices. You can actually run it at home on a Raspberry Pi for 3, 4, 5 users. That's totally fine. But it also scales to many, many users. So we have the bit of a problem that we also have very big customers. So our biggest installation actually has 20 million users. It's a big service provider, 20 million users. And with this kind of architecture, you want to have like more than one data center. Obviously, this is a cluster setup, sure. But even a cluster setup comes to its limit. So this kind of architecture, you want to run on different hosting centers on different continents distributed. And that's possible with the global SCaLE architecture, so we can support that. We have a plugin for Outlook. So in a lot of companies, they have Outlook used by all employees. We actually have a plugin where you can attach a file to an email. You press send. Then the attachment is automatically uploaded to Nextcloud. A share link is generated and put into the mail, and then the mail is sent. This has the advantage that first of all, you can send unlimited attachments, unlimited size, and also you don't waste space on the Exchange server, which is very expensive. And you can also still know who opens the file what, because you have the full auditing if you want. There are groupware functionalities. So if you build in calendar and contacts management and email management if you want. Not everybody is using every feature, by the way, but you can enable and disable them as you want. But that's actually one of our favorite features from people who want to get away from Google. So there's a very nice calendar, contacts, and email functionality. We even have project management functionalities as a plugin in Nextcloud. This is a Kanban board, very similar to Trello, but again, 100% open source and 100% on your infrastructure. A new feature is in the social area. So we actually implemented the Mastodon API. I don't know how many people know Mastodon here. Okay, a few, yes. Very nice, distributed, federated, open source social network, very similar to our philosophy. So last year we implemented the API. So every Nextcloud server can also be now a node of this Mastodon distributed social network. So you can easily share files and photos into this social network, and also in the activity stream see messages from other servers, from other users. There's a feature called Nextcloud Talk. That's a communication feature. So this can do different things. It can audio, video calls and chat, and you can use this for like one-on-one communication, but also for group communication. So the basic functionality is something like chat rooms. So it looks very similar to Slack or Microsoft Teams, where you have different rooms and you have communication messages. And we also have native iOS and Android applications. Here's the iOS application, I think, where you can also chat and get push notifications if you mentioned in the room, for example. But again, everything is open source. The clients are open source, the server is open source, and this can all run on your infrastructure. Right? Not like Microsoft Teams, not like Hangouts, not like Slack or others. Like on your infrastructure, very secure. Of course, you can also share documents in your chat channel. If you have a document, picture, Word file or something, you share it into the chat channel. You see a preview, you can click on it. You can even like view the document and edit the document if you want in this room. You can press the start call button and it transforms into a video call. So this is again something that's using WebRTC. It's an open standard, and all the communication is again peer-to-peer and fully end-to-end encrypted with many users. I mean, out of the box, it supports like 3, 4, 5 users in a room, and then it just reaches the capacity of this end-to-end communication. But we have additional component called an MCU, which aggregates the data, and if you install also this component, then we can really have like 100 people in a room. Then, of course, document editing is another very important feature. We can actually edit Word files and Excel documents directly in the browser. And we have two solutions. One is Collabora Online. This is using LibreOffice on the server for that. And another component which is called OnlyOffice, which does something similar. It's just another solution. So you can edit your documents directly in the browser, similar to Office 365. And of course, you can also do this with other people in a team. So in the sidebar, you can extend the sidebar, invite other people to the same document, and then you have several cursors at the same time in the same document. And this can be a LibreOffice ODF, ODT file, or a Microsoft file. But it's all great if you like 5 people together editing the same document. That's nice, but maybe it's a bit confusing. You need to coordinate, and because of that, you can also in the sidebar have a chat channel and a video call with the people editing the same document at the same time. I'm actually very proud about this feature, because here we're actually able to innovate above Google and Microsoft, because they can't do that. Skype for Business, for example, is a completely different window. It's not the same than Word Online. So this is something which is very innovative. And then we can also do spreadsheets, of course, where you can edit like spreadsheets. And I picked an example with charts and with formulas, where you can see that even complex Excel sheets can be edited like that. Here's a screen of the same interface on an iPad, and the same was an Android device too, right? We have native integration. The native applications can do the same. You can browse your documents here. You can click on a Word file, and you get an editor on the side. And the same with the chat and video calling feature. So that's actually very powerful. And it's just one of the many, many examples of the functionality that's available in Nextcloud. We have something called an app store. It's not really a store because everything is free software and for free, of course. But there's a repository from our community with over 200 plugins for all kinds of extended functionality. Okay, so this is all great, but of course you're asking, okay, how do I get this? I mean, and what's the real difference to Google and Microsoft and the others? How do I get it? Well, first of all, the very easiest solution is you just download one of the clients. You go to the iOS App Store or the Google App Store, download the client, and then there's a button, get an account, and you might think then you create an account on our server. No, that's not what happens, because we don't host any data of you. We never will. We are not a service provider. We only do the software. But if you click the button, you're redirected to one of the many, many service providers who already offer Nextcloud. And there you can create an account if you want that. But of course, like in this audience, you really want to host it yourself. And for that, there are also many, many options. You can download it from our website. There are also packages for SUSE, for example. And for other distributions, you can just, very simple, install Nextcloud and everything works out of the box. If you prefer something a bit more pre-configured, there are also virtual machines available for download, Docker containers, Snap packages, basically all kinds of ways to get the software if you want. There are even companies and organizations who offer devices. So there are some companies where you can buy a device. I think here's someone who sells one of those. Yes. Yeah. So there are also companies, again, we don't do this because we are only an open source software organization, but many, many other organizations actually sell hardware with Nextcloud pre-installed. So that's very nice. And of course, if you're a big organization and you want to run Nextcloud for a few 10,000, 100,000 users, then we are also happy to provide enterprise support and enterprise subscription to you. We have the same business model than what SUSE and Red Hat others have. You get an enterprise subscription for enough as if you want. If you want to contribute, that's also very easy because Nextcloud is actually an open source project. So we counted over 1,800 volunteers lately. Over 1,800 volunteers contribute to Nextcloud, and this is only the code. Of course, there's more like translations and testing and marketing and so on. And we are really completely open. Everything's on GitHub, all the feature requests, all the bugs, the roadmap. You can really be part of it. Like all the software components are there. You can have a look. And we also care about diversity. So we have a new initiative called Nextcloud Include, where you can also fill in something into the contact form if you want to have support in the area of mentorship or internship, travel support, all kinds of other things where you can become part of it. Okay, the summary. I'm running out of time, I know. I want to repeat a slide that I showed at the very beginning. So Nextcloud is a real alternative to Dropbox, to Google Suite, to Office 365, with the difference that it is self-hosted, open source, and distributed and federated. So in a way, we are a bit like the anti-cloud solution, right? We are basically giving you the same functionality that you can get from this nice big organizations, but you can run it on-premise, open source, on top of OpenSUSE or SLAS or something, and you have it under control and supported, and you keep your data where you want to keep it. So you don't have to give your data to Amazon or to Google or to someone else. You can keep it in your organization, in your stack, in your hosting center, together with your proven other Linux tools as before. But your users will have the nice new features that I know and love from these cloud companies out there. Thanks a lot.
Question, does your 2FA, your hardware key support, also work on apps and desktop sync clients, and if so, how?
I think it should, yes. I think we, 1.5 years ago, we introduced a new login flow, which is a bit inspired by SAML, which means on the clients, and this is the same for iOS and Android and Mac, Windows, Linux clients. If you actually want to authenticate against the Nextcloud server, you go through a web interface where you can, with a browser plugin, authenticate, and they get an access token back in the client, and then this is used to authenticate. So this should work. I'm not an expert in this area, but I heard that it should work.
Anyone else have a question?
Hi, that's a very interesting platform. I'm wondering about, you mentioned clients, so the browser client, is that something that is developed by Nextcloud and is part of the sort of a client that's bonded to the server? And if, for example, I was to set up a hosting myself and offer it as a platform as a service, how would the clients access it? Is there a client software that, or is it, what I'm wondering, is there an alternative to the browser? Does one develop like their own browser for?
Yeah. Sorry if I wasn't clear about it. I was just running out of time. So there's the web interface, of course, but a lot of people never use the web interface. So we have native clients for Mac, Windows, and Linux, and you can run them on your desktop, and they run as a small application in the sys tray, and just synchronizing the different folders between your desktop or your laptop and your Nextcloud server. So it's
for the Windows, for a Windows client, is there a way to do integration to where either?
Can you speak up a bit? Sorry.
Yeah, for a Windows client, because there's still so many people who are running Windows machines. Could you run virtualization? Do people have to package that to run within a virtual window, or do they have to run it through a browser in order to access all
you don't have to use the browser at all. There's a fully working standalone Windows client. You can, yes, there is a full working Windows client, and you can install it, and it runs like on your sys tray in the background, and very similar or really the same than Google Drive and Dropbox and OneDrive. You don't need the browser at all. If you don't want to use the browser, you don't have to. It's, yeah.
One other question. So I assume all of the actual file transfer happens through WebDAV?
Exactly.
And how do you deal with the performance hits and large files?
So the performance are two things. I mean, the performance in our experience is not really a big problem. I mean, sure, it all goes through HTTP and through TLS, and there's some checksumming and stuff, and there might be a little bit of more overhead than using, I don't know, sieves or something. But on the other hand, I mean, I wouldn't use sieves over the internet. So if you go through the internet, you need some kind of advanced encryption that HTTPS gives you. So I don't think there's a performance hit there. There is, of course, a bit of a problem if you talk about big files, the second part of your question. And that's true. I mean, this kind of transfer, they're not really reliable if they run for an hour or something. If you transfer like 5 petabyte file or something. And for that, we implement some kind of chunking. So implement the chunking, so big files are actually split into pieces, and they're transferred separately, and they're collected, combined together on the server side. And if the network connection goes down in the middle, it doesn't matter. It remembers which chunks are already transferred and which chunks not, and then only transmits the chunks, and if the internet connection works again. So we don't really have a file size limit. It should be quite fast. I mean, if you just use some more native protocol like SCP or something, I'm sure you get like a few % faster performance. But all this happens in the background asynchronously, so users probably, most of the time, don't really see the difference.
So it's impressive work. I hadn't heard about this until today. Can you talk a little about the finances? There's lots of people involved, obviously, in producing a product like this. Are you getting most funding from large enterprises or governments?
So our business model, it's actually quite nice to talk in this audience here because you probably understand this. It's very similar to what SUSE is doing, I have to say. So it's free software, you can download it, you can use it same as you can use OpenSUSE, that's all fine. We think that if you run something like that in a mission critical way in an organization with a few thousand employees, then you probably want to have an enterprise subscription, you probably want to have 24/7 support, you probably want to have like a hands-on workshop to deploy everything, you probably want to have security patches guaranteed in a certain time frame and so on. The same stuff you get with a SLAS subscription, that's the same you get from us. So we make basically 100% of our money with the big companies. Governments too. The German government is a Nextcloud user with 350,000 users. Yeah. Yeah.
What is the difference between OwnCloud and Nextcloud, and why would I prefer one over the other?
I have a talk about this tomorrow, and I'm probably a bit. Sorry.
Another question I have that's quicker to answer. I've already paid for OwnCloud for iOS. Would the other app is the same kind of structure as far as pay once and fee one?
So you really should come to my talk tomorrow. So the quick answer is I founded OwnCloud, and there were some things that didn't work out so well, and more about this tomorrow. Because of that, the core team, including me, founded Nextcloud as the successor. And I think that a few things are better now, including, for example, the not free software iOS app, which now is free software and also for free. So I'm sorry that you lost some money on paying for the OwnCloud app. The Nextcloud app is free now, and many other things are also better now. But more about this in the talk tomorrow.
So my questions are about encryption. So are the voice video calls all encrypted, and are the do you have a secure encrypted file transfer solution, and are you using some kind of public-private key infrastructure for that?
It's really hard to understand. So the question is if the...
It's about encryption.
Yes.
So are the voice and video calls fully encrypted?
Yes.
And for the file transfers, do you have a secure encrypted file transfer mechanisms, and do you have a public-private key infrastructure that you have to implement on top of that? What does that look like?
Yeah, so this is I could talk about this for a long time, for hours. So it's encryption, there encryption on a lot of different levels. First of all, the transfer is of course all encrypted with HTTPS or TLS, obviously. And this is for everything. This is a file transfer, this is for video calls, audio calls, push notifications, chat messages, everything. So obviously transfer is always encrypted. So then for files, we also have encryption of files on the server. So server-side encryption on storage. And this is useful, for example, if you have storage not running together with the Nextcloud server. So earlier we heard a talk about Ceph. Let's say you use like some Ceph object store, and this is provided by a different organization, or somehow you don't trust the administrator of the storage. Then we can also only store encrypted data on the object store if you want. So we can encrypt the files on the Nextcloud server, encrypts the file and stores them encrypted on the storage. That's possible. And the third way that's possible is full end-to-end encryption. In this scenario, we encrypt the files on the clients, on the macOS, Linux, Windows, iOS, Android clients. All our clients support this kind of encryption, and they're stored encrypted through the Nextcloud server on the storage. This is also possible. It's the newest, most advanced feature, but it comes with some drawbacks. For example, the web interface doesn't work anymore. So because of that, we support different kinds of encryption for different use cases, and you have to decide what you want, and what exactly your attack vector is.
Okay, we're going to shut this off. If you have a question for Frank, you could probably talk to him outside or go to the OpenSUSE booth. They'll be around. And if you want to learn how to install Nextcloud on one of the distributions, including OpenSUSE, Matt's up next. So
Yeah.
thanks, Frank.
So you have another talk tomorrow? Yes. Cool. Yeah. What time?
Okay, are we live? Can you hear me? Awesome. Okay, so my name's Matthew, and the purpose of this workshop is to walk through installing Nextcloud from a fresh install of OpenSUSE Leap 15 up to a running Nextcloud instance. I don't see very many laptops, so I'm guessing nobody wants to walk through it with me. We have an hour to do this, so if you have a VM or if you have a Leap laptop and you want to walk through it with me, we're just going to talk about the installation process. And it's going to be, just like I said, from a fresh install to a working server. So, as we're getting started, this is my first time giving this presentation. In fact, this is my first time giving any presentation. I am, whether you can tell or not, a bundle of nerves up here. So, okay, good, good. Yeah, so we're going to install the LAMP stack, and we're going to configure the database, and we're going to install Nextcloud. So that's what we're going to do. In order to do that, you're going to have to place a little bit of trust in me. And if you're going to trust somebody, then you really ought to know one thing, well, two things, and that's who are you and what gives you the right. So let's talk about who am I and what gives me the right. I said my name's Matthew McGraw. I'm a full-time dad. Those are my 3 kids right over there on the side. Little girl, little boy on top, and my big boy in the middle. This picture is unfortunately a couple years old, but I didn't have any with them all together that was newer. And of course, my other half is there as well. I have done some podcasting. I have contributed to Hacker Public Radio, if you're familiar with HPR. And I ran my own show called The Geek Dad Show, which I do post occasionally. The website is here at the bottom, norcalgeekdad.com. And I'm on Twitter, and I'm on Instagram, and I'm on Telegram, and I'm Geek Dad just about everywhere. Sometimes with the 3s and sometimes with the E's. It depends on what's available. Yeah, so feel free to follow me. If we get to the end and you have questions, I'm happy to communicate with you guys and do whatever I can to help you get an Nextcloud instance running. Okay, all right. So what gives me the right to come up here and stand in front of you and give you this information? And the most important thing is that it's open source. And one of the best things about open source is that anybody can dive in and learn something and then share it with other people. And I have been a volunteer at the Nextcloud booth here at SCaLE 3 different years. And I really enjoy talking to people about Nextcloud and what it can do to make your life better, solve your problems. If you've got something that we can solve, I want to help you try and do that. So I am not a developer. I'm not a contributor of code. And that's not really my wheelhouse. So if things mess up, I still use Google and try to figure out where I went wrong. I do run my own instance of Nextcloud. I run it on a DigitalOcean droplet. This is not an advertisement for DigitalOcean, but it's a great way to get started if you want to do that. They don't have a native OpenSUSE image yet, but they do allow custom images now. And so you can go on to the build service and get a QCOW2 image and upload it and then bootstrap your system that way. And I have done that 15, 20 times over the last couple of weeks as I've been walking through this talk, and it does work remarkably well. So Yeah. So, and also in doing this, I'm making some assumptions about you guys, and like it says, you're probably an OpenSUSE user if you're at OpenSUSE Summit. Right on. I'm actually a new convert to OpenSUSE. I've been running it on my laptop here for about 6 weeks, tumbleweed, and I really enjoy it. We're going to do some command line work in order to get this installed, so I'm assuming that you're somewhat comfortable with that. Thanks to Frank's wonderful talk that he gave before, I'm hoping you know what Nextcloud is, and that you're interested in leveraging it for your own use. I think those last two are the most important. Sometimes things don't go right the first time. So I've been through this talk, I've given it to myself and walked through the procedure, and it works. So I'm hoping it works today. and if it's not fun, then we're doing it wrong. So let's, we're going to skip what is Nextcloud anyway, because unless anybody has a question about what it is. Yes, sir, in the back. So you're asking about the VM image? Okay. The image, I don't have those numbers. I do know that when everything's installed, it will run off of a 16 gig Raspberry Pi SD card. That doesn't give you a lot of storage, but I have run it that way in terms of just having the LAMP stack installed and the Nextcloud app installed. I think that the image that I used on DigitalOcean was approximately 200 to 300 megs, I think. So it's not, I didn't start with a full install of Leap off the CD. I used the basic image. I'm sorry, I barely hear you. Oh, no, definitely not. Yeah. Oh, sure. Sure. So the question, thank you. The question was how much space do you need to allocate on your VM to run an OpenSUSE Leap bare bones plus the Nextcloud install, the LAMP stack. So, the final bit of his question, if I heard correctly, was will it be under 3 gigs? And there shouldn't be any problem with that. Obviously, your storage container or whatever you're using for your storage backing is going to have to be bigger than that, or that's all the amount of files you'll be able to store on the server. But as far as just running the application, that should be good. Okay. So this is where we started. This is where I started when I was starting this to research for this talk. It was a fresh install of Leap, and I used the JEOS, the Just Enough Operating System image of OpenSUSE. So the first thing I did was a good old zipper up to update the system, and I also added a command line web browser in W3M, wget, which we'll need for downloading the Nextcloud app, and the JEOS image doesn't include sudo. So if you're wanting to run a unprivileged user with escalation, you'll need to install sudo as well. If you need to create a user for your as an unprivileged user that you want to use escalation instead of running as root, it's a really simple user add -m, which will give you the skeleton files, and it will give you the home directory of the user and whatever the standard. It's usually a bash shell, and you're all set to go. When it comes to sudo, the default for leap in that file is for the user who is using sudo types root's password, not their own. If you're just running a single instance where you're the only person that needs to have escalated privileges, that's probably okay. But you probably don't want to hand out root's password to everybody if you're running it in a multi-user environment. So there's a couple of lines in the vi-sudo file that you delete. And if you want to search in the file, you're looking for the term target PW, T-A-R-G-E-T PW. And by default, OpenSUSE sets that target password to root. And if you delete those lines, then you have more control over who gets access to escalating the privileges. At that point, you're probably also going to want to add your user to the wheel group and uncomment the line that allows the wheel group to have privilege escalation. So that's how I would recommend doing it if you were doing it on a multi-user server. And yeah. So to get started, you log into your system and you're staring at that blinking black and white screen, or green, depending on how you set your terminal up. And so this is where we start. A lot of this is command line, and you're going to need escalated privileges. So if you have set up an unprivileged user and you don't want to keep typing sudo, obviously, if you do sudo space su, then you can switch into a super user mode until you exit out. So that's one way to get around it. If you're like me and you're scared, which I get scared when I'm entering commands because I don't want to erase my system or something, then you can type sudo every time, and that works just as well. So again, I'm assuming that you are installing this on a headless server or a VM where you're just at a console and not at a desktop with a terminal emulator. So YAST is your friend. And you can install it with Zypper, but one of the benefits I find to using YAST instead of Zypper at the command line is that you don't have to know the exact name of the package. So if you run YAST, then you get a search box, and you can type lamp, and it will show you on the screen lamp stack, and you click it and hit apply, and it will get that full stack. Obviously, Linux is already installed. Apache is the web server. MariaDB or Maria, I've heard it both ways. Anybody know what's official? Okay. I'm going to say Maria because that's what I always said. And PHP. And in Leap, the versions of these tools are fairly current. And I haven't had any problem installing and running the Nextcloud application on the tools from the repo. So you should be set to do that, and then obviously you're going to continue to do your updates as you maintain your server. So that's that step will take as long as your internet connection takes for you to download the packages and for YAST to run through all the installation. So the next thing that we do after that is we have to tell systemd that we've installed Apache. So that's we use the systemctl command, and we want to enable Apache 2 so that it starts on boot, but we don't want to have to reboot the system, so we're going to go ahead and start Apache. Yeah. That's the default when you install a lamp stack from OpenSUSE Leap. And if you want to install Apache and you want to install Postgres, or if you want to install Nginx and you want to install Postgres and you want to install PHP, as far as I know, Frank, correct me if I'm wrong, those tools work just fine. It's not an incompatibility. But for a new user that's just, maybe this is the first time you're setting up a web server, this is the default when you install LAMP from Leap. And so then the best thing to do after you have started a web server is to make sure that the web server is working. If you are running a VM on your laptop and you've got a graphical web browser and you can go to localhost in your browser, then that's great. But we installed W3M back at the beginning. So if you're just at the command line, you can type W3M space localhost, and it will pull up the Apache It Works page, and that's all it says. It's a blank page. It says It Works at the top. And if you see that, then you know you've got Apache running. Now, because of the way Leap handles the firewall, if you are not at the system you are installing on, and you're only SSH'd in, for example, then you're going to want to go ahead and run these firewall commands to open up port 80 and then restart the firewall rules, reload the firewall rules. I went round and round because I was doing this over SSH from my laptop to my home server, and I could not figure out for the life of me why Apache wasn't running, even though when I did a PS, it said it was running. And so I went round and round about that until I realized that SUSE basically denies everything through the firewall out of the gate. So as soon as you open up port 80, then you're usually good to go. Then we have to tell systemd about MariaDB. And so those two commands at the top, you'll notice, are the same. We enable it so that systemd knows to run it at boot, and then we start it so we can mess with it. And then this next step of the MySQL secure installation script, I would recommend doing it even if you're just running this on your laptop, in a VM, whatever, mostly to get in the habit. Because if you ever install it on a public-facing system, this is a great script to harden your database installation. Out of the box, Leap 15 does not set a password for the root user of the database. So it is root and an empty password line. So the very first thing that happens when you run MySQL secure installation is it asks you to set the root password. As you can see in bold type. Don't forget this password. It's possible to recover, but it's not pretty. It's not fun. And then basically you're going to just hit enter or Y through the rest of the script. What it's doing is it's removing the demo databases that are installed as an example. It deletes a unprivileged database user, and it flushes all your tables out so you're ready to start. And so if you run through that step, then you will have some initial hardening to your setup for security purposes. PHP modules are tricky sometimes. When Leap installs PHP, it's installing PHP 7 right now, and it installs a bunch of modules, but these are the 6 or 7 that when I got to the end of the install, Nextcloud complained that it didn't have access to these things. So, so these are the PHP modules that you may have to install separately. I don't know if Tumbleweed installs any of these. I didn't run through it on a Tumbleweed install. Just so you know, I should have mentioned this already. All the slides, the markdown, art assets and everything is going to be on my GitHub or available through my website. So if you're wanting to follow through this and you don't have a machine to do it today, you will have access to all of this information to do it at another time. So don't try to feel like you have to memorize all these or write them down. Excuse me. PHP MyAdmin is a great way, if you're not a database god, to add users and create databases. It just makes it easier, particularly for newbies. If you are a MySQL god and you can do this from the command line, go for it. What you need is a user, you need a database, and then the user has to be connected to the database. And I believe that if you know what you're doing with SQL commands, you can do that all in one line. But I can never remember how to do it, and PHP MyAdmin doesn't take up that much disk space, and it makes it just that much easier to create your users. So again, we're gonna create a user with a password. Again, do not forget this password. Yeah. On my instance that I use every day, my personal instance, which is on DigitalOcean, I don't have PHP MyAdmin installed. I don't know what all the steps are to hardening that particular attack vector. So maybe, you know, depending on your situation, your security level, you may not want to use PHP MyAdmin in this case. The first time I set this up was on shared hosting, and they had a cPanel plugin, and I could set up the database that way. So yeah, that's a good question, though. Thank you. So now we have our LAMP stack installed, and we have set up Apache to listen, and we have our database ready for data. Excuse me. And we have PHP ready to process. And the next thing to do now is actually get down to installing Nextcloud. So the version of Nextcloud in the repos for Leap 15 is Nextcloud 13. It is not current. Our current version is 15. You hear me now? Aha, there we go, much better. Yeah, go ahead. So you can, I believe it's available through the Open Build service. But if you are on Tumbleweed, then you are on, if you do a zipper in of Nextcloud, it installs version 15. So that's a little bit of a cheat, not cheat, but if you're willing to run Tumbleweed on your server, then you can just zipper install Nextcloud and get at least the base version. You may have to upgrade to the point release, but you can get the base version from zipper, just from the repos. But the other thing is, if you are setting this up on another operating system, the package archives are not always kept up to date, and the best way to get the freshest is to go straight to the source. Obviously, this URL, you're not going to be able to copy paste that because the version number changes, but you should be able to see it on the website to get the correct URL. So you can either download it through your browser, or you can use wget in the root of your web browser, web server, document root. and then it's just an unzip. And in OpenSUSE, the Apache user is www.run, and the group is www. So we want to do a change ownership to the whole directory recursively for Nextcloud, so that when we launch up our web browser, then the web server has permissions to read and write to the files that we need to configure and to run the application. And after you do that, then we need to restart Apache so that it is made aware of its new the files in the root there. There's one more step that is not not always recommend. I have seen people do demos and install tutorials, and they don't do this. This is something that I always do when I'm installing Nextcloud, and that is to move the data directory from outside your web server. If your when Nextcloud unzips, it's going to install a file folder in under the Nextcloud root. There's a folder called data, and that's where all your user data, all the stuff that you're syncing, all of your content that you're putting on your Nextcloud server is going to live in that data directory. If that data directory stays under your document root, there's a chance that somebody could exploit your web server and get access to that data. So I usually make a data directory in the root of the file system on the server. You can do it on your NAS, you can do it on your SAN, you can do it wherever you need to have that data stored, external drive, whatever. As long as it's mounted into your server, you can put the path in, and when we configure it in the next, I guess the next step, then I'll show you where you put that information in. So yeah, so we just create the directory, and then again change the ownership so that the web server has access to the files, or the web user, the Apache user, I should say. So after we do that, and we've unpacked the file, and we have restarted Apache, then we should be able to open up our browser and go to localhost or 192.168. Whatever your server is. By default, it goes into the /nextcloud directory under the root. So the web address will be mydomain.com/nextcloud. If you don't want to run it that way, you can copy all the files from the Nextcloud folder up one directory, and then you'll have it in your root of your web server. There are hidden files, so you want to make sure that however you move those files, whether it's through the command line or through a file manager, that you are taking all the files, including any hidden files that might be there. You can see I've circled in red here when you pull it up. That is where you're going to put the root or the path to that data directory that you created. You can see on here, this is where it is going to want to put it. It's going to want to put it in your document root, and then in the Nextcloud folder, and then that's where your data is going to be. So when you change it, like we did in the previous step, you want to be sure and change that at this stage as well. You're going to create an admin user. This is another thing that it kind of depends on your own personal philosophy and workflow. You can just create a user called admin or administrator. Probably not admin, because that's what everybody uses. So if somebody's going to try to bang on your box, then they're probably going to try to use the user admin. So you can make it webmaster, or you can make it administrator, or you can make it Nextcloud maniac. I don't care. But your very first user that you create is going to be the admin user for Nextcloud. And you're going to create a password. Remember this password. And then at the bottom, there's an option if you are running a really light system. When I run this on a Raspberry Pi, I don't usually use MariaDB or a MySQL clone. SQLite works if you're just doing small amounts of files like you might do on a home network. But for this installation, since we installed MariaDB, we're going to select that here. We're going to enter in our database user and password that we created earlier that we didn't forget, and the database name. I usually use Nextcloud and as the database user and the database name. I've not had any trouble doing that as long as I have KeePass generate me a nice long password. So then comes the moment of truth, right? We go right down there at the bottom and we hit finish setup, and hopefully this is what we see. And this is your first look at your Nextcloud instance. Got a little splash screen, and then the Files app is right behind there. And I don't remember which apps are in core, but I believe it's Files and Calendar and Contacts, and I don't remember. Is Gallery in core now? So it's going to install a few apps, because as you may remember, Nextcloud isn't just an app, it's also a platform. So we have open source contributors and Nextcloud developers that are creating additional functionality that you can plug right into your existing instance. I use the calendar and the contacts functions every day. I decided I didn't want Google to have my contacts and my calendar anymore, so I pulled everything out. I sync my Android smartphone right up to my Nextcloud instance, and it saves all of my contacts and my calendaring. There is functionality within the calendar app to subscribe to Google Calendars. I believe that there are some way to connect to Outlook. Is that right? Okay. Maybe not that. But it is running a full CardDAV and CalDAV server. So any applications that you have on the desktop or on your phone that operate through those protocols, you can sync your contacts and your calendaring through that. So like Thunderbird has a calendaring bit. There's several calendars for Android that also will connect up that way. So yeah, so hopefully that is a full installation ready to go. So are you talking about when you log in from a new? Yes. Right. So it's going to ask you to approve the domain or the IP address that you are serving it from. I've only ever run it on one server at a time. I haven't done any load balancing or anything like that. Sure. So yeah, that's a good point. His comment was about when you first log in the first time to Nextcloud, it's going to ask you to put in your admin username and password to verify that the domain name that you've typed in is the one you meant to type in. And so you're going to tell the system, yes, this is the name of this server, and I am approving that. So that is something that you have to do on a new install. And then after that, you can create users if you want to have multiple users. Users can be put into groups, so you can give access to different parts of the system based on what user group the users are placed in. and any of the users can be granted administrator privileges. So if you don't ever want to have to log in as admin again, you can give your daily user admin privileges, which is what I do since I'm the only user on the system. Excuse me. But if you were in a situation where you were going to have many users and you wanted to control access, then you could do all your admin work through the admin account and then parse out privileges to the other users depending on your use case. Nextcloud is all about syncing. So Frank mentioned a few of the different clients that are available. There are Windows, Mac, and Linux native desktop apps for syncing, and also Android and iOS. The apps that I've used the Android, the Linux, and the Mac apps, and they work flawlessly. I haven't had any trouble. I've heard people say that there's a lag time between when they hit save on their document and how soon it shows up on their server. And I have never had more than a couple seconds lag between the time I hit save on a document and the time that my sync icon in my system tray changes from a check mark to busy and then back to the check mark. So again, it's going to depend on your upload speed and how big the file is. But in terms of initiating the transfer, it's very fast, in my experience. And then, as I mentioned, it is an app platform. So you can go to apps.nextcloud.com and you can browse through personal information managers and media players. There is a way to run, one of my favorite apps to run is the Notes app. If you're a Evernote or Simple Note user and you like the functionality of being able to sync your notes, this is a great app to use. I have a desktop app on OpenSUSE called Q Own Notes, and it speaks to the Nextcloud Notes API, and so I can edit my notes on a desktop app and a native app on my desktop, and it will sync right up to my Nextcloud instance. And then I also have a Notes app a Nextcloud Notes app on my phone. So if I need to reference my grocery list or the meal menu that the kids and I made or the list of movies that I want to rent or borrow from the library, I can reference all those notes from my phone on the go, which is really nice. Anybody familiar with Apache for streaming music? Anyone? No? It is possible, depending on your bandwidth, to create your own self-hosted Spotify by installing the Apache app and any number of Apache clients from F-Droid or from the Google Play Store. I would assume iOS as well. I'm not an iOS user, so I don't know. But you can connect to your server and play the music that is stored on it, streaming over your network connection. Also to your desktop. It doesn't have to be your mobile device, but that's just another thing. And there are pages and pages of apps, and there are new ones being developed all the time. And it's very possible that you may find something that you didn't know you always needed, but you'll soon find maybe that you can't live without it. And then the last thing I would say is if you are running a public-facing or an internet-facing server, you have to do your Let's Encrypt, or be sure to apply your TLS certificates so that you have HTTPS, so that you have the encrypted file transfers that Frank was talking about in his talk. So I think that's it. Thank you for coming. Here's the link to my website. It's, of course, in blue, and you can't read it. It's norcalgeekdad.com/scale17x, all put together. you will find links there to the slide deck and the markdown and the icons, the OpenSUSE Summit that I borrowed off the OpenSUSE Summit website, and all of the assets that I used, including a link to my GitHub repository and a link to download a build of Just Enough OS Leap 15 that is in a QCOW2 format that you can upload directly to your hosting provider or boot directly through KVM or Zen on your local network. I have those things stored on Internet Archive, so you should be able to get to those without any trouble. And those links are available at that URL if you want to check them out. That's all I have. I am happy to answer questions if I can. Please come to the expo floor and come to the OpenSUSE/Nextcloud booth and feel free to chat more. If you go back to the hotel tonight or your house and you try this and it doesn't work, then come, let's talk about it. Are there any questions that haven't been asked? Mm-hmm. So I am one user on my server, and I don't use a lot of storage. I run it on their lowest level VPS, which is $5 a month. It's one processor and a gig of RAM and a terabyte of transfer. So if you're not uploading the family video library or your 2000 CD music collection, then you're probably not going to go over that. What I do, okay, we can all laugh at that. What I do is I also pay for 20 gigabytes additional block storage that's attached to my server, and that I just mount as a mount point through the Nextcloud interface, and it handles that no problem. I like to store my podcast files up there so that they're not taking up room on my hard drive. And I don't sync those to all the machines. That's something else. I don't know if Frank mentioned during his talk. Another really cool thing about the desktop sync client, at least I've seen on Linux and Mac, is that you can do some granularity in what you're syncing. So for example, on my ThinkPad, I sync my whole directory, I sync the whole server except for that podcast folder. On my netbook, I sync my documents folder and some photographs and some SSH keys so that I can set up new systems. But I don't have to sync the whole thing. I can have some granularity over which folders, subfolders of my instance I want to sync to which device. The other nice thing about the Android client is that it will browse your file system, but it won't download anything until you tell it to. So if you want to have access to your files on your mobile device and you don't want to take up all the storage space on your mobile device, you can browse through your subfolders, find the song or the movie or the document or whatever that you want to have on your device and download it at that time. I believe that same functionality is coming to the desktop client so that you don't have to sync your entire instance to still be able to browse the whole thing and download it as needed. Is that right? Okay. So that's coming to the desktop client as well. Anything else? Yeah. I'm sorry? Oh, yes. Yep. Yes. Right. So the comment was, for the benefit of the video, that that you don't have to just use the local storage on your server. You can mount in Dropbox, I believe. You can mount in Google Drive, AWS, SharePoint. Yeah. So you can mount in all these different storage backends, not to mention FTP, SFTP, Samba. You can mount all these different storage solutions onto your instance, and Nextcloud just treats it like storage. That's another thing that Frank was mentioning when he was talking about crypto at the end, is if you already pay Dropbox for hundreds of gigs of storage and your concern is, I don't want to be responsible for managing all the backups, and I like the convenience of being able to use Dropbox's servers and not mine, you can utilize the encryption client side or even through the Nextcloud server, and what you end up storing on Dropbox's servers is fully encrypted blobs that they couldn't read even if they wanted to. And that's true for any of the storage options, I believe, that you can mount into Nextcloud. You can store, it'll treat that storage like dumb storage and just store encrypted data on it. And so if you already have existing infrastructure, you can mount that right in and utilize it that way. And then, yeah, you can have you have WebDAV access to your files. So if you don't want to run the sync client, but you've got a Windows machine and you want to mount a web folder through the file manager, you can do that directly onto your instance. So it's super convenient, it's super robust, and it's a lot of fun to play with, and it's a lot of fun to know that you're hosting your data and not Google or Apple or Amazon, unless that's where you choose to store your stuff. Anything else? All right. Well, thank you guys for coming and muddling through it with me. I appreciate it.